Hello everyone, welcome to this machine learning A to Z Kaggle and real world projects. In this course, we have added some real-time projects as well as few Kaggle problem solutions so that you can further go ahead and can solve any problem in the competitive world. The motivation of this particular lecture is to give you an idea that what all is expected out of you before you can do this course and what are the prerequisite probably you need to go back and revise. So this course is going to help you with all that section. So right now you would notice that we have multiple projects. Like you can see that we are saying that project 1, this is basically coming from Kaggle. Project 2, this is coming from real world problem, which is going to be some industry related problem and we are going to solve it. Similarly, you would notice that there will be few Kaggle and few real world projects. We are going to add even more project to this because we would like to increase this project number as and when we will go ahead with this, and you will notice more of the Kaggle solutions coming up for you. Now, how this is going to be helpful for you? If you have this dream that you want to go and even personally work in Kaggle, you want to also just showcase your skill set, you want to strengthen all the knowledge by solving some problem in Kaggle, then this course will be very much suitable for you because this will give you all the idea and requirement that what all things you need, how people approach this problem, what all things you need to read from outside whenever required. Not only that, even when you will go and join any industry, then also this course will help you out that in what way the data scientists on daily basis are solving their problems, what kind of problem they are facing, what is the solution they are posting for them. All these things we are going to learn as a part of this course. Now, one expectation from my end would be that when you're looking at any problem, please do not directly jump and look at the solution. Always first try to solve that problem on your own. It may be it's going to take some time because all the projects, especially which are coming from Kaggle, they are time taking projects. So you have to spend some good time in exploring that. But once you do it on your own, then only you will be feeling more confident when you will look at the solution. So your learning will be far better comparatively. Now, the prerequisite for this particular course, definitely we are going to expect that you should already be having all the machine learning language. So that is something you should be aware of, all the algorithms, everything you should be well aware of. This course will be completely in Python. So when I say machine learning, so even if you're coming from R background, it is not going to much impact you because it's more about the knowledge which you will be gaining from it. So it's not going to impact. Maybe if you're coming from R background, R language background, you can always go back and convert this code to R language. That's something you can always do. But knowledge of ML is must. One suggestion which I can give you out is you can look at our course which is called as Machine Learning A to Z Become Kaggle Master. This course, you can use it as a prerequisite course. Once you complete it, you will be all good to come and start solving these particular problems in the further course. So I can say that this course is like an extension of that particular course. Now, so this is all it which I want to mention. So best of luck now. So you have to start looking one by one. And also one more suggestion I do have is please solve all these projects in a sequential manner. Because you will notice that I might have given a lot of explanation in maybe project 1 and I have used all that concept in project 2 or project 3. So there's a possibility of that. So that's the reason my high recommendation would be that if you can solve all this problem in the sequential order, that will really make your life a lot simpler. In this case study, we are going to work on a medical problem. This is a real problem which was faced into the medical industry. And in fact, this problem was posted on Kaggle, uh, so that all the data scientists can come and basically try to come up with a solution. So we are very thankful for this institute to provide us the real data set so that we can use it for research and development and for our learning purpose. In this problem statement, basically a lot of manual efforts was happening earlier, and they wanted to replace it with machine learning automation. And we will learn that how to do it, and we will take step by step for doing so. When I say step by step, we are going to work as a complete data science uh, person, where we are going to start this problem from analyzing the data, cleaning up the data, thinking about how to even give a kickstart to a machine learning problem, identifying appropriate solution for it, and then working on it. And remember, it's a real data set, so there are definitely few issues which we have to tackle here. Let's understand the problem statement first. So since this problem is from Kaggle, let me take you directly to the Kaggle page, and just to make it appropriate, I have given you the Kaggle link from where you can directly go and understand the problem statement. But I'm going to give you the whole explanation for it. Now, to solve this problem, you definitely don't need to be an expert into medical side. Even I have no experience in medical domain, and whatever I have learned is just to solve this particular problem. So even this is a very common thing which gonna come as a machine learning engineer, that you may not be an expert into a domain, but you are still solving that problem of that domain. So this is quite interesting about this machine learning journey. Now, let's understand that what is this problem statement and how is being solved. Now, as you can see that this problem is provided to you by this Memorial Slogan Cancer Center, MSKCC. This is a very famous kind of center basically into the medical domain, and this was even accepted in NIPS 2017. So it's a very famous part. And this problem also had an award, like whoever is going to give them the best solution, they were awarding that particular candidate with 15,000 US dollar. Right? So this will also enable you to kind of go and even target these Kaggle competitions later. What I mean is that um, if once you solve all of our case studies, because what I am gonna do is I'm gonna give you both the side, how a problem is usually being looked at in the industry and how a problem is being looked at from a Kaggle point of view. So you should know the real difference between them, because definitely Kaggle being a competition, there will be some sort of criteria based on which you have to provide your solution, so that it will make the life of Kaggle people easy to identify who is the winner or who is not, right? So, but in real world, that's not the case. It goes in a little different variation, and I'm going to give you all those insight while working on the solution, so that you get an idea that how this differentiation also comes in terms of solving a Kaggle problem and solving the real world problem when you work in a corporate world. So to start with, so if you look at this problem statement, so what happens is we do have something called as gene. Okay, so there is something called as gene, which is, you might be hearing this from your biology term if you do remember your biology course, that you may have a gene sequence with you. Now, in every gene, if there is any variation which gonna happen, so this can lead to any sort of cancer. Okay, now definitely it's not mandatory that all the tumor is going to be kind of a cancerous type, but definitely it can have some sort of cancer. And in this problem statements, let's say we are taking the 9 classes of those cancer, which is going to be from 1 to 9, okay, or 0 to 8, sorry, basically whichever way you want to take out. So this is going to be the class of my cancer. Now, what happens is we do have basically the pathologist who is aware of a lot of genes and their variations, and they know about, okay, this, if this is the gene, this is the variation, then this basically belongs to this cancer tumor. But what happens is there are thousands of mutations possible. Now, with respect to this, the challenge is that there is a lot of research paper being available for each variation for each gene, right? So now for each gene itself, there will be a lot of variations possible. Now, what happens is there will be a lot of research paper being available for you, and from those research paper, what pathologists have to do, when I say pathologist, I'm talking about a domain expert. Okay, I'm referring to a domain expert who have to, let's say, look at, let's say a gene is there and a new variation comes up. So that domain expert have to go and read a lot of text, a lot of research paper, and from that they kind of go ahead and identify that, okay, this belongs to maybe this sort of cancer. And this is actually happening in real world. Actually, pathologists are spending a lot of time in kind of getting the answer of, okay, where this is going to belong to. And that was the main challenge. Now, it's very easy to get all those research paper because you can go on Google and just type, okay, this is the gene, this is variation, and you will get a lot of research text about it. So collecting the data is never an issue, but going through all those research text and then basically getting to an answer that, okay, this belongs to this probably cancer class, is very difficult, because then you have to spend a lot of time, enormous amount of time in going through it. Now, this is where we want to bring our machine learning in. What we want to do is we want to replace that manual process of that domain expert with our machine learning. Now, this is actually what the main trouble they this basically particular center want to solve, and that's the reason they wanted to make it as a competition, so that if anybody gives maybe the best solution, they might want to use that particular solution for basically for their future purpose. So that's what we have to solve. And the funny thing about this whole solution case study would be that we have no idea, including myself, that what is this medical domain. We will not even be having any idea about what is this gene thing, what is this variation, what is this research paper talking all about. You may not be able to even understand if you will try to go through each and every detail of the text, but still you will be able to automate and will be able to give the answer that yes, if this is the particular thing, that then I will create a algorithm or a machine learning model which will tell me up, okay, this belongs to this class. And thus you can imagine that how much of the time you're going to save while doing so. So this is a very fun problem, and we're gonna understand it from the machine learning point of view as well, that we will try to understand that, okay, how this is gonna fit in from a machine learning criteria point of view, and what exactly we need to solve it, where does this fit in. Everything we are going to talk in detail in the next video. So now we're gonna move to linear SVM. Linear SVMs are very similar to what you have with the logistic one. So in fact, let me note down, this is linear SVM. Now, we are not going for RBF SVM because first of all, we don't know the kernel here. And if you use RBF, they are not very interpretable. So as per our business requirement, we want the interpretable result. So in that case, we will not be able to go with respect to kernel SVM part. So let's keep it linear, and that's going to be very similar to logistic regression. Only the loss function get changed from your logistic to basically hinge loss. So that's going to be the only difference. So let's see that if we just change this loss function, is it going to have any impact here? Now, if you look at this, again, we can go with one hot encoding, because since it's just like linear, so it's also going to work quite well even if you have a huge dimension data. So we will go with respect to this, and you can notice here that again we are getting for 0.01, we are going to get the minimal loss. You can see that 0.01 we are getting the minimal loss in this case, which is 1.13. Remaining are very high. Now once we put this value, we got the log losses, and also we also got all this train test loss. So I've just put every code into one container here. So here my train loss is coming as 0.74. So let me note down, 0.74 is my train loss. Now further to this, let's look at my CV loss, which is 1.13 and 1.14. So here I have 1.13 and 1.14. Let's look at the classification error. So my classification error is going to come out to be 34.21. So let's go back, 34.21. So here you can see my log loss have gone high, right? So that was my main criteria. Yeah, definitely you can see that this have gone low, but at the same time my log loss have gone little higher. So I would still not consider it for my final step, though it is not bad in terms of classification if you see that, but still for log loss even for 0.01 it may have a good impact. So let's go and check the confusion matrix. So this is my confusion matrix using which we have anyway got our accuracy and all that. Now with the precision recall, you can see that values are higher again, but yeah, there are some confusion points which have gone here, right? So you can see here that now the confusion is between 1 and 4, but it's not that huge. Even from recall, you can see that we do have confusion between 2 and 8 and 4 and 9. This remains the same. So now after that, let's classify some points. So when I classified for 7 and 7, you can see again the probability comes out to be pretty high for this. That's the reason we are choosing this up. And this is also an interpretable model, and that's what we are getting in our output. So this is again an interpretable model output what we got. Now further to this, we will look at random forest. Now let's talk about the random forest point in the next lecture. Okay, so in the last lecture we were talking about random forest with one hot encoding, and we have already seen that when we got the best hyperparameter, there were two hyperparameters, one is depth and second is estimator. And then further to this, we got our training and test losses. Now we were also looking at the misclassified point, which got around 0.38. So let's go and put that. So there were two values. So here we're gonna keep it 0.38. So this number have also increased, right? But definitely this is not doing that well when we compare it with respect to other model. That's surprising, but yes, it's not working. Now let's come back and see a few more things here that now basically we will calculate the confusion matrix and all, and again you can see that there will be few confusions, but other than that it's all same. Now it's very simple way to basically for you to go back and look at this precision and recall. I'm not going for every kind of explanation on this because it's quite simple now. Then further to this, we can also look at the classification points, and you can see here that we have correctly classified this, and the reason is again the probability was 60.4%. Again, when we say about random forest, it's quite good in terms of interpretability, so we are getting a nice interpretation about our results as well. Now what we're gonna do, we're gonna follow the same random forest, but this time with the response coding, and let's see the results what's gonna come out to be. Again we're gonna get the hyperparameters. Once we got the hyperparameters, we will get the log loss and all that. So let's put it. So train loss is coming as 0.05. So let's put it 0.05. This is random forest for response encoding. So 0. This is quite low, right? So let's go back and see whether what's the further result. Now this is 1.2 and 1.3. Okay, immediately reject this model. Reason being, you can easily see that 0.05 and 1.2, there's a huge difference between them. That means there's a huge overfitting which have happened in this case. So definitely this model is not good, but let's still see that what is the value of classification we're gonna get. So let's go back and see it. So it's coming as 48.68%, which is again bad, right? 48.68. So again, this is telling me up that again this is a worst model which we have seen till now, and random forest is definitely not working good. Not even for one hot encoding, but response encoding was even worst. So this is how we can see this part, and further to this, again we can look at this matrix part, and we can again classify and do the interpretation with this. So this is how you can kind of look at and basically get your interpretability and get your query point classified. Now this is interesting, right? So we got a good table with almost all the algorithms which are available. We will still do one or two more things, but we have almost covered up all the algorithms, and few places I've gone with one hot encoders, few places I've gone with response coding. I would like to give you as a homework activity to get this even more better. I would suggest you to please go through it and try it wherever I have tried only with one-hot encoder. Please try to do it with response coding. Try to create a table. Keep writing all those things with you, and same way keep on doing for all the algorithms like that, and see what the results comes out to be. Right. So I have just chosen whichever I feel is the best, just to show you up that how it behaves. So this is the way we gonna get the results till now. So great. In that case, let's connect in the next lecture for one more further thing. Okay, so now we're gonna build the stacking model. So this is also one of the is ensembling method which you might have learned during your machine learning courses. Now, in order to talk about this ensembling methods and all, what you do is, let's say you generated three different models, M1, M2, M3. And using those models, you gonna generate, basically you're gonna put this output to another model, maybe LR, and then get the output. So this is how basically we do it. But there are some problem with this. So when we generate these models, we don't take the whole data set. We take the subset of data set D dash. So we do take different data sets, so it works. Now the problem with this particular code is, though this basically this is called a stacking method. Okay. Now this stacking method works very well if you have a huge amount of data. But if you do have a very small amount of data like we have in this case, this may not work that well. So that's basically the problem with this. So since here we do have a small data, maybe the stacking model will not give us a good result. So you can see here that here basically we got the we are taking basically some models, and you can see here that I'm only taking my SVM because I'm taking the loss as hinge loss, and I'm taking another part which is basically my naive Bayes, and I'm doing all these things on one hot encoding. You can always feel free to do it on response encoding. So you can see here that we have chosen basically 2-3 models, and one is we have also chosen logistic regression. So logistic regression, linear SVM, and naive Bayes. These are the three things models we have built, M1, M2, M3, and after that we are going to build our stacking model. So this is quite simple, and once we got this, we can just look at our final log losses. So definitely you can see here that it is coming at 0.35, which is not that good if we compare with our older one. So if we go back and look at this, we already have got lesser than basically 0.35. We already have the KNN which is giving us, and at the same time if we also go back and look at the log losses, so log loss is also coming at 1.11 on CV and 1.1 on this, right? So if you go back and compare, so definitely it is more in comparison to my these two loss. So I need not write it in my table now, because as I can easily see that it is not performing well, and that is what we were expecting also before, right? Because if you look at these log losses, definitely these log loss is not going to come to be good, because the reason is the data was kind of smaller in this particular case study. Now there is one more thing to look at after this. So once we have done this, we can also see the maximum voting classifier. As the name states, that it looks at, let's say you create 3 models, and from 3 models whichever the log loss is going to be minimal, you're going to choose it. So that's a technique what it use. And again here you can see that we're gonna log loss like 0.19, but again you can see that my log loss is pretty high on the test set, 1.20. So this is again going to be very high, because we already have got 1.06, which is the minimal with us. And even if you look at the cross validation errors and all, this is also going to be higher. You can see that 0.35, let's put this value 0.35, but we do have already lower value than this, right? So we need not again put this into this. So again, if we have to decide the clear winner, again we have to take a call now based on our evaluation criteria. So by the evaluation criteria, we should go for LR, which is one hot encoding with balancing, because we are getting 1.06 as my lowest value in this case, right? So it depends. If we are looking for accuracy, then my answer may change to KNN, because that is giving me 33.83. So it again depends on case to case. So like when we talk about, let's say, and when we talk about competitions like Kaggle, then in those cases we all kind of only target with respect to one parameter which we want. So there will be, you if you look at a leaderboard, somebody will have 1.07, somebody will have 1.08, somebody will have 1.06, like that. Okay, so whichever is going to be the minimal is going to be the winner. So that's how basically it works there. So with the testing data, they always look at and just kind of keep working on minimizing this parameter and see if they can basically win those competitions. This is how it works. But at the same time, what we have done in this exercise is very minimal. To be really frank, you can also do a lot of stuff. For example, on the text data which we have looked at, we very quickly kind of went to bag of words, right? We just used the const vectorizer and kept on working on that technique. But definitely you have so many things, like you could have gone to TF-IDF, you could have done so many other ways of splitting this data. Even the models what we have used some model with a basically response coding, some model we have gone for one hot encoder, though it is going to work in the same way. But still you can go ahead and even build those models with all the ways possible and see that which is going to perform better. So all these things you can anyway try. This was our attempt to give you an insight that how you can basically play with these kind of algorithms and basically come up with some solution, and even can target Kaggle competitions like this. But in real world case, if you're talking about, definitely you're not going to run behind just one matrix. That's the reason I have also taken the misclassified point for you, so that because in real world even the accuracy matters a lot. So in those cases we will be looking at the other stuff and do it. So in this case maybe we can give linear regression with balancing and say that okay, you can go ahead and use this into your production system, right? So this is the final output with this. So I hope you had a good learning with this particular project. Please give a good attempt to it. Please look at all the interpretability code which I have not explained in detail line by line, but definitely from your machine learning courses you might have already an insight how to do it up. If you feel that you have a better solution, please do it, and even let other people know. That's something which will also encourage. The main idea was to give you a good insight how to approach these problems, what are the parameters we look at, even what are the optimization technique we do, what are how to play with these hyperparameters. So these were the main motivation to look at this particular project. Thank you. Okay, so now once we got the understanding about the data, now let's understand that what kind of problem we are trying to solve here. So we are interested in predicting about the class, right? So the class will be between 1 to 9. So it can be 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have just got this value by looking at the unique values from the class column. Now, if you look at it, this is a discrete output, right? As soon as we see that it's a discrete output, we say that it's a classification problem. Now the second question is it a binary classification problem? No, because in binary classification problem we can have possibly only two outputs, and here we have more than two outputs. So this kind of thing is called as multi-class classification problem. So we are actually trying to solve a multi-class classification problem, and that's what the prediction model we are going to build here. Now let's try to understand that from the real world perspective, what are the things really important for us while building our model. So what are the things we need to keep in mind while trying to build this model. So number one thing, so when we are trying to build this model, definitely it's a medical problem. Now in medical problems the errors can be very costly. Imagine there's a patient coming to a doctor, and a doctor tells him up by looking at maybe his gene and the variant, well, basically mutation, and tell him that okay, most likely you have this cancer, you are in this cancer stage or whatever. Now, and if his answer is wrong, that imagine what's gonna be the impact on that patient. He may even sue the doctor. So the errors are going to be very costly. So we cannot afford errors. We have to make sure that we do take care of that error component to bring it very low. So my accuracy is going to be highly important here. So in this case, we may want to return the result in terms of probability, because if you think about this, maybe we only want to give an answer in terms of yes to a patient, that yes, this looks like to be more appropriate answer here. So we may want to put a probability to it. Let's say if the probability of my answer that okay, most likely you are going to have this sort of cancer in, let's say, category 3, is, let's say, if I'm telling that with, let's say, 99% probability, I'm more confidently I can say that yeah, you have basically, let's say, type 1 or type 2 or type 3. So we can tell it like probability that you are falling into class 3, and basically given that you have x1 is your input, right? So x1 is nothing but you have your gene and you have your variance of this sort, or maybe the research paper for this variance is this, because we can easily get that research paper information from Google. So my gene and variance is this. So given this information, then if my, let's say, probability is coming out to be, let's say, 0.99, which is 99%, we can very confidently say that yes, you have possibly this sort of problem. But let's say if this is not coming out to be 0.99, but it is, let's say, 0. Maybe let's say 0.4 or 0.5 or 0.6, something like that, right? Now in this case we are not really very confident on our answer, because if you look at the answer now, though this 0.5 may be a higher number in comparison to the other 8 classes, because maybe the other 8 classes might have 0.1, 0.02, 0.05, like this, which is contributing to the remaining probability. But still this number is ambiguous, or there is a possibility that maybe for if I look at this, maybe I'm getting a probability of basically y belonging to class 3, as where the input is x1 is 0.6. Maybe there's another probability of class 2 which is given this x1 coming out to be 0.4, and maybe the remaining all the probabilities are 0. So here also it's an ambiguity that where we should place it in, whether we should look forward for whether we can tell to the patient that you belong to class 3 category, or whether you belong to class 2 category. So maybe in this case we may want to look at more evidence to give some basically final solution to my client. So so that's the reason I think the probability will be very important factor here. So in order to be more confident to avoid the error, we will be looking at our solution with respect to probability in this case. Okay. Now, one more thing which we can attach to build more confidence to is maybe telling the basically the reason. If my algorithm can even reason out this very well, that most likely if I'm telling to my patient that okay, you have class 3, then these are the evidence for it. I'm telling basically the reason that why I'm telling you that you belong to class 3. Maybe there may be few terms which I can use and say that okay, since you are falling with this thing, that's the reason you are falling into class 3 category. So what does this mean? Means interpretability. Can my machine learning algorithm also tell that why it thinks that it belongs to class 3? So there are various algorithms which can help us in answering that. So there are few algorithms which basically tells those answers, and there are few algorithms which do not tell those answers also. So there are both sides of stories. We will see to that what are those algorithms which are good. For example, if I talk about your RBF, and basically I'm talking about SVM, this is highly non-interpretable. So if we have done a machine learning course, you might have learned it, but if not, we will go through some of the case studies and you can see that how it is not or how it is. And similarly, if I talk about a lot of other algorithms, for example, if I say naive Bayes, if we say decision tree, we say logistic regression, even linear SVM, right? So these are highly interpretable algorithms. These also can return you that if there is some sort of prediction happening, then why that prediction is making sense. So those sort of things also it can return. So it's very important for us to basically tell an interpretation of behind my prediction. That's is very important part which we want to also solve. Now, talking about the latency or time taken to return a result. Now, definitely, since I want to reduce the error, so maybe I can give some flexibility to the time part. My algorithm may take, if my algorithm is taking, let's say, a few seconds or few minutes to give an answer, I might be okay with that. yeah, if my algorithm start taking maybe an hour, then it's might be an issue, right? Oh, sorry, 1 day, then it might be an issue, right? So it depends on my business requirement as well here. But most likely, I would be okay if my time taken by that algorithm is okay. Means if it is reasonably kind of manageable, I'm okay with that. Maybe like if you think about like companies like search engines, right? Internet companies like Google. Now, there basically the time is a very critical factor. If you say something, they want to immediately get an answer and give the output to you. The prediction algorithm required a very fast latency should be very low. But here, I don't want my latency to be that low. It's okay if I take some time. So that's also one thing we can keep in mind while building models, because there are some machine learning algorithms which do take a lot of time when the data is huge, which you might have also learned during your course, like KNN algorithms and all that, which do take a lot of memory, which do take a lot of time. Basically, in terms of if you look at the order of complexity of those algorithms, it is high. But maybe in this case, in this particular kind of case study, maybe they fit quite well. We will see that if they really fit or not. But maybe if they take a little bit of extra time, I might be okay with that time frame. So that's also one thing which we have. And I have written all these points in detail for you to again go back and revise if you wish to. So these are the things which I just explained it to you. Now, it's highly recommended that before you start looking at this solution further, I have given you a detailed explanation about the problem, about a data set in machine learning, how it fits in terms of we are going to solve a multi-class classification problem. And even we understood that from the machine learning points, what are the important factors we need to keep in mind while solving this. So given all this knowledge, can you go ahead on your own and see that if you can come up with a solution on your own? I would highly recommend to pause it here. Don't go ahead and try to solve this now problem on your own, and later come back and start looking at the solution and enjoy it, right? So then you will realize that, okay, what are the things you were missing out, and then you can anytime come back and look at the things and start working on that. So with this, best of luck for all of you who are solving this case study, for solving it first on your own and then match up a solution. Thank you. Now, I hope all of you have already gave a good attempt before looking at the solution. But now let me explain you that what my solution is, and definitely your solution might be quite different, and maybe you have come up with a better solution than me. Uh, in fact, if you have it, you are welcome to post it on the discussion forums and all that, so that even others can take the benefit out of it, or even I can answer to your response. It would be a great thing for others to, even for myself to learn. uh, so let's look at it, but I can tell you that this solution is also kind of a leaderboard solution, so this is a good solution to look at. Now, here, basically, if you look at this, we definitely, once we get the data, if we have to first bring it to a form that my machine learning algorithm can understand it and can work on it. Now, there is a problem. Problem is we do have, if you remember my data, we do have a text data, right? So if you do remember, we have even loaded this file, right? We have ID comma text, and I told you that this text is nothing but like a research paper. Can you see that? It's a huge text kind of research paper kind of thing. Now I cannot feed in this kind of paragraph kind of text to my machine learning algorithm. So if you have gone through the sections of NLP, basically in machine learning topic, you might have learned that how to process it. So we are going to use that. So we need to convert it to a format so that my machine learning algorithm will be able to deal it. So before that, we definitely would like to make sure that my data first come into a format. So we need to do some processing on it. Now, which will include few things. For example, if you look at this text data, there's a you can see that I do have let's say some lot of numbers. Maybe I don't need them. These numbers are not required. Even I might have a lot of like is, and, in, the, or what I will do with this word. These words may not be much relevant, so these are called as stop words. Maybe I would like to remove them up. They will be, since it's a research paper text, there's a possibility that maybe somebody have, instead of giving one space here, he might have given two spaces, or maybe he have pressed the tab. So those things also might not be that really important for me, right? So if I look at it, there may be various places where we may want to remove all those unnecessary portion which may not be relevant for my final analysis. So that's what we're going to do that. So in order to do that, we have first written a function which will help us to process once we pass this text data. Now, as you can see that this text data uh, is kind of huge. So when we will run our function, it will take some time. Okay, so you have to be a little patient on that part. So let's go back and see to this, that what we have to do. So number one thing is that we have used this NLTK library to got all the English stop words, because my research paper, which was in text format, is basically in English characters. So that's the reason we got all the is and a, the kind of words, because we definitely would like to get rid of it. So we have written a data text process function, and you can see that I'm going to call this function where I'm going to pass basically the text column. And basically here what all we are doing is we are looking at if it is a string, means it's not an integer, because as we've just learned, maybe that 2.2, 3.4, those numbers may not make much sense in terms of my final output. So that's the reason if we are looking at that, then first thing is we are interested only, let's say, in this. So we are going to basically replace all the special characters and all that, because definitely those things also we don't need. If we do have special characters, it's of no impact at the rate what it will do to my final analysis. So similarly, if we have like multiple spaces, like I just explained you, if you have tabs or double spaces, we would like to remove them up, right? So we are replacing that with a single space, the tab with a single space, so that everything comes to a normal format. And we also have to do this. Yeah, it's very, sometimes it do happens that somebody have written, let's say, something like gene like this, and somebody else might have written gene like this, but they both are same, right? So in order to bring them in the same scale, we will lowercase or uppercase the whole text, so that now everything comes to a same scale. So that's one thing we can again do here. So we will do it with the lowercase. Then further to that, we gonna split to each word and gonna make sure that we do not consider stop words like a and the. So we are going to remove all of them here, right, in this particular function. And in the end, we are going to return it, and that now my final text is going to be my pre-processed string, which we really needed. So this two code is basically doing that. So I have given the proper comments and all that here, so that you don't face any difficulty in understanding this particular function. So do not worry about that. You can anytime go back and just play with this particular code. Now then after that, we definitely need a final data frame, which is going to be a merging of the data frames of both sides, because if you remember that ID column was common between both of them. So I'm gonna merge it with respect to ID column now. So I'm gonna do basically this part on ID column, and you can see that now I got a data set which have gene, variation, class, and this text. And this text definitely going to be huge, though it's not showing up here. Now the next thing is we definitely want to look at if we do have any missing data, because missing data can impact our analysis a lot. So we have to make sure that the data which we have is in appropriate format, which we can use it. So we may want to make some decisions if we notice that we do have some missing values. So now we can see here that yes, we do have some missing values when we hit this line of code. Almost there are 5 rows which have missing values. Now what to do with this missing rows, right? So one idea could be that you can just go ahead and remove those rows, because they are very less in number, but we do have a very small data. If we have some 3000 plus rows, it's not really a huge data with us at the moment. Now in this case, we may want to come up with a better idea. Can we do some sort of imputation here? Imputation means that can I replace this nan with some more appropriate values? Now what can be that appropriate value if we want to do that? So in this case, one idea could be that we can just take up the gene of that row, and the variation means, let's say this is nan here. So we will just replace it with the concatenation value of this gene and this variance. So that's what we have decided. Again, this strategy is completely up to you to decide. You can take your own call. If you want, maybe you want to remove those rows, or you may want to come up with a different imputation strategy, please feel free to do that. This is just one of the strategy I've taken, but it doesn't restrict you from taking any other strategy. Feel free to take any other strategy as well. And after you have done this imputation, again you can have a check that whether you still have any missing value. And you can see that since this is got properly imputed, now there is no missing values left with us. So we can definitely go ahead and start working on our further analysis. Now, once we have done that missing value imputation, the next step is to work on splitting this data into training, test, and validation part. Now, this is really important because if we build the whole model just based on the basically on the whole data, then there is no way that we can validate it. Now, one idea could be that we can just go ahead and create a training set and testing set, which you might have learned in a machine learning course, and create a model on training set and test it on a test it on the testing set. Now, this is also sometimes not a good idea because a lot of times, especially when we play with hyperparameter tunings, we do kind of we do get the results which comes out because of my test data set. And because we start looking at the test set and we start keep on improving the accuracy on my train set, so we kind of start getting a dependency on the test set part. Now, in order to handle that, we come up with a validation set. So what we start saying is that we can split now the data into three parts rather than two parts. And those three parts is going to be like, we're gonna create one part for my training set, second part for my cross validation set, and the third part for my testing set. Now, what we're gonna do, we're gonna build and verify our model with the help of these two. Okay, think of cross validation as the test set only. Now, here with the train set, we're gonna build our model, and with the cross validation, we gonna do the hyperparameter tuning and all that, and we'll see that what is the best parameters or metric we're gonna get out of it. And once we get this, then once we have the final model based on the testing of cross validation, then this is completely untouched data. We have not yet used it for anywhere. So we will finally validate our model output with this test set. So that's what we are going to follow in this particular case study. Now, the first question is which is going to come to your mind, that how should split this data. So there are various ways people go for it. Some people take it like 60-20-20. Some people take it like 70-10. So basically 70-10 and 20. Depends on you how you want to take up. Depends on how much data also you have. What I have taken in this case study is that I have first divided it into 80 and 20, and this 80 again I have divided into 80% and 20%. So which brings us to kind of this sort of data. So this cross validation will be 20% of this 80. So that's what basically how we gonna divide it. So first we gonna write a code which is going to help me to convert into train and test, which is 80-20. And then again on that train data set we will again do a split on 80-20, and that 20 we will give it to cross validation, and 80 we will give to our training data. So that's what the strategy we're gonna adopt. So let's see how we have done that. Now, in order to do this, what we have done, you can see that I'm using this train test split function, which is gonna first divide it into 80-20, and this is gonna return me train and test data. Then further to that, we are going to use this train data and again gonna do a split of 20. So we gonna get the cross validation data now, right? So we got three set of data. One is cross validation, testing data, and training data. So three kind of data what we got. And if you want to look at that how many rows and columns you do have now, you can always look at it by saying shape, and this is going to tell you that in your training data you have some 2124 records. In your test data you do have 665 records, and your validation data have 532 rows. So this is how we can see our data. Now, it's very important point that when we do this splitting, now we always want to see that the data distribution have happened kind of properly. Because we can end up with a lot of issues if we don't have. Imagine I have taken a training set, okay, which because if you look at it, I have classes from 1 to 9, right? Now there is a possibility that in my training set, I have taken all the data for my, let's say, class 1, okay? I have taken all the data of training here. But in my test and cross validation, I have no rows left out because it's a random splitting. So maybe there's a possibility that in my cross validation and test, we have no data related to class 1. So there is no way to even go and verify whether my model, which is bringing this class 1, is good or not. So now this can be an issue here, right? So we definitely want to make sure that the distribution have happened appropriately, and that's what we're going to look at. Second kind of problem could be that maybe there is a class 7 which may be not at all present in my train set, or very less amount of data have gone here, and more data is going in my test and my cross validation. So in this case, we don't have enough data in the train set in that case for that particular class to learn a particular pattern, a good pattern, and give prediction. So that is also a bad strategy. So we may want to look at if there is any issue, we again will go back to the basics and again kind of to look at again the split and then all that properly, so that a distribution happened in the right format. So let's go and see that how we can verify those things up. So in order to do that, what we have done, we have got our training class, testing class, and CV class distribution. And what we have done, we are looking at the classes because that's what is our main worry, that each class should be distributed kind of in a appropriate manner. So what we have done is we are looking at if you look at this code, what this is going to do, it's going to look at that class 1 is in training set, how many times it is coming. So let's say 363 entries of class 1 is happening in my train set. Similarly, class 2 have 289 entries in my training set. So like that, we're gonna get the output for train, test, and cross validation. So this is what we are going to get from here. Now, once we are done with this, now definitely we can I can even look at the test class distribution, I can look at the CV class distribution, but the problem with this approach would be that it will be very difficult to look at the raw output and kind of do a comparison. So what is the best way? As a data scientist, you should be kind of visualizing this. You should look at the graph, right? So if you can put this things into graph, it will be more easy for you to visualize how the distribution is happening. So for doing this, we have plot this particular graph. You can see that this is happening for your train class distribution. So we are drawing the bar plot, and here you can see that for class 1 we do have a good distribution. For class 4 we have a good distribution. For class 7 we do have a very high distribution happening in my training set. For class 8 and class 9 we have very less data coming into this. So let's see what's the case in my other portions as well. But before that, maybe I want to put it in form of percentage here. Like if you look at it, class 7 have the maximum data in my training set. So what I've done, I've written a code to return the percentage of this, that what is the percentage of overall of class 7 in the whole data. So it is almost like 28.672% percent of the data which is coming in the train set for class 7. Similarly, for class 4, we have 20.669, and this was quite easy for us to do that. It's a very simple Python code to get all these values. You can go through it. So this is how you can see this distribution here. Now let's go and check the distribution for my test part. Now for test also, we can see that for class 7, the distribution is high. That means maybe in our original data set itself, my class 7 have huge amount of entries. So even for class 4 we have huge, and for class 8 and class 9 even we have lower number, and you can verify that from this as well. So class 7 we are getting 28.722, and you can see here also in the train set we have almost the same distribution, which looks like if you compare basically both, this output looks like my random split have happened quite well, right? Let's look at the cross validation, and here also we are getting almost the same output, right? So again, class 7 is very nicely distributed. 8, 9 have very less distribution. Even if you compare for the rest of the class, you can actually check that it's going to be kind of in the same distributed manner. As I said, sometimes it can happen that this distribution is not happening properly or in the same way. In that case, you need to go back and again rework on this. Okay, so don't just blindly start working on any machine learning algorithms. Always keep this in mind. This is a very critical fact, guys, that you have to look at before you even think of machine learning algorithms. You should always look at your data and see whether before you plug in your data to machine learning algorithm, everything is in the right format, whether you have cleaned it. All those things are really important as a data scientist for you. Otherwise, you may end up with some messy results. Okay. So we will see the further points related to machine learning now in the next video lecture. Okay, so after we have done all the cleaning, we have looked at the data, we have got our training set, testing set, cross validation set. We have even confirmed whether my distribution is appropriate or not. Now, after this, we need to go back and see that what is the criteria based on which Kaggle is going to decide that who is going to be the final winner. Now for this we have to again go back to Kaggle page. So I'm going to go on the top, click on this Kaggle link once again. Now when we are going to look at this, you will notice here there is something called as evaluation. Now let's click on this, and this is where you need to see that what is the criteria they have kept it. Now you can see here that they have clearly mentioned this is going to be evaluated on multi-class log loss. Okay. Now you might have heard about various ways of evaluating a model. For example, you do have something called as accuracy, right? This is a very common metric being used. You have something called as AUC, area under curve, ROC. So many things are there, right? So many evaluation metrics are there for my model. But in this case, Kaggle have kind of restricted you to multi-class log loss. And this is how your Kaggle competitions go different from your real world corporate problems. In the corporate problems, there is nothing like this, that you have to only look at one particular metric and give the output. You need to be kind of generic, but Kaggle being a competition have to definitely go in a way so that they can easily identify that who is the winner. Now, this log loss, if you don't know about it, don't worry about that. I'm gonna give you a good explanation of what is log loss, because I know that most of the instructors generally don't teach this metric. If you know it, well and good. You can skip out this particular lecture because this lecture is going to be completely about log loss. But if you don't know, then you will learn that even from this problem point of view, what are the things in log loss you look at. So we will understand this particular point and how this log metric is important. So maybe I would keep two metric here. One is your confusion metric, because that's what you guys understand well. So I'm also gonna consider confusion metric so that you can understand the accuracy portions and all that quite well. At the same time, we will also understand from the log loss point of view, because the winner is gonna have the minimal log loss. So here, like we always say that this, right? We want to keep the error to the minimal point in machine learning. So similarly for log loss, we want to keep the log loss to be minimal, because that's what would be our evaluation criteria here. So that's what we're going to learn now. So let's understand that what is first log loss, and then we will relate to our problem statement that how this is going to fit in this log loss formula here. So let's go back and understand this now. So this is going to be log loss. Okay. So in order to understand this log loss, let's take a very simple example. Okay. So let's say I have input X. Okay. And I do have the output Y, and let's assume that this is a binary classification problem. So let's say for my input X, there is something like X1. In fact, let me mark it with different color. And let's say my original output for this is 1. X2, this is also 1. X3, this is 0. X4, this is 0. Let's say this is my outputs. Now here, let's say when I build a model and I got my prediction y dash, okay, this is probability. Let's say my probability came out to be, let's say we have built a model that anything greater than or equal to 0.5 probability, I'm going to mark it as 1. Otherwise, I'm going to mark it as 0. Let's say we have built some model like that. And for the first portion, let's say we got it our probability as maybe 0.9. Second one I got 0.6. Can you see that it's a close decision because we have just a probability greater than 0.5, so that's why we have considered it. Third column is, let's say, 0.1. This is good for predicting it to be 0, but let's say 1 is 0.4. So if you look at this part, this is, let's say, 0.4. Now, let's say these are the probabilities, and based on this, you have done your predictions. Now, if you go with your accuracy metric, and if you have built something like this, then in that case, your accuracy will come out to be almost 100, right? So that's what you would say that my prediction and my final output is quite good. But log loss kind of work in a little different way. Let me first explain you the formula behind this log loss so that you get an understanding that how it works. So in order to get the formula, I will explain you how this formula also works, but for now just let me note down this formula, log loss. So for the previous data, first of all, it's going to be minus, okay, minus 1 by n, okay, means I'm going to take the average. So if I have in the previous, I have 4 rows. So my value of n is going to be 4 in that case. I'm going to run this from 1 to n, okay, and what I'm going to do in this case, I'm going to take up the log values. So I'm going to say log of probability, okay, so this is going to be probability, which is pi, okay, which we got like 0.9, 0.4 and so on, into my yi. Basically this is my original output what we had. Now this is first thing, plus 1 minus yi. So in between both of them, only one of them is going to be true. So if the value is 1, then this value will become 0, right? So only this term will make sense. And then log of 1 minus pi, which is again the probability, okay? And this. Let's once you go through this full formula, you will get a good insight that how this whole thing works. Now, as I said, with this part, this is for a binary classification, very specific to our old data, which I have presented to you here. So if you look at it, we do have the knowledge of yi, we do have the knowledge of our probability part like pi. So with this, we're gonna place our data to this. Now, if I look at this y is equal to 1, right? So if I have to place this data into my formula, so since I have a minus symbol, I can maybe put my minus inside and let's start solving it up. So my first value will become what? Minus log of pi. Pi is what? 0.9, right? So first row, I have the probability of 0.9 into yi. Yi is what? 1. So I got this value. Now, what about this part? 1 minus yi. So since the value is 1, so 1 minus 1 will become 0. So this term will become anyway 0. So it doesn't matter what is going to come out here. It's always going to be 0. So I got the first term for the first row as minus. So I'm going to note it down here. So minus log of basically I'm going to get minus log of 0.9. This is for the first row. Let's calculate it for the second row also. And if you do calculate again, this is for yi as 1. So my 1 minus yi will become 0. And if you look at it, I will get minus log of 0.6. This is for the second row. For the third row, let's go back. This is for yi as 0 and yi dash is 0.1, right? So again, let me go back and plug in into this formula. And if I have to plug into this formula again, it's going to become, so I'm kind of ignoring 1 minus n term, which I can always include at any moment. This is just for an understanding. I'm trying to explain what is log loss. Now, after this, if I plug into this formula for the third row, so definitely this term, because yi is 0 will become 0. So only this will be kind of relevant right now. So 1 minus 0 will become 1. So 1 into log of, again log of. Now this is 1 minus pi and pi is 0.1 for this. So it's become 0.9. Okay, so this is what the value we're gonna get for the third row. Let's go back and place it here. Minus log of 0.9. And same way, if you compute it for the last row, I will get minus log of 0.6. If you do compute these values, I have done it already, so you need not worry about that. So if you do compute all this value, your values for minus log of 0.9 is going to be 0.0457, if I'm not wrong. This is going to be 0.22, and this is going to be 0.0457, and the last one again is going to be 0.22. Now let's look at the interesting point here. If my probability is 0.9, which is kind of high for value prediction to be 1, means if you get like probability of 0.9, and if I'm predicting okay this is going to be 1, that means it's a good prediction. My probability is kind of coming quite good. But if my probability comes out to be 0.55 and I'm predicting it to 1, there was still a dilemma. It could have landed to 0 even position, right? Because it could have kind of gone lesser than 0.5 and we could have gone to 0. But being this, basically this is very close to my 1 and it's a very good prediction for this row. So can you notice that this value comes out to be very low for this? If my prediction is quite good, my log loss value is going to be low, because as I told you, my log loss should be as minimal as possible. Now, if this is the second part, can you see this 0.6 probability? Here, this value came out to be high. So when there was a dilemma, my log loss is going to penalize me. It's going to say that, okay, this value is huge, so I'm going to give you the value of 0.22, which is high. Similarly, look at for 0.1. This should give you a low log loss value. Why? Because again, this is very good probability for my zeroth value. So you can notice this. I got 0.04, which is a quite low value. But for 0.4 to prediction 0, it should again return me a little high value. This is the whole idea behind log loss. So the main idea here is that more your prediction is better, the log loss value is going to be low. If your prediction is going to be kind of ambiguous, it's not that great, then your log loss is going to penalize you. So we want to keep this whole value to be lower. That's what is the whole idea behind this log loss. You can think about it. Let's say I have this probability as 1 instead of 0.9. Then in that case, what I will get? Log of 1, right? And log of 1 is what? 0. If I get log of 1 as 0, that means my log loss became 0, right? So if my probability somehow goes to exact 100%, that means I will get my log loss as 0 value. So this is the beauty behind this. Now I can extend the same thing to my multi-class classification example as well. So right now we understood from the binary classification part, but I can extend it to completely multi-class classification. So let's go and try to put the same thing into my multi-class classification. So for my multi-class log loss, the scenario is that I'm going to say 1 minus n. I'm going to run it again for all the rows, but this time I'm going to put it for my classes basically from 1 to C. And here I'm going to put Yij, which means that it's going to be 1 if my Xi, so it's going to be equivalent to value 1 if my Xi belongs to class J, right? So if this is the part, it's going to be 1, otherwise it's going to be 0. Again, just go back again to the same binary classification. If you want, you can just change this value of C to 2 and I give this as a homework activity. It will just end up to the same solution what we have just gone through. I would suggest you to do that. Now after that, we can just say log of Pij, which again is the probability term that Xi belongs to class J. Okay, that's a probability what we have. Now this is the formula which we can put it if we are talking with respect to our multi-class. Now if we come back to our case study, we are talking about multi-class. We are not talking about single class, we are talking about multi-class problem. So let's understand that how in our multi-class scenario, how this is going to fit in for our project. Now, again, as I said, this is basically telling me that yi belongs to class J. So if you think about it, let's say in my project, we do have 9 classes, right? So let's say there are 9 classes. Now in this 9 classes, let's say I have this value as 0, 0, this is 1, and again all the value as 0. So this is, let's say, y for ith row first classification. Again, this is y ith row second classification, yi3, right? So which is for ith row third, this class third. So let's say this is belonging to 3. So in this case, we can say that this value is going to be 1 for ith row where it's belong to class 3. So that's how we kind of represent it. Now in terms of probability, if we look at in terms of probability, if we go and kind of understand this, I have a data set, I'm passing it to my model, and I will get some probabilities. So my probabilities will look like this. I will have let's say for first row, if I'm talking about, okay, so I do have let's say first row, and this belongs to class 1. This is the probability for it. Probability that first row belongs to class 2. Again, you can keep on doing it till class 9, right? Because we have 9 classes. Now think about it. Just put this in this way. Let's say I got a probability that for class 3 the value is 1, okay? For remaining it is 0. So what I'm saying that maybe I am getting a probability that for 1, 2, 3 till 9. So if you look at it for remaining all, because sum of the probability should be 1. So what I'm saying is that let's say we come to a situation where I got an output from my model from when we passed this. We got an output that probability comes out to be 1 here for this. Now in this case, if you will calculate the log loss, you can just go back to a formula and put it. You will get basically log of 1, which is going to be 0. So I will get the log loss to be 0 in this particular row. For this row, I will get the log loss as 0, which is quite good. But in case, let's say this is 0.9, okay, instead of this, let's say this is 0.9 and I got this as 0.1 and remaining as 0. Now in this case, my log loss is going to penalize me. This 0.9 will return me a very lower value, as we have seen it in the binary classification as well. But at the same time, this is definitely going to give me some value greater than 0, right? So my log loss will have some value. So the best model for log loss definitely should be 0. The value for log loss is 0. That means I'm creating a perfect model. But in real world, we never have a perfect model. So in this case, the model can lie from 0 to infinity. So we will see that how to use it and how to build the model with the log loss keeping in mind. But this is what log loss is all about. So we just understood what is log loss. We will see to the next lectures that how to use it. Okay, so in the last lecture we understood about what is a log loss. Now we have a bigger problem here. Problem is that let's say if I have a metric of accuracy. Now in accuracy we know that my accuracy, if it is like can be between 0 to 1, and in 0 to 1 case, if more closer to 1 is good, right? So it means that if it is, let's say, 0.90, then we say that we have a 90% accuracy in this case. So it is closer to 1, it's good to this. Similarly, we do have AUC, area under curve, and this value also, if it is closer to 1, it's good. Now we do have a lot of metrics where we do have a defined criteria. If it is falling in this, it's good, or if it's not coming to this is bad. But if you look at the log loss, in log loss, the value can go from 0 to infinity. Now the thing is that, yeah, I know that if the value comes out to be somehow 0, it's a best model, right? It's a best model. There's no doubt about it. But the problem is that we do not generally get as a best model, right? Maybe let's say if in some model I use and I got the value of 1.5. Now what I can really say from this number? Can I say that the model is good or bad? How can I really do some comparison? Because the highest value can go to infinity here, right? So there should be some kind of comparison metric to it. That's the reason log loss is not that good in visualizing and giving it the output. So now in our problem statement, since we have to use log loss, so how we should really go about it, how we should really think about using this log loss matrix and say that, okay, this is a good model or a bad model. Now, one way, there can be various methods. I'm going to tell you one method. One way is, how about if we generate a random model? When I say random model, I'm talking about a model which is a worst model possible. Okay, this is the worst model, which we will create by completely by some random numbers, and that model is, for that model which we're gonna generate on our data set, we gonna basically compute the log loss. Okay, let's say that log loss come out to be 3. Let's say that log out comes out to be 3. Then after that, what we will do, we will start generating our models. Okay, let's say we will generate a LR model, okay, which is logistic regression model. If this LR model is going to return me, let's say, log loss of, let's say, 1, right, or 1.5, in that case, if I compare with 1.5 with 3, definitely LR model is performing better than my random model. That means this model is better in comparison to any worst model which we have. So this is the strategy which we're gonna take in order to deal with this log loss. And maybe we will compare this basically log loss for various algorithms, and we will see that which algorithm is going to give me the minimum log loss, because that would be our main focus here. Now, in order to do that, how we should generate a random model? Now, here we are working with probabilities, right? So, in terms of probabilities, if we look at, definitely all the probabilities of, let's say, 1, 2, 3 till ninth model, if sorry, the ninth model. So, here the sum of these probabilities should be equivalent to 1. So the way I will generate this model is, random model would be that in the end, the final probabilities which I will randomly generate is the sum of those probabilities should be equivalent to 1. That's something which we have to keep in mind while creating it. So let's go and see how we can work out on this sort of models. So first of all, we need to work on all the probabilities for my test data set and my cross validation. So we are taking the length for it, because for each row we gonna generate this probability, right? For first row we gonna generate the probability for all these 9 classes. For second row also we gonna do the same, and similar thing we gonna do till nth row. So that's the reason we got for this, because we want to generate the log loss for my cross validation data set as well as for my testing data set. So that is something we gonna do now. Now, first what we did, we kept everything, because we need for all the 9 values, right? So we need to fill up basically 9 values here, 1, 2, 3, 4 till 9. So that's the reason initially we took all the values to 0, all the 9 values to 0, and later we're gonna fill it with some more appropriate values. Now, in order to do that, what we're gonna do, we're gonna run it for my whole cross-validation dataset, and we're gonna do the same thing for testing later. First, we started with cross-validation dataset, and we started putting the value randomly. Now you may say that, okay, randomly this may not sum up to 1. That we will do in the next step. So we put the value randomly, and in the next step, to make the sum value basically equivalent to the part, what we did, we basically divided it with the sum of all those part, and this is gonna ensure that the sum of the probability should be equivalent to 1, right? So that's what we're gonna get. Now after this, once we got this part, we have to calculate now the log loss for this cross validation in the random model. So what we will do, there is a function called as log underscore loss for calculating all this for us, and here we're gonna pass our actual output, which is for cross validation, and my predicted part, which we just computed here, which is random probabilities which we have just put in, so that the sum of all these probabilities should be equivalent to 1. And once we pass this, we got the log loss to be 2.49 for cross validation. Now what does this tells us? This tells us that 2.49 is the worst log loss, and if any of my model which I'm gonna generate is gonna be greater than this, that means it's a worst model, means even it worse than worst model, and we should not consider that. So we got some sort of criteria now that all the models we gonna generate should have lesser than 2.49 cross validation log loss error. Let's do the same thing for my basically for my test also. You can see that we are taking exactly the same route for this. We took all the 9 values to 0 initially, then we took the run it for all the test data rows, and we put randomly 9 values, and we made sure that all the values should sum up to 1 probability values, and we are passing my y-test original value and the predicted, which we have just done it randomly, and we got the log loss of 2.48. So for the random data model, for my test set and the cross validation set, we are getting the log loss of 2.48 and 2.49, which is quite close. So this is how we got this part. Now, this is basically for the random model, right? So we do want to do some more analysis on this. So what we gonna do is, we definitely, if you look at it, let's say if my random model is returning this sort of output, let's say 0 0.1, 0 0.1, 0 0.05, 0 0.05, and so on, in such a way that then the last probability is 0.2, right? So let's say this is my output, and all this sum of 9 values is equivalent to 1 somehow. Now, in this case, let's say if 0.02 is the highest value, so this should return, right? This should get returned that when class 9 is having the highest probability, so it should return it. So that's what we are doing with the argmax. So we are going to now get the index at which it is highest. So you can see that we gonna get it in my predicted underscore y, and these are all the indexes, but you can notice that it have taken the index from 0 to basically values 0 to 8. So we have to increase it to bring it to the scale of 1 to 9. Let's add it plus 1 to it so that we can bring it to the same scale in which we are solving our algorithm. So this is the way we have generated our random model. We got our log loss for it, and now we gonna work further on it on the same random model to look at various metrics, because once we get this, we definitely want to ensure that how my confusion matrix looks like, how my precision matrix looks like, how my recall matrix looks like. So this we will do all those things in the next lecture. So after we understood what is one-hot encoding and response encoding, and we have also seen that how response encoding would make sense to this particular problem, where we will look at for a particular gene I, we will look at the probability that how it is occurring for that. So that is the value we're going to impute, and the advantage we have seen for response encoding is that it will create number of columns equivalent to total number of basically number of class outputs you have. So in this case it's going to be 9. Now we will see that how to perform these things in the practically in the Python notebook. So first thing is that we need to create a one hot encoder, and I will show you up that one hot encoder will create much more columns for gene in comparison to when we will go back to your basically response encoding part. So here we are going to take the help of count vectorizer, as you might already be aware of this, and we are going to pass my gene column in the fit transform, and this is going to convert it for my train, for test, and for cross validations. For all the three data sets we're gonna do the same, and after we got it, we can look for the train shape or test shape or Chebyshev shape, doesn't matter. But if you will look at it, you will notice that for the gene column it have created 227 columns, right? Which is huge. Just for one gene column we got 227, but it's okay. There are few algorithms like basically if you look at, let's say, linear logistic regressions, they perform really well if you have even huge dimensions. So we will see in those cases there will be no issue, but there will be few algorithms like KNN, where maybe, like for example, when I will say KNN, K nearest neighbor, then in that case maybe this may not work good, and we may want to move towards a smaller dimension data, which response encoding can help us do. So now let's go ahead and see a few more things to it. Now here you can see we can also look at all the column names that I have created. So we can just say get feature names, and it's going to return me all the column names which it is going to return. Now after that we're going to see how to perform a response encoding. Now for response encoding, what we are going to do, if you look at it again, we are passing this gene column, and here we are also going to use something called as Laplace smoothing. Now this is also one of the very interesting concept. In fact, this Laplace smoothing, I'm going to use this almost throughout this project, and even at a lot of places I'm going to use this calibrated classifier as well. So you should really know what is all this. If you don't know, don't worry, in the next lecture I will explain you what this Laplace smoothing is required, why Laplace smoothing is required, and basically what's the significance of this, why I'm basically using this into my project. Now in this case, I have chosen the value alpha for performing Laplace smoothing, but right now don't worry about it. As I said, I'm going to explain you what is Laplace smoothing just in the next lecture. So for now, just take it some value alpha, we are passing it on, and it's just getting it work. Now after that, what we are doing, we have created a function. Now what I have done for this function, this function is taking my input for Laplace smoothing, one something called as alpha, and it's taking the gene column which is there, and your training data set or testing data set or cross validation data set, and it's gonna return you the response encoding value for it. Now when this is gonna be returned, you can notice that when I looked at the shape of this, the output of this, you can notice that I got only 9 columns instead of 227 columns what we were getting in one hot encoder. That's basically is the beauty about this response encoding. Now for doing this, this function is not available to you by default. So for this I have written a Python code for it, and I would strongly recommend all of you to go through this particular code. This is a well commented code. You can see that each and every line is properly commented so that you should not face any issue in understanding this particular concept. So it's very simple code. Just go through it line by line, and this is exactly the same thing what I explained you, that how we calculate the response encoding in terms of those probability terms. So please go through it line by line. It will really help you to understand. So this is one also an art you should learn. Though definitely you need not be a very good Python developer, but this is quite simple to get that. So I leave this as a homework for you to basically go through this particular functions and kind of work on that. And Laplace, I'm gonna introduce this in the next lecture, this Laplace, what is collaborator classifier. So I'm gonna talk about all this in the next lecture. So now we understood that how to get the response encoding and the one hot encoder. So right now we have just converted the gene particular column to basically with respect to either a one hot encoder which is going to create 227 columns, or with respect to your response encoding part which was creating 9 columns with respect to your probabilities. So once we have got that, then the question is that how good is this gene column for my final output, right? Now what is the way we can actually go and test that? So one nice method is, we have already created a random model, and there we have seen that what is my log loss, right? So we know my log loss was, let's say, 2.35, let's say. I do not exactly recall, but it's, let's say, was 2.35. Now in this case what we will do, we will create a very simple, maybe logistic regression model, okay? And I'm gonna build it assuming that I only do have something called as only one column with us, and that is called as gene, okay? And we are trying to predict from it my classes. So simple model which we're gonna create. And during this process, if my log loss comes out to be lesser, my log loss is going to be come out to be lesser in comparison to your random log loss, then in that case gene is a good feature, right? So that will be the way we can say that, okay, since it is performing better than any random model, so definitely gene is going to be a important part for my prediction. So that's what we are going to do. Now in order to do that, we need to understand a few techniques, like basically we have to work on something called as Laplace smoothing. I will explain you what is this now. So this Laplace smoothing is a very interesting kind of method which you should be aware of. Now this is the concept which you might be introduced in your machine learning concept in Naive Bayes, because that's where it have made more sense, but it's a very generic call. So in Naive Bayes, what you do, right? If you recall, you kind of, let's say you have various words, W1, W2, W3, and so on. till let's say wm, and you have your classes. Let's say the classes can be either 0 or 1. So in this case we used to calculate during your training phase I'm talking about. So used to calculate the probability of w1 given that y is equal to 1, because in training phase I used to know my 1 value, that where is my class 1 for word w1. Similarly, I used to calculate for remaining things as well, and same thing we used to do it even with respect to your y is equal to 0, right? So this is the way we used to work in your naive Bayes theorem. Now I'm not going into depth of all this, because again I'm keeping my assumptions here that you know what is naive Bayes, okay? But if you really don't know, do not panic. Please go back and do a revision of this algorithm. Or if you still face any issue, guys, feel free to post your questions on your discussion forum, and I would be more than glad to create a video for it. Okay, so if you really feel, or if you want that I should create some nice video for with a mathematical intuition for Bayes theorem, definitely I will do that. Now coming back to this, now there is a problem is this is happening in the training phase. Now all this w1 w2 till wm what I have is the words present in my training data. Now if I go back and let's say if I look at my query point, which is my test query point, and let's say by any chance my I have, let's say in my this part I have this, but I do have a word w dash, okay, which is not a part of my training set. Okay, this is quite possible because English keyword is huge, right? So there is a possibility that in my training data I do have some word, but the same word in the test data, or maybe I have a test data set where I do have word which is not even present in my train data. So I have no idea about this w dash, that how it's gonna behave, what is the probability I need to keep for it. So now the problem is, if I have to, let's say, get the probability that what is the probability that it's going to be 1, given that it belongs to my test queue. Okay, now this test queue is nothing but my y is equal to 1, and this is going to be like w1 w2 till w dash, right? Now there's a problem is, if I break down this probability as per Bayes theorem, it's going to break down something like this: probability of w1 y given 1. This is going to come from a training set, and it's gonna go on, but in the last I will have probability of w dash y is equal to 1. Now the problem is I have no idea what to do with this term. Now one way could be, you could say that, oh, how about drop it, how about ignore it, right, and take the remaining term. But if you are dropping it, don't you think it is equivalent to saying that you are equating the value to 1 to it, right? And that is not the case. You are giving the value 1 to it if you are actually going to do that. Now there is another idea what people can say: how about making it 0? But if you make it 0, then the whole multiplication will go 0. So again that will be a problem. So in order to solve this particular problem, we use something called as Laplace. Now, what is this Laplace smoothing? Or sometimes you will hear this term called as additive smoothing also. So that is also sometimes people do refer it like that. So now in this case, what we do, so we will say P of W dash means probability of W dash where given that y is equal to 1. This is going to be equivalent to earlier what was happening if I have decided that if I would have gone with the technique that, okay, number of training points basically that it belongs to y is equal to 1, that was basically 0 because there was no points present in my training part, or divided by total number of values. Let's call this as n1. So in the earlier case we were deciding it to give the probability 0, which was not working good for us because 0 will multiply with everything and return 0. So in order to solve this problem, what we will do, we will add a alpha term to it. Now alpha will be hyperparameter. Okay, so this alpha and alpha k, so you might be using all these hyperparameters a lot in your machine learning. So this k is nothing but your total number of classes. Okay, so like in my last example I have taken y as value 0 or 1. So in this case my value of k could be 2. So in this case my value will become alpha n1 plus 2 of alpha. Okay, like this. Now typically we take the value of alpha as 1. Generally we do that. So we generally want to keep it a reasonable value, and definitely it is a hyperparameter, so you can always change it and see that where your model is giving you the best output, and you can stop there. That's something is always in your hand. Now let's say I have taken the value of alpha as this and assume that I do have 100 points. So my N1 is 100. So what's going to happen in this case? My alpha value is 1 and my this is 100. So plus 2 into 1. So what I got, 1 divided by 102. Now, if you look at this value is definitely not 0, right? This is going to be a small number, but it's not 0. Now, you take another case where let's say I have gone for alpha value to be 10,000, right? Or some huge number. Now, in that case, if I go back to my same part, so 0 plus 10,000 divided by 100 plus 2 into 10,000, because if you remember the k was 2, so here we will get something like 10,000 divided by 210. So I will get somewhere roughly by 1 by 2, not exactly 1 by 2, but almost 1 by 2. So you can see that if I control this value, it can also help me in kind of controlling my something between bias and variance, right? It's a very interesting part. You can actually play with this and see to this part. So this really helps us in kind of doing it. Now the question is that are we going to only do this alpha multiplication, basically this alpha part, only with respect to my data which is not present? No, because we can't really filter out all this. So what we do, we do this Laplace smoothing for all my whole data set. So even if my data is present, so let's say I have some probability coming out to be 2 divided by 100. Maybe that's the case. It's not 0, but it's 2. So in that case also I can say alpha plus alpha k. It's not going to make any difference for you. So even if the value is there or not there, doesn't matter. We're going to add this for every term present into my algorithm, and that's what we're going to do. So I hope now you got an idea that when we were doing this response encoding, I was considering that alpha is 1 and then I was passing it. So I was just ensuring that if some place it's not present, then it should not return me some value like 0. So that was the idea. So again, this Laplace smoothing is a very interesting concept. Similarly, there is another thing which we also going to use called as collaborated classifier. So let me explain you what is that. Calibrated classifier. So I'm explaining you all this because I'm going to use this while building my model. So this is a very simple concept. Let's say I have an input xi and I'm passing it to my model m and I got the value yi. Now this yi may not be mandatorily a probability term, right? So it may not be probability. Now in that case, maybe we need some output in terms of probability. For example, like when your final output is required in terms of log loss. Now in this case, log loss definitely needs probability. Log loss is a complete concept on probability theory. So now in this case, what we should do then? So what we do is we build it again with a classifier which is called as calibrated classifier. It may be a sigmoid function, or it may be any advanced level function like isotonic. Okay, so then it is going to return you the form of y dash. This is going to be probability. So as a thumb rule, you can think of it that whenever you're going to use log loss, it's always a good idea to use calibrated classifier, so that your final output should always be in the probability format. So it's going to help you to convert it to the probability format and use it. The third thing we're going to use is SGD. I believe this everybody is already aware. It's called a stochastic gradient descent. Okay, this is, we use it for optimization purposes and all. So this I hope everybody is clear, right? So so these are things which you need to know for understanding the further machine learning model. And now as a next step, we gonna basically approach the whole problem from these three perspective a lot. So after we got our random model, which we have just seen, now let's see that how good that model was. Definitely the model cannot be good, and we have seen the log loss was also high. But now let's see that if we calculate something like confusion matrix, which will return you the accuracy, or if you go for precision and recall, how it will look like for random model. But do not expect a good output here, because definitely it's a random model. Now the code is very simple for it. We are going to calculate this matrix by using this confusion underscore matrix function. And in this function, we are passing our original data set and my prediction. So prediction, we got it from here, right? So we got our predictions here by getting those indexes. Now, once we got it, I'm gonna just plot this heat map matrix. It's quite simple code, which you might have seen in a machine learning algorithm. So my label is from 1 to 9, and we're gonna put our matrix C to it, and let's see that what's the output comes out to be. Now, this is my output. So you can see that it's a 9 cross 9 output, and your basically this axis, y axis includes your original class, and this part is your predicted class. So if you look at this, definitely I do have some coloring code here that if the value is going to be kind of higher, then it's going to be blue color, otherwise yellow color. So I want my diagonal element to be always high, right? So that's the main thing basically which I look at, because what does this diagonal element tell us? It means that there are 10 values which, if you look at this part, this means that there are 10 values which are actually belonging to class 1, and they in the original class also they belong to class 1. So they are 10 in number. And similarly, you can look at the other part, and you can see with this that it's do not look that great. So all these values here and here are errors, right? Where my prediction have not definitely happened correctly. So this is my accuracy. So you might be seeing your accuracy confusion matrix a lot while you were solving your normal small case studies when you're solving your machine learning courses, but here this is going to be a little huge because it's a multi-class classification problem. Now let's go ahead and see few further things. So we are now going to look at precision and recall. So we just understood that how the accuracy is being looked at, but now we're gonna look at precision and recall, that what exactly this number is going to come out to be. So my precision is another matrix where we computed again the matrix B, and we are going to calculate this precision matrix. Now, what does this precision matrix basically tells about this? Though I am pretty sure that you all might already be aware of precision matrix and recall matrix, but again, just let's try to intuitively understand this particular portion. Now, in this case, when I see this value of this 0.139, it means I'm talking about 13.9%. What this value tells us? This value tells us that of all the points predicted to class 1, 13.9% of the class actually belongs to class 1, right? Or so if you look at it, basically the way precision is calculated is, if I look at this particular point, so this point divided by all these points, okay? So this is how we calculate it. Or if I talk about this point divided by all these values, all sum of all these values, okay? So, or if I talk about this point, how this we got, so from the, and this is all done on the confusion matrix. So on confusion matrix, whatever the entry is coming here divided by all the sum of all these points, so this is gonna return you again your output in terms of percentages. So we always look at it in terms of percentage. So let's say if I have to talk about this means that 11.1%, right? So it means that of all the points which is predicted in your class 1, okay, 11.1% actually belongs to class 6. Okay, this is what basically it means. Now let's go and look at your recall. Again, this is very similar to this, but only difference is on the confusion matrix, again on the values what you're getting. So let's say if I have to calculate the recall on this data point, so this value divided by sum of all these values like this. So it's just it's a row wise thing which happens, and when we were talking about precision, it was column wise division. So now if I go back and again look at this, my recall values, so we got basically these values as again the same explanation, like if I have to look at this point, so divided by sum of all these points on your confusion matrix. So that's how we calculate it. Now how we can infer this? In order to infer this value, again we look at something like this. If let's say if I am talking about this part, it means only 8.8%, which means of all the points which actually belongs to class 1. Only 8.8% were predicted to be in the class 1, right? So that's how you look at a recall. And you can see that all these three matrices are coming out to be really bad. Okay, we will now start doing the comparison in the other way as well. Thank you. So by now we have computed uh, how to calculate the confusion matrix, look at the accuracy for it. We have seen that how to work with respect to your precision and recall, and now we gonna take one further step, and now we're gonna play with the columns. What I mean by that, so if you remember from my original data set, we do have uh, three independent columns and one dependent column. So one column is gene, second column is variation, third column is text, which is your research paper text, and the fourth column was your class, which was your dependent column. Now this class value was falling from 0 to 9. Now what we are going to do is we would like to understand that how impactful this gene is for the class. Means, is gene is really important independent column if we compare with if we have to predict the class variable. So that's what we gonna figure out first. So in order to do this, we will do some analysis, and also if it is relevant, in order to identify that as well, we need to bring this categorical variable into an appropriate format which my machine learning algorithm can really understand. So right now this is completely categorical, so my machine learning algorithm cannot take that value exactly as it is. So we need to apply some sort of techniques to get this done. Now in order to do that, let's start with some analysis here. Now the first thing is we would like to see that how the distribution of this data looks like for gene column, and we can see here that we do have like all these values, like BRCA1 is occurring 174 times, TP53 is occurring 102, and the unique genes are would like 227. Now we want to maybe plot few things to get even more better understanding about this data. So what we are doing, we are plotting a cumulative distribution plot, and if you look at this plot, what this tells me is that if I look at the top 50 values, they are contributing to almost 75% of your data, right? So almost 75% are being covered by top 50 genes itself, and remaining values may be kind of less occurring. So this is one of the analysis which we can make out from this particular part. Now, as I was telling, that the first thing before we even think about building any machine learning model is that we need to convert it into an appropriate format so that my machine learning algorithm will be able to take it as an input. So as we already know from machine learning techniques, that there are two different techniques to do that. One is your one hot encoding, and second is your response encoding. I'm really surprised to hear this, that a lot of machine learning engineers are not even aware of response encoding properly, and it's a very powerful technique. In fact, we gonna see that in which all algorithm response encoding works best, and in which all algorithm one hot encoding works best. So there are various cases where maybe my response encoding will perform much better than one hot encoding. In fact, people who are already aware of one hot encoding, they might be aware that one hot encoding do creates a lot of columns for us. So since it do create a lot of various column for us, at some time creates a problem. Just to give you an example that how one hot encoding work. So let's say I have a column which belongs to, let's say, country. Okay, and in this country column we do have some data points, let's say US, India, maybe we do have something called as Sri Lanka, right? So we have, let's say, these three countries. Now the thing is, if I have some more columns, maybe they are numeric or non-numeric, doesn't matter. But if I have to feed this numeric data to my mathematical function of machine learning, it is not feasible. So how to deal with this? So one way could be that we can just say that, okay, this is US, I'm gonna give a numeric value 1 to it, give a numeric value 2 to it, and give the numeric value 3 to it. Now, this solves the problem that, okay, we have converted our categorical to numeric, but this brings another problem for us. The another problem which will come here would be that if in this particular case, we are giving some number. So now it is sounding like India is greater than US or Sri Lanka is greater than India, because as soon as you give some number, it start working like an ordinal data. Now this is where again the problem starts. So how one hot encoder fix it? So what one hot encoder instead do is, so let's say it looks at unique values present in this column. Let's say there are three unique values. Maybe after that, India is going to repeat into this data and so on. So what it do is it's gonna remove this particular column. It says that let's remove this column, and instead of that, maybe add three unique columns here. One belongs to US, second belongs to India, third belongs to Sri Lanka. Now in the first row, since I have US, I will give 1 0 0. I have India in the second row, so I will give 0 1 0, means whichever entry is there, give the 1 to it, and remaining values give 0 to it. Similarly, I do have Sri Lanka. Now here I will give 0 0 1, and I do have India again, so I will give 0 1 0. This is how we can represent it. Then after that, we do also one more step as a machine learning engineer, usually, that if I do know the value of US and India, I can definitely tell the value of Sri Lanka. So maybe I don't need all the three columns, and we remove one columns from it depending on whatever we want. So that's something what we do as a one hot encoder. So this was a very quick review of this. But if you look at the problem of one hot encoder, we are facing one issue here, that if your unique values are too high, let's say my unique values are, let's say, 1000. Now in that case, are you going to end up with 1000 new columns? Means you are increasing the dimensionality of your data, and that too you will have so much of sparse data. This is a very big issue with respect to one hot encoder, and few algorithms have a big trouble with this, especially if you talk about like trees kind of thing, like random forest. So this is where maybe this will create problem if you have huge dimensionality data. Now, in order to solve this, we do have something called as response encoding. We also call it sometimes as mean imputation. Just like how we used to deal with the NA values, we start dealing the categorical values also in the same way. Now, this is an art. You need to learn it, that how to basically convert your values in a way that it should make some meaning out of it. Like in the previous example itself, where we have taken, let's say, three values of US, India, and Sri Lanka. Maybe finally we are trying to output something called as height here. Now what we can do here is, maybe we might want to replace all the mean value, mean height of US here. So I will replace this US with some other value. Okay, so the more thing which can make sense here would be that instead of keeping the US value, maybe I would like to replace it with the average height of all the people present in country US. Maybe let's say it comes out to be 160. For India, let's replace it maybe the average height of all the Indian people, so 152. So I do need to have maybe sometime domain knowledge to do it, or it depends. So right, so we can basically take up this call and can replace with this. Now this is called as response encoding. Now in our problem statement, if I go back to our problem statement, where we do have to look at genes, and from those genes we are going to replace our data. So how we gonna do that, right? So that's basically is a question for us, that how we pull up the response encoding here. Because here we cannot replace with the height or weight or something like that. So what we can do, so let's imagine I do have a data of this sort. So let's say I have two columns, one is gene and second is, let's say, class. Now let's say I do have a value called as gene I. So let's say I do have all these gene I value here, and I have corresponding classes to it, let's say 2 2 2, and I do have, let's say, 3, and there are some more, let's say 3 3 3, and I do have this gene value even going up here. So now in this case, let's assume that this is all 100 values. Okay, let's say we have this 100 values. So it's saying that this gene is there, so it's belong to class 2. This gene is there, so it belongs to class 3, and so on. So now here basically, let's say these values are, let's say, 30. So let's say this values are 30, and let's say these three value, class 3 is, let's say, 70 out of it. Okay, so these are, let's say, 70. So how we basically can work on it? So in response encoding, instead of creating like depending on the unique values, we are creating various column. What we will do, we will say that for every row we will create 9 columns. Okay, so like this is one row, right? So this is one row. So for this row I will create 9 columns. So now I will add, let's say, all these 9 rows. So this is, let's say, 1 2 3 4 5, and this is 9. Now, what we're gonna do further to this? Now, if you look at this probability term here, what we are basically going to do is, we this is probability 3, right? So we can also call it as probability that y belongs to class 3 given my gene gi. Okay, this is what I can basically say about it. Now if you look at this, this is going to be what, 0.7, because this is, if you can recall from your Bayes theorem, what is this value? This value is saying that I want the probability that y is equal to 3 and probability of gene I divided by probability of gene I, right? So this is going to be 70 divided by 100, which is total number. So I'm going to get 0.7. Similarly, here also I will get 0.3, and in the remaining place I will put 0. So this is how we will be imputing the value instead of keeping the categorical. So now in the first row, I got, let's say, this value as 2. So in that case, we will be basically replacing accordingly to whatever my computation is going to come for it, right? So for every value, we're going to replace it with respect to my 9 columns here instead of keeping it 1. That's the whole intention of using this. So in this response encoding, definitely we're going to have only basically, if you will look at it, we're going to have only 9 columns instead of having like multiple columns being available to us. So that's the advantage of basically using this response encoding instead of basically using anything else. So this is quite interesting, and I'm gonna give you more insight about it, and once we do it practically, it will start making even more sense to you, because we can go ahead and start exploring with this data, and you will notice that at few algorithms it works really well. So we will learn all of those techniques as well. Okay, so as we discussed last time, now we're gonna create a model considering only my gene column. And in this particular case, I'm gonna create a logistic regression with respect to my SGD classifier. So I'm gonna use the basically SGD classifier to do that. And at the same time, I'm also going to use my calibrated classifier, which I explained you in the last lecture, and we will be doing the Laplace smoothing if required. So let's go ahead. So here you can see here that I'm going to use one of my alpha parameter. Again, that regularization hyperparameters are required in SGD classifier. I'm also going to use L2 classifier in this case. So you can see that basically I'm going to use this L2 as penalty. I'm not using L1 norm, which is basically, so I'm going to with the L2 distance calculation and all. And I'm going to use this is loss is log, which means that I'm going to use logistic regression. But you can notice that this part I'm using it as a hyperparameter. So I'm going to run this algorithm for various value of this alpha, and whichever alpha is going to give me the best result, I'm going to just take that up as a final result, right? Now here what I'm doing is I'm computing, I'm basically doing this fit part, and you can notice that I'm using one hot encoding. So the way it works is that if I go back and understand this point, so if I go to one hot encoding, even if you have, let's say, huge dimensions, even in that case your logistic regression, LRSVM, these kind of models works really well. And similarly, if I go for your response encoding, so response encoding, you have like naive Bayes, random forest, okay, or basically these, or KNN, I can also put KNN to it. So in these cases it works. Even naive Bayes, you can use it for one hot encoding, that's not a big problem. But yeah, for random forest and KNN, definitely you have to go for a response encoding. So that's where we do it. So since we are going to use here logistic regression, I'm going with one hot encoder. But I would leave this as a homework exercise for you, that you can play with other models with only gene and see that how your log loss comes out to be. And you can notice that I'm using something called as calibrated class of classifier here. And if you look at this, what basically we are passing to it, we are passing this model, and we are using the sigmoid function just to ensure that we return everything in the probability format. And once we have got that, we are taking our one hot encoding data and basically going to train this model, and after that we are going to predict, and in the last we are going to use log loss, right? So that's what we have done. Now let's analyze this output which we are going to get. So here you can see that we got the value of for various alpha, like we have taken one alpha as 10 to the power minus 5, and this and so on, and we got for every different alpha we got basically different basically log loss. And if you look at it, this log loss seems to be minimal, which is coming from 0.001, right? So that's what basically we are getting the minimal log loss. So we can choose this alpha and go ahead with this. So what we're going to do further, we can also plot a graph and see that which is giving me minimal. You can see that when alpha was near to 0.001, maybe that's where it's going minimal. And even after that, what we can do is we have just computed this, but now we need to also choose the same alpha and go ahead and calculate for my testing loss. We will also do it for the cross validation loss also, just to have our comparison ready whether the model is overfitting or not. So let's do that. So what we are going to do to achieve this, we are going to now we have already got 0.01, which is going to be stored in best alpha, and after that we are using the same L2 Lagrange logistic regression. Everything is good. Created a model, we fitted this, everything is all good. We are using calibrated classifier, and in the last we are creating the log loss for each, right? So we are going to do a log loss for test, for cross validation and so on, and this is the value which we are getting for each part. So for with only gene column with a one hot encoder, logistic regression plus calibrated classifier and so on, we got our log loss value to be this. And if you look at this, this is very less in comparison to what my random model was giving us. So that's a very good insight what we're getting here, right? So this is telling me up that my model is good, not that bad, right? So which means that with gene column is it's definitely having a good impact, because this is much lower value in comparison to my random model. Now one more thing which we also want to look at a lot of the time, that how stable is my model. Now when I say stability, what I mean by that, now you have gene, and since it's a random distribution, there is a possibility that maybe you have genes basically which are here in the training set, and only very few are coming in my testing set. So this is, let's say, my test set, and this is my train set, and let's assume we do also have a cross validation set. So if this overlap is low, okay, so because there's a possibility that maybe in the gene some gene value which is there in train set but not there in the cross validation set, right? So that's the possibility, so that's not going to overlap. So we definitely want to ensure that I do have a good overlap. So more the overlap, better it is. We definitely want to make sure that if I'm training something on some gene data, that should be present in my cross validation. It should not happen something like the case where I talked about Laplace smoothing, right? So that sort of thing should not happen, that in the test data something comes up but I have not even done any training on it. So though we have the solutions for it in terms of Laplace smoothing, but it's not still a great idea. So we do want to have the very less part. So if the more overlapping it is, that means the data is quite stable. My model is also going to be stable. So that's what we are going to look at here. So you can see it in this case, it's telling me that my testing data, if I have 665 points, 639 are common in my train set and my test set, which is good, because if I look at the percentage, I have almost 96%. Similarly in cross validation also, with the train set, if I compare, we do have 96.42 points which are overlapping, which is good. So looks like my gene column is going to be quite well, in this case it's going to be good overlapping, so it's going to be stable, and even my log loss is good. So gene column is definitely important for my classes in this case. Let's follow the same steps on my variation column. So we have just seen that the gene column was relevant. Now we're going to work on the variation column and see that whether my variation column is going to be relevant here also or not. So in order to do that, again, we are going to look at that how this distribution looks like. So we can notice that we do have some 1936 unique values, and the distribution looks like this, that we do have training mutation, this, but if you look at it, apart from these four values, almost the remaining values have the values occurring less than 5 in number, right? So maybe we can see the same thing during when we are going to build our basically graphs as well. So let's see whether that is happening or not. So let's go down and see this part. And yes, we are right. So you can see that there's a spike here. But after that, the values are moving like this. But in fact, if you look at it here, 80% of the data may be falling till 1500, right? So because the distribution for the remaining points are very less, maybe they are just occurring less than 4, 5, this number, right? So that's what is happening here. Now let's go ahead and see a few more things. Now for this portion also, we're gonna create the one hot encoder and response encoding. So for this, when we did the one hot encoder for my basically all the data set, which includes my training data, testing data, and cross validation data, and when we created this, we got 1967 column. You can see that it's huge, right? Now then after that, I'm gonna again apply my response encoding, and again I'm gonna call the same function which we have created above, and this is gonna return me only 9 particular columns for my variation. So I hope now I no need to explain in detail about what is happening here. Then after that, we're gonna build our model in the same way, just keeping my variation column. And again, the same technique, I'm gonna use one hot encoder, I'm gonna use SGD classifier, same L2 penalty, same logistic regression. I'm gonna run it for a different value of alpha, and when I'm going to run it, I'm gonna get this output. Again, I will look at the minimum value out of it. We will do a plotting of this part, and once we do the plotting, we will get the best alpha, and we will start generating the log loss for each. Now let's look at the log loss. If you look at the log loss, for my best value of alpha, my log loss for test, which is more important for me, is around 1.70, which is again lesser if I compare with respect to my random model. So definitely it is a good model. It's a good feature to look at. It's not a bad feature. So we may want to even look at this feature and will not ignore it. So this is also one way to look at if any of your column is important for the final output. But if I look at the stability point of view, then my percentage have gone down. So my test data have only 10.97% of overriding here, and for my cross validation I do have 11.4% of this. So this is a problem, right? So if you look at it, definitely this is low. So looks like this feature is not very stable, but at the same time, since my log loss is pretty low, if it would have been kind of nearby to my basically, or exactly kind of nearby to somewhere random model, I would have kind of ignored this particular column. I would have not considered it my final model which we are going to create. But in this case, maybe we are okay to kind of ignore that, because definitely if we look at this particular scenario, we though we have a less stable feature in terms of very less overlap is happening, but let's give priority to log loss and decide to keep this column for our case. So this is how you can look at this. Now after that, we have to look at text column. We will do that in the next lecture. Okay, so now let's work on the text data. So for working on text data, because text is going to be very huge in comparison to your gene or variation, so in this case, we have to deal with it in a different way. So we have created few functions for it. So like first function we have created to just get the count of each word, like how many times each word have occurred in this particular scenario. That is what we're going to take as the first step. Second function we have got for getting the response encoding. Now for text data, how we will perform this basically this response encoding, that's a question, because it's going to be huge for us. So let's talk about it. So again, we do have values from 1 2 3 and so on till 9. So this is my value. Now if I have to get the probability that the value is 1 given your text, this is how we work in the naive base, right? Now in this case, if I look at the basically the output for it, it is the value is going to be proportional to my value from 1 to k, and we will say probability of y is equal to 1 given basically your wi, right? So that's what we gonna have here. Now, so this is what we want to compute in this case, right? Now, this value can sometime can be very low also. This can be very small. So in order to handle that, we can take the log. So after we take the log, this product will get converted to the sum format. So this is going to look something like this. I'm going to take the log on both the side. So log of probability that y belongs to 1 given the text data, right? So, and because here we go with a naive assumption that everything is independent, so that's the reason we do that product. So this is going to be not equal to but directly proportional to, again this is gonna become like sum of this, because now when we take a log, this is gonna be sum, then log of probability is equal to 1 uh, given this word, right? So basically given words whatever we do have. So that's how we can do it. And then once we calculate this up, again we can take an exponent to get back the value in the appropriate format. So all these things we can anytime do. So again it looks very similar, there's nothing strange, but just want to show you that what this function is doing. You can see that here also we are computing the log, right? So that's for the same reason what we are doing it, and after that you can see that we are doing the exponent also. Once we got the log output, we need to again do an exponent to bring it to delog it, right? So that's what we're going to do in this case. So now these are the functions which we have created. Again, these functions, I'm pretty sure you might have already kind of created or used a lot during your machine learning course. There's nothing too kind of fancy about them. Then after that, we are going to build the one hot encoder, and when we are going to use consider text, maybe we may only want to consider the words in my one hot encoder which are occurring at least 3 times or more than 3 times. So that's the reason in this count vectorizer we are considering the value of mindiff as 3, so that this is something we can take care of, otherwise there will be too many columns going to come up. So this the whole code is remaining whole code is basically to get that one hot encoder. Quite simple, you can walk through it. And once we get that, we are basically looking at the total number of unique words, which comes out to be 54,007. And when we will apply basically and definitely you can see that this is going to be huge, right? And the same way we're gonna create for response encoding, and for response encoding also we will ensure that the sum of all these probability should be equivalent to 1. That's something we have to ensure even in response encoding. So that's what we are doing it here. So after we have done it, maybe if you want to normalize the code, you can also do that. So that's the next step we are doing it here. And once we have done this, this is how your values are going to look like. So you can see here that this is telling me that there are 5,732 values with which are kind of occurring, let's say 3 times. And similarly for the other, like the words which are occurring 4 times, 3,761 and so on. So this is the occurrence of word. Again, guys, I would strongly recommend you to go through each line by line, and we had made sure that we have provided all the comments to understand each and every line. You can see that for everything we have properly commented for you so that your understanding should be easier. But since they are very straightforward stuff, I'm not basically going line by line of code, because again I'm assuming that you already know some portion of machine learning. But as I said, it's if you have any problem, just feel free to put it in the discussion forum. We will be more than glad to help you out with this. Now, once we are done with this, let's build the model. The model building stage is going to be very similar. Now, we have again taken the L2 norm, again the logistic regression. We are going to use calibrated classifier. We are going to use one hot encoding, and in the end we're gonna get this particular output. Once we get that, we can look at again the same graph to look at the minimum value for log loss for comparative alpha. Once we have done this, then we are going to compute our losses, log loss, and you can see that this log loss is coming out for test set as 1.25. In fact, it's much better in comparison to what we have got for the variation set also, right? So this is performing much better. That means this column is quite critical. And then once we are done with this, we want to look at the overlap portion. For that, we have again written a function, and the overlap is also high. So you can see that 96% here and 98% here for test and cross validation respectively, which means that my text column is highly stable and very much significant. So all these three columns are highly important. So that's what this basically tells me up. So now once we are done with this, we will do some more data preparation before we apply our machine learning algorithm, because now we need to bring all these three columns together to work and build a model. So that's what we're going to do as a next step. So we will do that basically in the next lecture. Okay, so after we have understood that all the three columns are important for building my final output, which is class, now we have to do some sort of data preparation and some sort of functions which we need for the overall machine learning algorithms. So what we're gonna do, first function is simply to just report back your log loss, so that I don't want to keep on writing this code again and again, because we are going to build various models like Naive, Ken, and logistic regressions and so on. So I don't want to keep on repeating the same functions, same code again and again, and that's the whole reason we are writing it up. Second is plot confusion matrix. And if you do recall, this is exactly the same code which we had already seen it earlier when I created random basically model. So what I have just done, because we have to do create it again and again, now I created a function for it so that we can again and again recall it. And the role of this function would be that it's gonna give you back your precision, recall, and your accuracy, means your confusion matrix. So all these three matrix it is going to return, and if you look at it, exactly the same code. You can see that we have A, B, C, and these were exactly the same thing what we had created here. And the same function I'm going to call it in predict and plot confusion matrix function. So you can see that I'm calling this function here, and this function is doing nothing but it's gonna help me to do my prediction part, because my prediction code is also going to be common for almost all the algorithms. So that's the reason it's better to create a function so that I can use it again and again. Now, further to this, this is the function which is required only for naive Bayes, so don't bother about it much. It's just gonna tell you for a given index, and it's gonna print that what is the name of that particular feature. Okay, and we will also check whether the feature is present in the test point text or not. So this is a very simple, straightforward function which is just gonna we can see that it's written in if else loop, just to kind of look at and tell you that whether it's present in it or not. So we'll see in the naive Bayes part. Now the next thing is we got gene, we got variation, we got text. We have converted them to one hot encoding. We have converted to basically different sort of encodings here, right? We have done the imputation also, so with the response encoding, but here we need to combine them up. So we cannot just leave it as it. So let's say if A is one, basically this sort of value, B is this value, I'm gonna combine them up, right? Just think of it like this. Let's say the first vector which you are seeing, this one, let's assume that this is your gene, right? And let's say this value is your let's say variation. So I have to combine them like this, right? I need to stack them so that, you know, now this column, then this column, so concatenate these columns. So that's what we are going to do here, and we can do it with the help of hstack function. Once we go ahead with this, so this is gonna just create this, and I'm gonna concatenate both the type of calls, one gene, variation, and text for response encoding, and one combination we will do for one hot encoder for all these three types. So once we have done this, you can look at it and we can get this particular output, and you can see the shape of this part. So you can see here that for the train data one hot encoding, when I did, I got 56,201 columns, which is huge, right? Even my rows are lesser than the column number, and it's obvious because if you remember, my text column was having huge number of columns, and that's the reason in the final output I have this. But if I do a combination with the response encoding, I have only 27 columns because 999 for each, and that's the reason we do have only 27 here. So we are done with this, and after this we're gonna look at building the machine learning models. So we got our data. Now we will start shooting with respect to naive Bayes as our first algorithm, and we'll keep on comparing the results with various algorithms and see how it works. Okay, so now let's build the naive Bayes algorithm on the all three columns. Now we're gonna include the gene column, variation column, and text column, all three together. Now it's quite simple. We are actually building the models from a quite a good time. So we have already seen that how to do all that. So with the naive Bayes, again we're gonna choose the alpha, and we're gonna use the multinomial NB class because that's what we use it for multi-class classification. And we're gonna again fit the model. Again we're gonna do all those probability part. You can see that we are using PredictProba so that we can get the probability output, and here also we are getting the calibrated classifier for doing that, and we are using one hot encoding because naive Bayes is good when you work with respect to your text data, right? So if you do recall it on the text data, it's work good. So even you have a huge column, it really doesn't matter to naive Bayes because naive Bayes will still do quite well in that case. So in this case also we're gonna keep that, and we got all our log losses. So you can see that this is gonna return me log loss for various sort of alpha values, and we can check out this values. We can say that alpha 10 to the power minus 5, this is the value, and so on. Now if you check it, maybe my minimum value is occurring for alpha as 1, right? 1.28 is my minimum value. Maybe that is what we may want to choose it, and we can plot and also confirm the same, right? So this plot, as we are seeing it from so long time, we are also going to plot and confirm the same part. Now once we have done it with that minimum value, let's use it on the test data and see that how is my log loss comes out to be. So in this case my log loss for test data comes out to be 1.32. Now, one more thing we also look at is that for my train set, I do have 0.92, and for test set, I have 1.32. So this distance is okay, reasonable, not that huge. But let's say if my this log loss difference between a training set and the result what you got from the test set is huge. If the difference is huge, that means that on the training set definitely there was some sort of overfitting happening. So you need to go back and again look at that case. But here it's okay, reasonable, so we can accept this particular solution and go ahead. Now we got basically this part. Now let's test it on the testing data as well for this alpha, and we got this. Now what we are going to do when we are testing it up, we are also going to look at the confusion matrix, and let's see that whether it is giving us the better result what we were getting earlier with respect to your random classifier. So in order to do that, you can see this value, and definitely we want the diagonal values to be higher, and this sounds like it is giving me a good output. You can see that at the wrong places we do have a lot of 0 0. Yes, we do have some issues. For example, you can see this value 47. This is suggesting that there is definitely a good in fact we should look at this value. So this is definitely a wrong classified points which is happening, but let's look at this from the precision point of view. Precision gives us a very good idea. Ideally we want this diagonal value to be 1, but if that is not happening, it's okay, because in the ideal case that never happens. So here let's say look at this. So definitely there's a huge confusion happening between 2 and 7, right? And we also have a confusion happening between 3 and 7. So that's what is one of the case we can look at. And even at few other cases also if we see, but majority of the value are okay, right? They're not very much getting confused, and you can see here with this model we are getting a quite a good matrix at the diagonal side. So that's what is happening in this case. Let's go ahead and see further things. Similarly, you can also look at recall matrix, and in the recall also you kind of see the same trend. Like few places it is getting confused. Definitely you can see this 0.3 key, that means there's a confusion between 9 and 8 class, right? So that's what is still happening. Definitely we cannot come up with an exact good model. It never works that way. So that's something which we have to keep in mind. Now one more thing to look at is the interpretability, because if you do remember your business case, So business case was telling you beforehand that your model should also be interpretable, that you should be able to tell that why your model is predicting this. Now for doing this, if you remember, we have written that function above, get underscore important feature underscore names. Now in this part we are passing our data point, and you can see that let's say if I have taken any of the index where I got the prediction as 4 and my actual value was also 4, that means my model have predicted correctly. And the reason we got this as because we got the probability as this, right? So this is for 1 class, 2 class, 3 class, 4 class, 5 class, 6 class, 7 class, 8 class, 9 class. Now I can see that probability for the fourth class is highest, which is around 68% in comparison to all others. In fact, if you look at the further probability which is even close to it, is quite far, right? In fact, all the values are very far. Even this might be close, right? 0.08, which is almost just 8%. So this means that it is working really well here. But there might be few scenarios where might be this is, let's say, 0.68 and or maybe this is 0.5 and the second one is 0.4. Then it's quite close. Then in that case, even though we are getting the correct output, but we may want to look at again that what can be possibility. There is a confusion, so maybe you may want to look at those outputs because errors can be very expensive. So with this probability, you are getting a very good idea that how confidently we can say that, okay, whatever results I'm getting is really a good result or it's just a myth. Now you can see that here it is telling that basically we do have this point being present in this. So like we do have there's 10 text feature, function, protein, amino, experiments, all these are present in the test set. That's the reason we are saying that this belongs to this. So we are kind of giving the evidence that because these words are what we are seeing in this test data, that's the reason we are kind of going with this probability to be higher. So this is also a good idea because now think from a pythologist point of view, he will be able to understand this word. Maybe I will not be able to understand all this, it's too naive for me, but basically the pythologist will be able to understand, and by looking at these words he can basically get a good insight that basically whether why this confusion is occurring or why my model is predicting it to be the basically belonging to that particular class. So that's how we gonna get this particular output. So this is about the interpretability part. Now you can look at some data points again. So let's say I choose another data set. Here also we got the right output. So you can see that predicted 7, value 7. So like this is class 1, 2, 3, 4, 5, 6, 7, 8, 9. So here also you can see that my probability is coming out to be 64%, which is again quite good. So that's the reason it is predicting correctly. But you can again go back to your data set and look at any wrong classified data, which I'm also going to show you in further models as well. But you can see that why it is giving you the wrong result. You can look at the probabilities and see that maybe there might be some confusion due to which this have occurred. So this is a very nice case of looking at this. So again repeating what all we have done. So this is basically about your naive Bayes. So again repeating what all we have done, and what does this basically tells us that naive Bayes is working pretty well, right? So basically we do have computed the naive Bayes by starting at looking at the building the model. We created all this log losses, then after that we created this particular graph, and then we looked at all this log loss for each with respect to this, and then we calculated the log loss and created a matrix. One more thing which I also want to add here is you can look at this, that this portion is also telling me the misclassified point, means if you subtract it with 1 minus this value, you're gonna get your accuracy. So I'm getting almost like 0.38, which is almost like 0.62, right? That is basically is my accuracy. Definitely this is not the best, but let me tell you, this is one of the hard problem. Okay, this is not an easy problem, this is a very hard problem basically which we are solving. And though definitely if I say I want a perfect model, might all the diagonal values goes 1, and I would be more than glad and say that okay, this is the best model, means because this is what we definitely expect. So we have not yet reached to that level that we can definitely create an exact model which can give me 100% prediction, but trust me, if you are getting in this particular case an accuracy around 68, 69, it is actually quite good. So that's the advantage of basically working with these sort of things. In machine learning, you can at least have a prediction something better than just doing a random guess. So and here we are talking with respect to 9 classes. So here, if you are able to come up with this level, it's quite good, and plus it's a real data. So do not forget that it's not some made up data which I'm using in the class. So this concludes our naive Bayes, and we got a fair idea that what is the accuracy coming out, what is the log loss. Log loss is far better than my random basically part. So that means that this is working quite good. Great. Okay, so now we're gonna build for logistic regression. In fact, this is one of my favorite model because it's quite simple and can give sometimes very good results. Now in logistic regression, this time what I'm gonna do, I'm gonna do some oversampling. Why I'm going to do oversampling means what is happening here that we have noticed earlier that we had a lot of data in class 2, class 4, class 6 and so on, but there were few classes like class 8 and class 9 where we had very less data. Now due to this also we can have some impact. Now in order to resolve those impact, what we will do, we will try to balance the class. So there is a parameter which you have to just pass and it will help you to oversample. It will automatically just do a oversampling within the data and will balance all the class for you. So this is what basically do. Now if you look at this, so I'm going to create this logistic regression with both, one with balancing and one without balancing, so that you get an idea that what is going to be the difference between them if we balance the data set for all the classes and when we don't balance it, right? So that will be very interesting. So again, the same thing. Now I'm going to use one hot encoder. So again, the same thing. If you look at it's a LR technique with balancing. But one thing about LR is that you can work on the high dimensional data. So that's the reason we will go back to one hot encoding. Okay. So you can work with basically with this very well. It have no issue with respect to this. So now let's go back and see. So when we are balancing the class, you can notice here that we are getting basically this sort of log loss, and we have to look at the minimal. So it's very difficult to see it from here. So let's do it from here. So the minimal, the value we got is 0.001, right? So let's see to this. So even if you look at it, you can see that it's 0.001, and this is the place where my log loss is 1.10, and remaining log loss, you can see it's pretty high. Now if we draw a plot also, it's telling me the same thing. 0.001 we got the minimal log loss, and here we are just basically looking at a training test and this loss. So I'm not going into all these basically line by line of code, because again we are seeing this again and again lot of time, and you can see that we are again and again following exactly the same thing: SGD classifier, calibrated classifier. So we're not putting any such different things in this case. So we got the values here, and we got 0.61 as my train loss. So let's put it up here. 0.61 is the train loss. For my cross validation, I got 1.1. So let's put 1.1. And for my test loss, we got 1.06. So I got 1.06. And let's look at the misclassified point here. So if I come back and look at this, we got 35.33 as misclassified point. 35.33 as misclassified point. Now by now you can see that though my log loss is lesser here, right? If you compare this, definitely log loss is less, but definitely misclassified points are little more in this case, right? So misclassified are coming higher in this case. Here we have 33.83, here we have 35.33, right? So they are almost matching up, but let's go ahead and see a few more things before we can conclude anything up. So I don't want to do any conclusion here that my LR is working better than KNN also. But if my metric is going to be log loss, then definitely my LR is doing better, right? If that is going to be my metric, because that's what we want to basically hold in this case. So let's go back and again look at few more things. Like we have got this data sets. Now we got our log loss, and one thing which I want to show you up, that how you are putting into the code that it's basically going to be balanced. So you can see that when you put your SGD classifier, here we are basically putting the balanced here. Okay, class weight as balanced. This you have to pass this parameter and it makes your class balanced. So it takes care of all the overfitting and all that for you. Second thing is you can see that the loss I have put it as log. So basically when you say loss as log, it means that we are talking about logistic, because that's a logistic loss. So logistic loss, basically when you put, it's a logistic regression. But if I would have just changed this loss to hinge, then it would have become an SVM classifier. So that's the only difference between them. And you can see that in calibrated classifier, I'm always using almost sigmoid and it's all working, right? So that's a small change which I also wanted to kind of focus on. So once we got that, let's look at the confusion matrix. So my confusion matrix came out to be again in the same way. So you can see that we can see that we do have a good high values coming up basically on this part, and we do still have some concerns with respect to 7 and 2, but that's okay. There will be definitely some points, but definitely is doing far better. So again, this interpretations, now we have learned a lot, so we don't need to bother much about it. So we will almost every time we are getting same. Now here one more good thing about logistic regression is that it's very good in terms of interpretability. So when we talk about interpretability, it's kind of awesome. So in that cases, it's because it looks at the weights and all that, and based on those weights and coefficients, it basically gives you the interpretability. So this is a very simple function for achieving the same. And when we have done this, you can see that we are going to import this and again look at the interpretability. So even you can see that by my predicted class 7, we have gone through this multiple times. So you can see that for the 7th probability, we are getting 87.62, which is awesome, right? That's the reason my prediction is coming out to be 7. And these are the reason, like you can see that we do have 35th feature which is activated present in the test point. So this is basically the interpretability part. Even we can also look at an incorrect data where we do have predicted class to be 6, but the actual class was supposed to be 4. And you can see that here definitely if I look at it, 1 2 3 4 5 6, we got 48.27%, and that's where it got confused. But one very interesting thing, if you note here, that it's all, this is the place where this gets interesting. You can see that though my interpretability came out to be bad, because here since my sixth class was having 48.27 probability, that's the reason my basically it returned you that okay, it's a class 6. But at the same time, can you notice this part? Class 4 was also having 42.29, right? So definitely by looking at the probability itself, we could have said that yeah, there is a good confusion happening between these two classes because they are very close. So that's where it got, but it's not always going to be the case. Okay, so keep that in mind. It's not always going to be the same case where you are going to notice that it's gonna give you close probabilities. There is a chance that maybe one of the probability which you have predicted wrongly may be very high, but still it is going to give you wrong results, because again, machine learning is not a god. It can bring you closer, but you cannot say that it's going to give you the perfect results. Now let's come back and see a few more things. Now we have just seen it with respect to class balancing stuff. But what about if my classes are not balanced? I don't want to go with that parameter class balance set. I don't want to do oversampling here. So in that case, if we go ahead and look at it, we do getting basically some sort of this again the same part, and we can see that it's going to be minimal for 0.001. So let's go and check that. So we are going to get 0.001. Yes, we have 1.09 for this, which is quite less. And then we have computed again our train loss and this. And if you look at this, we are nowhere using the balancing part here. So the balancing is not true in this case. So in this case, we are getting the train loss as 0.61. So let's note down. So it's going to be 0.61, which is same. And this is for LR without balancing. Okay, and again we are going with one hot encoder itself. So this is what we have got. Now let's look at the cross validation. My cross validation comes out to be 1.86. 1.86. Can you see a red flag? I hope you can. And we do have I'm really sorry, I have written down the wrong term. It's 1.09. Okay, that's why I was thinking that it's a red flag. So it is going to be 1.09, and if we go back, it's going to be 1.07. So we got 1.07, and let's look at the misclassified points also as well. So if we go back and look at this, my misclassified is 34.77. 34.77. Definitely it's working better if I look and compare with respect to my width balancing. Okay, this is interesting results of machine learning, right? Sometimes it do happens that you can, when you thought that balancing will help, but it didn't much, right? Though the misclassified point have kind of reduced. At the same time, basically here if you look at your log loss is almost coming similar, right? So you can see that for KNN and both the LR, my log loss are very similar. There's not much difference here. So maybe we can go again with respect to whatever we want to. So, but this is giving me a good result. Means I cannot say that LR is working bad here. But definitely we would like to see other classifiers also, to see that if they can somehow perform better than them. So we have to still wait for that particular moment. So now let's go back and let's look at few more things here for this. Again, you can look at the confusion matrix. For confusion matrix, still we have some confusions happening, but there are few classes which are getting now very nicely classified with the value 1. Even for class 9 we are getting the value 1. And you can also see that these values are also higher, which is good. There are still confusion happening in 3 and 9 now, and 2 and 8. Okay, so there are still confusion, but you cannot skip that. At the same time, now let's look at the testing some points. So if you look at the testing, my predicted is 7 and my actual is 7. So let's go and see whether it's what's the value. Yes, and yes, you can see that this is the lower value. So that's the reason we are sorry, this is a higher value of probability. That's the reason we are getting this value. So it's almost going to be 86% probability, and we got the perfect output in this case, right? So, and this is the interpretations. We have already talked about interpretations a lot, so we need not repeat it again and again. So we got basically this result with respect to my LR results. Now, further to this, we are going to look at SVM models. We will see that how linear SVM is going to work in this case. Okay, so now let's talk about random forest. So in random forest, though it will be good idea if you go with response coding, but sometimes even one hot encoder works well. So, but definitely we want to like to keep the dimension less. But let's do one thing, since it's a very good model, in fact, because it tries various things up. So I would suggest you to go with one hot encoder as well as response both, and we will see that how my results will look like. So what we will do with this model is with one hot encoder part. So we are having two hyperparameters this time. So one is going to be a depth and one is going to be an alpha parameter. So now what we're gonna do for this case is that number of estimators we're gonna keep, and the maximum depth we both want to find out. So definitely this algorithm may take little more time when you're going to run it, because as you are aware, random forest do take some time when you're going with this. Now what we are going to do, we are going to put this, and we are using the criterion as Gini, and we are fitting the model again using calibrated classifier. We are using the log loss. Now we are getting this result. Now when we are seeing this result, you can see here that my basically my value, I need to search that which is going to be the best. So for 200 best estimator, we are getting the log loss to be minimal. So let's go and check that. So if you look at 200, you can see the log loss is 1.14 and the remainings are pretty high. Now you can see here that with this value we have calculated our train test and cross validation loss. So let's put that. So for train loss we got 0.71, and so let's put it. So 0.71. So the space is filled up, so I need to create a new table now. So here I'm gonna say random forest, and this is for one hot encoder, and this is going to be my train loss. I do have a test loss, or in fact again I'm doing the same mistake, cross validation loss. I have a test loss and misclassified points. So this was 0.71. Let's go back, and we do have 1.14 and 1.12. So let's put it 1.14, 1.12, and let's put the number of basically this is the point which we have got in this case. Now if you compare this particular portion with respect to your with your previous outputs and all, you can notice it that we are definitely not performing that well in comparison to the last part, right? So if I go back to my earlier page, we do have got the log losses of 1.06 and all. So what we will do, we will explore this component again in the next lecture. And also what I'm going to do in the next lecture, I'm going to also tell you up that how to work with this log, basically with respect to this log losses and all, when we are using the response coding, and we will see and we will compare both of them and see that how well it is working. So we will do that in the next lecture. Okay, so now let's understand that what are the things you would need to solve this problem completely. Now, first thing is you need the data. So in order to get the data, you have to first create an account from Kaggle, which you definitely need it here. And once you're done, you can go to your data tab, and from here you can get these two files. One is your training text dot this part, and even your training variants dot zip. Okay, so this will be a zip file. You can unzip it and can start working. So these are the two files which you need to work on it. So again repeating, you have to get training text dot zip and training variants dot zip. These are the two files which you will need to work on this part. Now second thing is that once you get the data, you should always look at the discussion forum. This is one of the place from where I learn a lot personally, and I would definitely recommend all of you to please go ahead and kind of look at the discussion forum. There is a lot of discussion which keeps on happening between people, like they have some doubt, maybe that's your doubt as well, and there will be people answering that, okay, if you get stuck in this place, then how you can proceed, or you can post your questions and you will get very interesting answers. So this is one place from where I have myself learned a lot, and you can even look at the leaderboard who is working on what. And this is the things which you will definitely need to work on this part. Now in this discussion forum, even you can see that this Iker, this guy is, I think he's the organizer of this, so you will get to know a lot of understanding about the problem statement. So it do happens a lot of times that when a problem is given, since you are not even a domain expert into, let's say, medical domain, so these organizers comes and kind of give even more detailed explanation about the problems. Or if you are not able to understand it, then you can really post it out, and they would really help you to understand all the problem statement. So this is an interesting thing about it. So I would strongly recommend you to go through this discussion forum. Secondly, even I would like to credit a lot of people who have even contributed to their solutions. In fact, a lot of solutions I have personally gone through in GitHub accounts. So it's very easy to search for them. You can just go to Google and type this problem statement name and type GitHub. There will be a lot of people who will be putting their own solutions. In fact, I would like to credit all those people who have put their solutions on basically GitHub, because even from them I have learned how to solve this particular problem, and using that knowledge I was able to design a nearby solution to it. So I would not say that this is completely coming, the whole solution is completely coming through me. In fact, I would wholeheartedly thanks those people who have given the best solution into the GitHub accounts, and I kind of looked at them, learned through it, and created the one of the whatever the better solution I could think of, and kind of providing it to you, so that you can even think like a winner, that how generally even winners of Kaggle thinks and approach the solutions, and why basically they were able to win that competition. Because even the people who kind of win the competition, they post a lot of solutions on GitHub, and that's a very good way of learning something. Never feel shy even once you become an expert into this domain. Never feel shy to even learn from other people. That's one of the very good idea in machine learning. Even today, I have developed this habit of going through at least one or two GitHub accounts on daily basis, and try to learn their solution, what is their approach. And sometime I just feel, wow, what an excellent solution this guy have given. So I would recommend you to do that. Now Once you get this data and this, you need to really understand that what is this data first. Let's explore this, and then I will explain you that given this data set, once we understood that, what is this real machine learning problem we are trying to solve, right? So we need to really fit in this problem into the machine learning box. Otherwise, there's no point of solving it. So we need to really fit in all these things into machine learning part. Now, one thing which even we have told in the kind of in our introduction video also is that we are kind of assuming here that you guys already have the machine learning knowledge. If you don't have it, you need to go back and kind of learn that topic, because this is an advanced level course where we are expecting that you really know that what is supervised learning, what is the unsupervised learning. This is called as classification, this is regression. So at least we expect you to have the basic knowledge of machine learning. Any advanced level concept which we are going to introduce, I'm going to give a detailed explanation of it, so you need not worry about that. So for anything which we feel that yes, it makes sense for us to kind of give you the solution of or give you an explanation for that particular topic, we are definitely going to do that. So you need not worry about any advanced topic kind of solution, because we know that generally when you walk through any course, what are the things generally instructor kind of cover, and what are the things instructor do not cover. So but I'm really sorry to say about this. When you go to the real world, a lot of things which people do not cover is really important, and you will really notice this while working on this first case study itself. Means when you will solve further, you will realize much more things to come, but at the same time you will learn about it, that definitely there are a lot of important things which maybe books will not teach you. The beginner level books or maybe the beginner level instructors will make your life easy to understand what is machine learning, but at the same time those complex details will be kind of skipped out. So we want to bring up all that, because we do want to bring up all the experience what we have learned while solving those real time projects, so that you do not face that difficulty once you move into the industry. So with this, let's start understanding the data. Let's start shooting, at least get an evaluation, get some insight on that data, and then we will try to convert this problem into a machine learning problem. Now, going ahead with this, let's first analyze the data. So yeah, this list seems to be huge, but yes, you do need all these packages. But I would strongly recommend, in case if any place you get an error, because it's a high probability if you execute this import statements, you may end up with a lot of errors here. But really do not worry about that. As in when you get any error, you know how to install those packages. You just look at those packages name and say pip3 install package name or conda install package name, right? So whatever way you have done your installation, just do that. So no need to worry. So even I have put this comment as well: if any of it failed, do not panic and just use this command. So I've given you the commands and all. Just look at the error and accordingly just install it, because there's a high possibility that you might not have already all these packages being available to you beforehand. So it's a very common case, no need to worry about it. Once you are done, then the second thing would be to kind of load this data set. Now, once you have downloaded this data set, you, let's say, have created a folder. So what I have done is, like, we got these two data files, right? I told you two zip files, training variant and training text. Now what we are going to do with this is, I have unzipped them and created a training folder, and inside that training folder I have kept both these files, okay, so that I can just go ahead and start using them up. Now one thing is that this we are going to use pandas. So again, we are going to read it by using read underscore csv, and the first file will be loaded as a data frame, and the data frame name is data underscore variants. The second data file was training text. Now here, if you will go and look at the data is separated by a delimiter like this. Okay, it was not separated by comma. Like if you look at the training variant data set, it's going to be separated by comma. So I need not define the delimiters and all. But here in this data set, I do really need to define this. So that's the reason you can see that, and we do have like ID comma text to it. Now let's go ahead and try to explore this data. Okay, so let's see that what all is going to be present inside this data. Now, in order to get that, so first what we are going to do, let's explore the data variant file. Now in this data frame, as soon as we did a head, we can see that we have ID, gene, variation, and class. Let's understand that. Now, this is the class we were talking about, right? So I told you that there can be cancers of various type, which means the cancer will be from 1 to 9, okay? And this is where we are interested in that given something new coming up for you, you want to basically look at the gene, the variant, and the research papers associated with it, and you should be able to tell that, okay, this is going to be my class, right? Now, here in this data set, I do have gene, I do have variation, right, which we have talked about. But I was telling you that we do have gene, we need variation, and we need the class, right? Sorry, research paper, which let me call it as text. And then we are interested to predict about class, right? This is what the problem we want to solve. Given any new gene, the variation associated with it, and the research paper, like all the text data related to it, and I want to predict which class it belongs to. Now, in this first data, I do have gene, I do have variation, and ID basically it tells this ID is also there for to link the mutation to the clinical evidence, right? So this is what we do have. So definitely in the second data, we will be having all that text information, which is going to be coming from the research work, right? So this is how the data was collected and given to us. So let's go step by step. Let's not hurry up in understanding this problem statement. Now, the second thing is that so once we are doing this analysis, when we look at the information here, so we can see that we have ID, gene, variation, how many non-null values are there, every detail is mentioned here. Let's do a description of it and we can see the mean, median, 25% percentile, maximum, minimum, all these values you can very easily do that. Now, then you can look at the shape of the data. This shape is telling me that how many rows I have in my data set and how many columns I do have. Now, definitely when we talk about column, we do have columns like ID, gene, variation, class, right? 4 columns. That's the reason you are seeing this value as 4. And I do have 3,321 entries into my record. Now these are the column, right? So as I just said that we have 4 columns, so we can see it with the help of columns function. Now let's explore about data text, means my second file where we do have the text data coming up. Now here you can see we do have ID column and the text. Actually, if you look at this text, this is going to be huge data. I would strongly recommend you to open that file, data file, and see that. It's going to be a huge data. And you will notice that it's a research paper, so it's going to be huge text being associated. But one interesting thing you can notice that ID is common between both the data set. So I can definitely do a merge operation and then I will have gene, variation, and text all things together. And using this, I will be building my model, and then later we are going to kind of, for any new data, we're gonna look at our predictions. That's what we're gonna do. So let's look at again some more information, like we can do an info again. Can you notice something interesting here? This information is giving us some idea. Can you identify that? If you look at it, this is giving me an idea that in text we do have some missing values, right? Without doing any analysis on this data, we can still analyze just by looking at the info that yes, we do have some missing values. So we will see that how to deal with that later. Now let's go ahead and understand few more things. We can do a describe again to try to just do some statistics for the data. We can look at the column and we can look at the shape. So in short, my data set looks like this, right? So if you look at this data variants, this included my ID and gene variation and class, and data text includes my ID and this research paper text. Now in further videos, we gonna go ahead and try to understand that what we can do with this data and how really, what is the kind of problem really now we are going to solve, right? So we first understood that yes, this is a Kaggle related problem. What is the real problem the people are facing and why they want to automate with machine learning. Then we looked at the data set, tried to explore it by using our pandas data frame and got some insight about the data. Now the next step would be we will try to infer from this data set or this problem that how basically it fits in the machine learning world. What is the real machine learning problem we have to solve further? So that is the one next step we're gonna follow. Interesting project which is related to investment requirement by a company. I have given a random name to it called as TechLove, which is our own company name. But this is going to give you a good learning from the perspective of whatever you have done till now in terms of your data analysis. So you have to kind of apply a lot of skills in this project coming from NumPy, Panda, your data analysis skills, how you can plot some interesting graphs. Uh, Basically, all these things you will be kind of using it across. Definitely, this project will not require any sort of machine learning. So I hope this will give you a quick relief now that okay, we are not going over a machine learning project. This is a complete data science project which will require a lot of analysis and help you to understand how to explore with data, how to deal with data with different ways. If you look at the project description itself, this is almost like 12 pages of this PDF file. This project description will be uploaded for you, so you have to definitely walk over this completely first to understand the requirement first. I'm just gonna read it out so that you get some understanding, and wherever some explanation is required, I'm gonna explain that. But at the same time, this project is uh, explanation I have properly put it here so that you don't face any trouble in understanding this. So let's understand. So let's say you work for a company called as Tekla, which is our company, and let's say that this is also doing something other than education, which is an SS. This is also going to handle the asset management. You can think of it like investors who kind of come and invest into some other companies. So TechLove want to make some investment in few companies, and the CEO of TechLove wants to understand the global trend in investments so that she can take the investment decisions effectively. So that's the idea behind it. Now, so they just don't want to randomly go and put their money on some company. They definitely want to ensure and follow some strategy before they can put their own money on it. So let's understand the business. So what is the requirement from it? So there are two minor constraints for investment. They are not really minor, but yes, they, let's call it minor constraint here. So the first constraint is that TechLove want to invest between 5 to 15 million US dollar per round of investment. Not so low, not so high. Maybe TechLove is not that rich, but it's not so poor as well. So they want to invest between a range of 5 to 15 million USD dollar. It want to invest only in English speaking country because in our group there is no one who know any other language apart from English. So that makes the communication more easier when they will be interacting with that company. Now for our analysis, consider a country to be English speaking only if English is one of the official language in that country. For example, if I say India, so though in India there are lot many languages which are prevailing, but English is one of the official language. So we would consider India as English speaking country. So if you want to get the list for all the countries who are English speaking, you can just click on this link and you will go and check which all countries are going to be your English speaking countries. Okay, so let's go ahead and understand few more things. So these conditions are going to give you sufficient information for your initial analysis. But before getting into specific question, let's understand the problem and data first, because that's a very important point. Whenever you work on any project, be it machine learning, data science, or anything, you have to always first try to understand the data and the problem statement. This is a very important thing. So now what is the strategy we are going to make here? So the TechLove want to invest where others investors are investing. So this is the pattern you will notice that most of the early investors adopt. And since TechLove is also one of the early investor, so maybe they also want to adopt the same thing. Like wherever everybody is going, I will also take the same path. I don't want to take a unique path. So that's basically is an idea here. Now, where we have got this data, so this data is coming from a real investment from crunchbase.com. So the insight what you're gonna get is going to be very useful, and basically this is going to be kind of the project which you have to kind of work with me along with me, so you can call it a group one, but it's up to you. And I would strongly recommend, if you have a friend with whom you are doing this course, I have a strong recommendation that try to solve this in a group, because definitely this is will be, you will get better insights if you will be solving these things while discussing with somebody else, because you can come up with some interesting idea. Now you might be wondering, but you are going to give me a solution, then why I need to interact and discuss with my group? No, you have already learned about data science. You have already learned that how to work with NumPy, Panda, ED and all that. Now you really don't need to look at the solution on this. I would strongly recommend that once you understand the problem statement in the data, which I'm going to explain you in this video, and after you walk through this PDF, I would strongly recommend you to try to solve this on your own, because unless and until you give a try on your own, it's completely useless that to even look at this project solution just like that. Because if you look at the solution and try to come up and basically then start looking at it, it may not make much usefulness in terms of your learning. So I would strongly recommend you that, and trust me, this project is going to take some time. So maybe you have to invest a day or two completely focusing on this project, looking at data. There will be a lot of challenges I have put across in this, and it will take some time. It is not going to be like 1 or 2 hour of traditional project. It is definitely going to take some time. So I want you to basically spend a day or two on this complete project after understanding it. And if you have a friend, work in group. This is my strong recommendation. So maybe if you have a friend who is working along with you in this course, then probably just get him along with him and work in a group, devise a strategy and work on it. That would be my insight. That's the reason I have put it as a group project. Okay. So there will be some files which we have, and what I'm going to do is right now I'm holding up that files. So there will be mapping file, customer files and all. But what I'm doing is I'm right now holding that information to be spoken up here, because I'm going to explain that little later. So even you can see the data standing from NumPy notebook when I'm going to explain you what is this data all about. But for now, let's focus on few more things. So basically, though I've written it like 3 files, but ignore it for now, because this is intentionally being left blank. But here the basically definitely the thing would be that I would strongly suggest that you go back and see that what kind of data you have. So let me give a small brief about it. As I said, there will be 3 files. One will be related to your companies. So this will be companies.txt file. So I'm talking basically from here, okay, this files, and companies.txt file. Second file is going to be rounds2.txt file, and the third file is going to be mapping file. Okay, and don't worry about this file because I have not yet put the explanation here in detail, but later we will understand that. Now let's go ahead and go over a few more things here. So what are the business objective here? So business objective is pretty straightforward. The objective is to identify what are the best sectors, countries and suitable investment type for making investment. The overall strategy is to invest where others are investing, as I told you before, implying that the best sectors and countries are the one where most of the investors are investing, right? As I told you, wherever the crowd is going, I want to follow the same path. Now, what is the goal of the data analysis? There are 3 major categories where I've divided this problem. First is investment type analysis, which is comparing the typical investment amount in venture, seed, angel and private equity. If you don't know about these things, you can read on Google, but I'm going to give an explanation in some time. So that TechLove can choose the type which is best going to be suitable for them. People coming from little bit of startup background, they might be already aware what is venture, seed, angel and private equity, but we will see that. Second is country analysis, that is identifying the country which have been the most heavily invested in the past. These will be the TechLove favorite as well. And the third one is sector analysis, understanding the distribution of investments across the 8 main sectors. Note that we are interested in 8 main sectors provided in the mapping file. So remember I told you the 3 data files which I have, there is a mapping file. So in that mapping file, the information related to sector is there, and from there we will be interested in the top 8 main sectors. So the 2 files, companies and round 2, which are the other 2 files per there, they have numerous subsectors there, okay, and hence you will need to map these each subsector to its main sector. So now basically you are getting some insight about the data as well. So you will notice that basically in rounds 2 and companies you will have some subsectors information names, and basically in the mapping file also there will be some information, so you need to probably join them in some way. Now let's look at the company's detail. A table, basically I'm talking about now these data files, okay, I'm going in the explanation of them. So basically there's a companies file which is the basic data for all companies. There's a sector classification part where you have mapping.csv file. This file is going to map the numerous basically multiple category names in the companies table, such as you have 3D printing, aerospace, agriculture, etc. And you will be doing it to 8 broad sector names. The purpose is to simplify the analysis into 8 sectors bucket rather than trying the analysis hundreds of them. So that's basically what's the idea behind it. Now let's go to the problem 1, which is the data cleaning. Okay, definitely when you get the data in data science, it's very important that you first look at the data and do provide some cleaning. If you just directly jump to start doing any other thing and do not do a cleaning and bringing the data in the proper format, you are actually not doing the right stuff. Okay, so make sure that you do a data cleaning. So in data cleaning, you have to first load the companies and rounds data. I'm not asking you to yet right now use the mapping data file. This will come little later. Into 2 data frames and name them as companies and round 2. Though I have specifically mentioned it here, but feel free to change it to your own name. That's perfectly fine. Now this is the table which I have given, and you need to fill up some records to it. So what you could do is that fill up all the answers here and then see that how well you're matching your answers with mine, which I'm going to provide you. Now, how many unique companies are there in round 2? That is what is the first question. How many unique companies are present in companies? That's the second question. In the companies data frame, which column can be used as a unique key for each company? Write the name of the column. Now, the fourth question, are there any companies in round 2 which are not present in companies? Do this carefully. There is a catch here. Merge the 2 data frames so that all variables or columns in the company's frame are added to rounds 2 data frame. Name the merged data frame as master data frame. How many observations are present now in master data frame? This is simple. You can easily do that. So this is what you have to do in problem 1. Problem 1 is quite simple. Okay? Because here you're just doing a data cleaning and making, if you're answering this perfectly fine, that means your data cleaning have happened properly. This is kind of a check that have you done the data cleaning properly or not. This is the problem statement 1. Let's go to problem statement 2. Now this is the first of 3 goals of data analysis, which is your investment type analysis. The funding type such as seed, venture, angel, etc. Depending on the type of the company, which is either a startup or a corporate, its stages, either it's a early stage startup or a funded startup, or the amount of funding, whether it's a few million USD to billion USD and so on. For example, seed, angel and venture are 3 common stages of startup funding. Remember I told you I will come to that later. This is the point now. So let's talk about what is the seed, private equity and so on. So starting with seed and angel funding, this refers to early stage startups where venture funding occurs after seed or angel stages and involves a relatively higher amount of investment. Private equity type investment are associated with much larger companies and involve much higher investment than venture type. Startups which have grown in scale may also receive private equity funding. This means that if a company have reached the venture stages, it would have already passed through the angel or seed stages. Okay, this stage only happen after angel or seed stages. Now, TechLab want to choose one of these 4 investment type for each potential investment they will make. Now, considering these constraints for TechLab, you have to decide one funding type which is most suitable for them. Remember that constraint, English speaking countries, and the 5 million to 15 million kind of decision. So now calculate the most representative value of investment amount for each of the four in funding type, which can be venture, angel, seed, and private equity, and report the answer in the template provided in the previous page. So basically you will notice that I think I have provided it earlier somewhere. uh, so basically this is what you have to anyway answer, and what I will do is I will provide you a sheet separate if you want to, where you can fill up. Otherwise that's completely fine. I will provide you some sort of Excel sheet where you can put it up. So this is your problem number 2, right? So remember that. So here what you have to do is you have to basically fill up all these details for this part. Now let's look at so there's a problem part 2 also. So let's do one thing. So you have to finish up till problem 2 here, and basically this problem type part 2, basically I will be adding up separately for a section. So this is being left out intentionally. I'm gonna put this part in the notebook itself, because there are sometimes what happens, the client have explained the problem and suddenly they say that, okay, can you try this and let me know what to be done in this case. Maybe this means that requirements sometimes keep on getting added from the client side. So this do happens, and that's what I want to show you in this particular case study as well. So while going to the notebook, I'm going to talk about it. That's the reason it is intentionally being kept like that. Now let's go to the country analysis. This is the second goal of analysis, country analysis. Now that you know the type of investment suited for TechLove, let's narrow down the countries. TechLove wants to invest in countries with the highest amount of funding for the chosen investment type. This is part of a broader strategy to invest where most investments are occurring. So TechLove want to see the top 9 countries which have received the highest total funding across all sectors for the chosen investment type. For the chosen investment type, make a data frame named top 9 with the top 9 countries based on the total investment amount each country has received. So identify the top 3 English speaking countries in the data frame top 9. Remember that I'm talking about English speaking countries. There is a possibility when you will be solving this problem, in the top 3 countries, there will be countries which are non-English speaking as well. So you need to make sure that you remove them up. Now this is the sheet which you have to fill up. Okay, so this is the sheet which you have to fill up for case study 3. Now you also know the 3 most investment friendly countries and the most suitable funding type for TechLove. Let us focus on funding the best sector in these countries. Now let's go to problem number 4, which is your sector analysis 1. Now this is the third goal of analysis, which is sector analysis. Now basically here when we say sector analysis, we are referring to one of the 8 main sectors listed in the mapping file. Note that other is one of the 8 sector as well. Also there are 8 sectors if you consider the category blank as missing value. Okay, so there's a missing value part. You can take a call on this, that what you want to do with that. This is to simplify the analysis by grouping the numerous category list named as category list in the mapping file. For example, in the mapping file, category list such as 3D, 3D printing, 3D technology, etc. map to main sector manufacturing. Now also for some companies, the category list is the list of multiple subsectors separated by a pipe. For example, one of the company's country list is application platform, real-time, social network, and you can notice that they are all separated by pipe. But what you have done is when you discuss with your CEO and come up with some business rule, that the first string before the vertical bar need to be considered. So what we decided is, though it may look huge like this, but I'm going to only consider this part. I don't want to consider this at all. I'm going to remove this. So that's the main thing. Let's say our CEO have decided that this is what we would like to follow. So what we would like to do is extract the primary sector for each part. So we will only extract out this and work on this part and use the mapping file mapping.csv to map each primary sector to one of the 8 main sectors. Now, what are the expected results in this? Code for merging the data frame with each primary sector mapped to its primary sector. The primary sector should be present in a separate column. If you're right now thinking, oh, it become already a huge project. Yes, it is. It is becoming a big project, and that is how in real world you are going to get the problem statements. It's not going to be a small data with cleaned up everything. You just go and start doing. No, it's not going to be a cakewalk. It's going to be like that. And though I'm just reading it out because already I have put across all these things in a very simple words as much as I can, but at the same time, definitely feel free to again, while I'm explaining each and every problem statement, maybe you can go back and read the whole statement again from your PDF given to you, and then if you have maybe you can even attempt the solution along with that and see how close you are getting to the solution file. And then anyway, you can always look at my video solution which I'm going to provide you to understand what exactly to be done. Let's go to the problem number 5, which is sector analysis 2. Now it is going to go a little tougher. Okay, now you have a data frame with each company main sector mapped to it. When we say sector analysis, we refer to the 8 main sectors. Also, you know the top 3 English speaking countries and the most suitable funding for TechLove. Let's call the 3 countries country 1, country 2 and country 3, and the funding type FT. Now remember that the TechLove is preferring between 5 million to 15 million US dollar. Now the aim is to find out the most heavily invested main sector in which in each of these 3 countries. For funding type FT, an investment range of 5 million to 15 million USD. Now what you have to do in this case, you have to create 3 separate data frames, maybe name them as D1, D2, D3 for each of the 3 countries containing the observation of funding type FT falling within the 5 to 15 million USD range. The 3 data frames should contain now your column of the master frame along with the primary sector and the main sector. Second thing is total number of investment for each main sector in a separate column, and the total amount invested in the main sector in a separate column. Using the 3 data frame, you can calculate the total number of amount of investment in each main sector. Now, what are the expected results in this case? 3 data frames which are going to be D1, D2, D3, and basically based on your analysis, and there is a table 5.1 which I have created, which you need to fill up actually in this case. Okay, so based on your analysis of sector, which main sectors or countries would you recommend TechLove to invest in? Present your conclusions in a presentation. When I say presentation, I really mean that maybe you can pull up into the sheet or whatever way you would like to convey your result. The conclusions are subjective, that is, there may be no right answer. Keep this in mind. Every data scientist is different, every data scientist can come up with different results. But it should be based on the basic strategy, invest in sectors where most investments are occurring. Now note, this is your table which I have given to you already. So fill up all these answers. There are a lot of questions being available for you. Now the last one is you have to plot few things. Plot is also not that straightforward. Definitely you need to do some work. So a plot showing the fraction of total investment globally in venture, seed and equity, private equity, and the average amount of investment in each funding type. This chart should make it clear that a certain funding type is best suitable for TechLove. Second is plot showing for top 9 countries against the total amount of investment for funding type. This should make the top 3 countries very clear. A plot showing the number of investment in top 3 sectors of the 3 top countries, and this is what you have to do. So the expected result is going to be 3 plots. So we have talked a lot about this project, right? If you are thinking this is too much information to grasp right now, it's completely okay. You can listen to me once again, or as I suggested you earlier also, please review this problem statement once again. This is intentionally created like that because in real world you're gonna get the problem like this. Now, what you are expected out of it is, once you understand the problem statement, try to come up with your own solution. Spend a day or two, don't try to cheat. If you're cheating, you're cheating yourself. As I suggested you, go and work in group if it's possible. Pull your friend along with you in this course if possible. This is going to really help you, both of you, if you're working in a group, because you have already seen this course is complex. This has a lot of information. So when you discuss and solve these kind of problems together, it makes a learning even far better. So maybe you can pull up your friend, see that you both discuss, come up with your own solutions. And one more thing, I strongly recommend after you solve these problems, see if you can prepare a nice presentation out of it. Means, let's say, imagine that you are working for TechLove right now, really, okay? And then you have solved this problem. Now TechLove don't want to see your code, right? What TechLove would be interested in? How well you can present a solution to them so that you can tell them, okay, I have seen that you may well do well in US because of these reason. So maybe you can prepare a nice presentation for yourself and feel free to post it into discussion forums and let the other students view that what you have nicely created in this project. So maybe your answers might be different from mine also, which I'm giving, and just put your thoughts in a presentation. Prepare a presentation, name the PPT as Tech Love, means keep the background also for Tech Love so that it should look professional. That yes, you have prepared a professional presentation for Tech Love and you're going to present it. This is also going to give you a nice way of different way of learning and understanding. Very fun to watch. Let the other students also come and kind of put some review for you and tell you that this maybe you can improve, or this you might can improve. So look at, for the students who are not able to prepare that presentation, maybe you can look at least other students and see that what they have done, and maybe you can suggest something better. That would be a nice way of learning. So now in the next lectures, we're gonna walk over the solution. But again, a very important point, please do not cheat. Try to solve it on your own first. Okay, so now let's come to solution. I am really expecting that you have tried this on your own and then coming to it. But in case if you have not, no issue. We will now understand this problem statement. So we will see that how to work on the data cleaning first, and we will understand the data also, like companies and all that. So what we will do is, in the first cases, if you remember, we need to only work on rounds and companies. We don't need to bring up the mapping data file. So what we have done is we have loaded this data set. So first we imported all these packages, and then further to that we are loading this rounds to CSV and companies.csv. Now you will notice that in companies.txt we have a separator of tab, and in rounds.csv we do have a comma separated, so it worked well. Now you will notice if you don't use this, if you have tried this already, you might have seen if you would have not used this, you would have got an error in Python. So what you have to do in order to solve this, you need to apply the encoding. And in encoding, this is the very common thing which we use, ISO 88591. So this is a very common encoding what we use in Python side. So this is what even I have used it in this case. So here we basically will encode and start working on it. Now let's look at the data, that what exactly my data is gonna look like. So first thing is we gonna look at the rounds data. So in the rounds data, you can see that we do have all these company names, which is permalink. But you have even the details of like funding rounds, like whether venture round, seed round, what kind of funding, like A series funding, B series funding, C series funding, when it was funded, and what was the amount being raised, right? So this is all the data what you have. Now, if you go ahead and do the info for it, you can see that we have almost like a lot of entries being available in it. We have like 114948 entries total. Now let's look at also a few more things. You will notice that found running code, and basically these part also have some sort of missing entry, because you can easily make out from info also, right? You can see here. So if you would have seen, sorry about this. So let me just bring this down. So what you will be doing in this case is, if you see this amount of data, right, this part. So this is like 1149, but you can see that here we have less values. So that means that we do have some missing entries in this case. We have to deal with them. Okay, so we will see that how we can deal with this scenario. But this is giving us an intuition that yes, we do have some missing entries. Now, let's go ahead and look at the company's data. In the company's data, if you look at, this is related to all the companies related information. Like we have permalink here, which you can see the organization frame, name of it, homepage URL, category list, status, country code, status code, region, and so on. Right? So these are my company details being available with us in this case. Now let's come down and try to infer a few more things with it. Now, let's look at the structure of my company's data. So this is going to be my information for this. Now what we are going to expect from here is, so there may be few companies which are there in my company's round, but basically they may not be in the round part. Basically maybe they have not got any sort of funding, right? So in the rounds company data frame, maybe we don't have it. Or you might notice that we might have more data in rounds data frame, because there is a possibility that in rounds data frame one company is occurring two times. Maybe a company A is getting series A funding and series B funding both. So both the information will be available in that case, right? but in companies round there will be only one entry for that company A. So that is what can be a possibility when we will see the data. So let's go and explore. So what we noticed that in companies data frame we got 66,368 unique entries. So this permalink is basically nothing but your company names which are coming up. So when we did the unique of it, we noticed that there are 66,368, and if you will go up and see that, you will notice that this is exactly the same amount of data we had, right? Now you can see that this is basically the part. Now if you will, what does this mean for us? This means that this is a unique column, right? You can even check it from here. In companies info also we had permalink 68 to 68, and the unique also came out to be the same. So it's a primary column. It's kind of a unique column which is non-repetitive in nature. Now let's go ahead and see a few more things. So what you might want to do is, because there's also a possibility that if you look at this data, maybe somewhere it might have been mentioned as something else, and in some other case it might have been mentioned as something else. So what we could possibly do in this case is, if you look at this part, we are getting like organizations frame and so on, right? So maybe there's a possibility that this is written as capital O here, and in some other side it is written as small o. So what we need to do, we need to bring everything to lowercase so that things becomes normal. So what we can do in this case is that we can come here and look at this data, and what we have figured out in this case is that we basically are getting here all the lowercase, and now you can notice that everything is lowercase. Now let's look at a unique column. It's all set, so that means there's no problem. But yes, there could be a problem in the rounds data frame, so we need to have to do this. Now let's look at a unique in the rounds column, and you can see that we got 90,247. This is too much, right? If it is not comparable with this, we were expecting 66,368, but it is more than number. So what we can do is, let's, maybe there's a possibility that it might be happening due to lowercase and uppercase thing. So what we will do is, we will convert this also to my lowercase, and when I will convert this to my lowercase, you will notice that again everything formed a lower number. And here you can see that when we see this length, we got 66,370, but there is still a small problem. Problem is, we were expecting 66,368, right? 66,368, that was in company, but here are two extra. Now you may say that maybe this is occurring because there is companies which may be extra, and maybe we don't have any metadata for them in companies. This will be troublesome, right, if we have that, because then in that case maybe we have to remove those two extra companies that might be coming in your mind, so that we both the data frame have the same number of companies, at least with respect to name. So but before that, let's do some analysis. Let's really see that is it really a problem, because there is a might be some other problem also, right? It may be possible that both the company names are same, but this is all happening because of some Python problem, and actually that will turn out to be. So we will see that what we analysis we will do. So for doing this, what we can do is, maybe we will try to see that what are those two extra companies which are there in my rounds. Let's explore that. So we have written a code for it, and you can see here that what we are doing for this, we are looking at basically the all the rounds company permalink, which is basically a part of it, and then we have put a not. Basically, we want to find out the companies which are present in rounds but not in my companies. So that's what we want to do here. So when we do this, we saw this sort of output. Now this is strange, right? Because if you look at it, this is not English readable part. This is not English readable. But I tell you one thing to do right away. Pause this video, go to your Excel sheet and look at these indexes. Okay, the data set what you have got, go to these indexes. When you will go to those indexes, you will notice that that will be in English letters, proper English letter. It is not basically like this in the actual data set. That means we have some problem. We have some problem here from Python point of view. Python is not able to read this the thing properly, and because of which this problem is occurring in this case. Now let's see that what we can do to basically fix it then. So in order to do that, so what we will do is, so we have also gone to those indexes from Python and have seen that Python is reading like this. But as I said, if you want to go and really check in Excel, you can pause this video right away and go and check. You will notice that in the rounds data set, it is actually going to be a proper English character. So it's a problem of Python, which is basically giving us weird results. Now, what can be a solution for it? So one solution is that we can import with the characters data that carded, and this will tell you that what should be the proper encoding you have to use. Maybe we have used the wrong encoding of ISO, due to which it is happening. So maybe I would like to see basically the right encoding for it. And what we will do for that, we have to install this carded. The reason I have uncommented it out is because it do take a lot of time to run. But let me tell you what this carded do is, it tells you that for this data, what is the right encoding technique you should apply. And you will notice that when you will run it with the result, it will tell you that the right encoding is CP1254. So what we did, we started removing that ISO and started with CP1254, and we noticed that we got an error. Okay, you can try that. I have basically commented it out, but you can actually try this out, and you will notice that we ended up with error. Now, due to this, what we can realize is this is not going to work. So what we have to do in that case, then we started exploring it a little more, and we went to a Stack Overflow discussion, for which I have also given the link. There was a very nice solution to solve this particular kind of issue. And the solution for this is that you can first encode it with UTF-8 and then also decode it with ASCII. Okay, so if you will do this and look at the data now, you will notice that now everything is coming up as a real English character. Now there's no problem of that special characters and all. Now let's look at the unique column. So it looks like now we have 66,368, which is good. Now let's look at, maybe the same problem can happen in companies data frame also. So we can compare now with companies. So we have reversed everything up, and we notice that yes, we do have problem in companies as well. So we applied the same solution for companies data frame with UTF encode and decode ASCII, and then after that, when you will try, everything is gone. So now we got a good idea that everything is working good. And what we have done, this clean data, we have just now write it back to a new data set, which is roundclean.csv and companiesclean.csv. Reason we have done that, because we want to create separate notebooks for some part, because sometimes I have seen that some students complaining that if the notebook becomes huge and if they have less RAM into their system, their notebooks do not load up properly. So for that, we just attempted to split out our notebook into multiple parts. If you want, you could just continue with the same part. So this is the first part of the thing. Like what we have done is we basically have cleaned up the data and worked on it. Now, given this solution, maybe you can go back and fill up your Excel sheet accordingly. Now you can very easily kind of do all that. So in the last part, we have got our data with the right encoding technique, and we were able to create a new data frame with all the clean one. Now, you might be wondering why we need the data cleaning too, because we have not yet dealt with the missing values, right? So there are a lot of missing values in the data, and now we will see that how to deal with them. Now, the first thing is we gonna load up again the same files which we have created last time. So which was roundclean.csv and companiesclean.csv. Now let's quickly verify whether in those cleaned data we are getting the records as expected. So if you remember, we were expecting 66,368 records. So we can look at the unique values, and if you look at this, there should be 0, right? Means that there should be no output where I have a permalink present here but not present here, something like that. So now let's go and do the missing value treatment and see that how much missing values we do have. In order to deal with it, we gonna look at the missing value and do the sum of all that, and these are the missing values. Now it's little difficult to interpret here, so we would like to see it in the percentage format rather than this format. So before that, let's also quickly look at the rounds data frame missing values, and yes, we do have some missing values here as well. So what we will do is we will look at the percentage format and on the merged data of both. But if you look at it, what is the common columns which is possible for them? We have a permalink column, right? So permalink column. So these two columns are same here. So what we would like to do is we would like to see that how we can perform basically this merge. So this companies and rounds we're gonna merge, we're gonna do an inner join, and we will do it on this particular column. Let's look at the data. So this is how the data merged data is gonna appear like. Let's go ahead and look at the column of the master data frame. This is the column, but notice one thing. We still have a permalink here, and we also have even company permalink here. We don't need both, right? We have already merged them. So why we need both? So let's remove this unnecessary extra column. So what we will do, we will drop the company permalink here. Now let's look at the column. All look good. Now let's go back to the missing value data. Now, as I said, it will be a good idea if we look at the missing data from the point of view of percentage rather than looking at the raw data. And in order to do this, what we can do, we can look at the missing value sum divided by total number of indexes present in it. So this will give us the percentage. Now, so in this percentage, we can see that this is definitely one of the waste column here, because 70, almost 72.91%, which is 73% of the data is kind of not available. So we would like to remove it. And similarly, if you look at some more columns, right? Let's say if I talk about homepage URL, business point of view, it may not make sense. Similarly, if I look at some other column, let's say funded ad, right? Basically founded ad, sorry, founded ad. This is basically a waste column. Funded ad may be useful, so let's keep it. Similarly, we have state code, region, city. So these columns may not be, from the business perspective, they may not be useful. So I would like to remove them up. So let's drop all these unnecessary columns. And now let's look at again the missing value data. Now raised amount USD have 17.39% of missing data. Now what you can do with this? Think on it. Now, one way is you may say that, oh, this is too huge number of missing data, let's move it. No, but this is the main column on which you want to do all your analysis. So you cannot simply remove this particular column. So what we should do? The next thing which comes in our mind, that should we think of doing some imputation here? So before we do any sort of imputation, let's quickly explore this data. And while exploring this data, I'm going to use this describe. And in this describe, what we're going to do, we going to say that, okay, we have a count of this. This is sounding good. But if you look at this, my mean and median have a huge difference. Look at this mean. This is 10 to the power 7. And look at the median, which is 10 to the power 6. It's the mean is somewhere around like 10 million and median is around like 1 million, right? So there's a huge difference. Even if you look at the minimum and maximum value, there's a huge difference between them, right? They are continuously very far apart. So definitely imputing the mean will not be good, because there's a huge variation of data in this particular case. Now one way is either you can just remove some outliers by using some methods which we have learned in the sections. That can be one way, or other way is you can probably remove these 17% data which is missing. And I would prefer to choose to remove that, but I leave this as a homework exercise for you guys to maybe look at the outlier component and see that how you can remove these particular outliers from here and then do imputation on it. So maybe you can do a median imputation or a mean imputation, up to you. So now here what we are going to do is we gonna remove that. So what I've done, I've just basically said that take only the master data frame where I don't have the missing value, right? So this is basically the code which is gonna help me remove all the missing data from it. Now let's again quickly look at how much missing data we are left with. So we can see the next one is country code, which still have quite a good missing data. Let's go and explore this also. So let's quickly see the value count, because it's a categorical data. So maybe we can see that how the countries are distributed, and we can see here that USA is occurring 62,049 times, GBR is occurring 5,019 times, and so on. So we can notice that this data is also not uniformly distributed. You can see that most of the country code is like USA and maybe the initial few countries, but coming down it's very low in number. So maybe imputation here will also be tough. How you would say that, what imputation should you do? Can you say that really I should put USA everywhere? Mode? Um, Maybe a good strategy, but might not be good, right? Because the real data set, and we would not like to randomly put any data just like that, because the distribution is not that great. But yes, one strategy could be that you could have gone with mode. Means some data scientists could have approached with the mode factor, which is USA, and applied here. But my strategy would be that since it's just 6%, let's remove them. So I will just remove them out because the percentage also, if we look at 65% is USA and remaining is very low. This is just to look at the percentage part. Now let's remove them. As I said, let's remove all the country code which are missing. Let's look at the percentage again, and this time you can see that we have only category West, which is 0.65. Let's remove them simply. This is very, very less. So let's remove them out, and we remove the category list wherever also we have missing value. And now we have left with this. Now you can see this, and we can write it up again to a CSV file. And if we see this information, you can see that there's no missing value. One more thing which we can also do is that we can see that how much data we are retaining after removing all those missing value. Because if you have noticed that every time we were just removing our missing values, right? Now we would like to see that how much missing data after removal of missing data, the data we have retained. So we are left with almost 77% of the data, which is good, right? We have lost 23%, and given that this data set was pretty huge comparatively, so it's okay if we have kind of removed this much. So this is what we will be left with, and we will now use this data frame, which is clean data, for our further analysis. So now in this part, we are going to perform some analysis. Now, if you recall from our problem statement, we have to perform funding analysis, we have to perform country analysis, and we have to perform sector analysis, right? These are the places where TechLove would like to invest. So in this case, remember the constraint which we had, like investment should happen only between 5 to $15 million, and second constraint was the English speaking countries. So let's talk about funding type analysis first. Now, if you recall, in the last case, we have created the master data frame, which was the merge data frame for it. Let's load it, see the data. And now in the funding analysis, we want to identify whether we should go for venture investment or seed investment or angel investment or private equity. So what we will do is we will filter out the data based on the round funding type. So that's what we have done in this particular code. Now there will be a very important decision which we have to make here. Should we make the call based on the mean value, or should we make the call based on the median value? So for that, we need to understand whether we have outliers or not here. So let's do that. So in this case, let's look at the raised amount USD. And on the Y axis, if you notice, I have taken the log of it. So that otherwise, if you remove the log and create this, you will notice that you will not be able to make out anything of it, because it's completely on a very bad scale. And that's the reason you will not be able to make any information out of it. Now let's look at the summary stats. It will give you even better insight, but here definitely we can see from here that there are some outliers going up, right? You can see that there are a lot of dots above this quartile. Now let's look at this describe, and this is kind of confirming our thing as well, right? You can notice here that my median value is here, which is 10 to the power 6, and mean value is also 10 to the power 6. So it sounds good, right? But at the same time, look at the number. Here we have 2 million of median, and there we have 9 million of median. Now definitely this is not good, right? If you look at it, 9 million versus 2 million have a good difference in terms of mean and median. So in this case, maybe we would like to go with respect to a median rather than going with the mean part. Now let's go ahead and see few more components with respect to this. What we're gonna do is, now let's draw a box plot, and this box plot is again for all the funding type. So on the y-axis with the log scale, we have put raised amount USD, which is basically this part, and on x-axis we have put venture, seed, private equity, and angel. So this is giving us an insight that how this data is distributed. So you can notice that maybe seed investment is happening lower, then the angel is investment and all, and then venture, and then private equity. And if you know the startup how it works, it basically makes sense also. This is how the investment is happening. But for us, the main thing is to look at these outliers, right? So we do have a lot of outside going values, which tells us that we should definitely go for median. Now one more thing what we can do is we can do a comparison of mean and median value into while creating a simple pivot table. Now you can see here that what we are trying to do is on the basically here, like for we have created this for median part. So you can see that for angel, this is the median value for this value. For venture, we have like 5 into 10 to the power I think 6. Similarly, but here you can see this is 10 to the power 6, but this right hand side, right? So this is the right hand side. This right hand side is your mean value, and anything here is the median value. But if you compare here, this is 10 to the power 7, right? So there's a huge difference popping up here. Even you can compare for others also, right? You can see that there's a huge difference in median and mean. So this tells us that probably we should look forward for looking at the median instead of looking at the mean value. So now let's do basically median for all this investment type, which is going to be your private equity, venture, or angel investment, or seed investment. So what we have done is we have done it in the sorted way. Now, by looking at it, it looks like private equity have the maximum investment happening, so we can go with this. But we have to remember our rule. We cannot go beyond 5 million to 15 million part, right? So we cannot go this. This is above our pocket. Now, in the second part, venture is falling in our pocket. This is venture is definitely falling in our pocket. But if we look at this two, definitely they are below our pocket. Means I don't want to look at anything below $5 million. So maybe I will go for venture. So that is the way we can choose it. Now you can make out it's so important to choose whether you should go for median and mean here, right? So because mean could give you completely different result. So one way I could ask you to do as a homework activity is that you can probably look at if you can remove first outliers and then use the mean as this and see that whether you're getting the same result or not. So this can be another strategy which I want you to attempt and see whether it works. So this is the first part where we looked at the investment type. So we got that funding type. We need to look at the venture. Oh, sorry. We need to look at the venture. Say, and we will not take anything else, right? So this is the first answer we got. Now let's look at the country analysis where we need to look at the top 3 English-speaking countries. Now in the second part, we basically what we are actually trying to find out is we want to find out those countries where the maximum investment is happening, but at the same time they should be English speaking country so that we should not face any sort of communication issue. So that was the second restriction kind of thing which we have put across with it. Now what we are going to do, since we have decided that we will go only with venture, so let's take out the data only for venture, because maybe I would only try to analyze with respect to venture now that which country is having the maximum investment. That will make more sense for us. Now, so we have done it. Then after that, what we can do is we can quickly see with respect to like USA and all, and we have done all this in the sorted order, like what is the value coming up for this, right? So we have just basically summed up all the funding which have happened for each country, and in the sorted order we have returned you the result. Now this is interesting. We got almost our point. Now we can extract the top 9 countries. So these are our top 9 countries, which because it was in sorted order, we can just take the top 9 rows from it, and we can see that we got USA, China, GBR, India, Canada, France, and so on. Right. So these are the countries we got. Now, but we are interested in only top 3 English-speaking country. We are not at all interested in any other type of countries. And if you will look at the link which I have given you, basically definitely USA is one of the English speaking country, but China is not. So China we have to rule out. So China do not have English speaking part. So then GBR and India is also English speaking country, so we can basically take them up. So in this case we will go with these English speaking countries, and basically if you look at the output, this is basically the output for it. So we basically have pulled out only the data for English speaking country. Let's look at the data frame information. Now we are left with 38,800 rows. This looks good. You can plot it even for all these 3 countries to see that how the investment is happening, and we can see that this is the way investment is flowing in these top 3 English speaking countries. Now, after this, we need to work on sector analysis. We will learn to that in the next video. But as I told you that this is not the only way we have done this analysis. And at the same time, if you recall from the problem statement, you need to keep filling your those sheets also which I have given you. So that was just a way for you to basically verify my answers. But these are not hard and fast things. But Definitely, when you will be working across for a real-time projects, you might come across these kind of requirements a lot. Like, fill this kind of sheets and give us the answer in appropriate format. And if you recall, even I have added one more requirement for you to prepare a presentation and post it to your discussion forum to showcase to the other students that what you are recommending to TechLove for this. Maybe you can upload it on Google Drive and give the link for everyone to just look at it. So this will be a good thing from your end to try. This will really help out. But what we will do is the next part is sector analysis. This is the final analysis which we're going to work on in this statement. So let's look at the second case study which we are going to work. It's going to be kind of a loan analysis. Uh, in this case study, we gonna majorly focus on exploratory data analysis. Whatever section you have learned from there, we're gonna probably use that. So this is gonna gives you an idea that how real business problems are usually solved by just looking at the EDA. Means here also we are not going to use any sort of machine learning. It will be completely an EDA based project. Now, apart from applying the technique what we have learned in EDA, here you need to also develop a basic understanding of risk analysis in banking and financial services. And also we need to understand how the data is used to minimize the risk of losing money while lending to the customer. So we would like to develop some sort of pattern or some sort of strategy which will help us in future to determine whether we should give a loan to somebody in future from the bank side or not. And this is a very famous problem which we always solve. So what is the business standing here? So let's say you work for a customer financial company which is specializing in lending various sort of loans to urban customer. And if I'm not wrong, this data is from 2011 to 2017. And when any company receives any loan application, the customer has to make a decision for loan approval based on the applicant profile. Now there are two type of risks which are associated with the bank decision. One is if the applicant is likely to repay the loan, then not approving the loan result in a loss of business, right? So that's one thing. And if the applicant is not likely to repay the loan, that is he or she is likely to default, then approving the loan may lead to financial loss for that company. Now the data which is given contains the information about the past loan applicants and whether they have defaulted or not. So I will show you the data in the Python notebook sooner, so you can basically look at that. The aim is to identify the pattern which indicates if the person is likely to default, which may be used for taking actions such as maybe in future we may want to deny some loans, or maybe we can say that we will not give you the loan of this amount but lesser amount, or basically lending to risky applicants, right? So maybe if we notice that there is a very risky applicant, then we may say that you have to pay more than what we ask for the normal candidate. So that kind of thing we can make decisions based on that. Now in this case study, you will use your EDA to understand how customer attributes and the loan attributes influence the tendency to default on a loan. So when a person applies for a loan, there are two types of decision that could be taken by the company. One is loan accepted. If a company approves the loan, now here also there can be three possible scenarios. One is the applicant have completely paid the amount. Second is he is currently paying it. He have not yet fully paid it, but he is paying the installment. And third is charged off. This guy have kind of defaulted, means he is not paying anymore, and this is the risky customer. Now the second condition which could have happened was loan rejected. So here, if the company have rejected the loan, the maybe due to the customer is not meeting the requirement, and since the loan was rejected, there is no transactional history of these applicants, right? Because if we have already rejected, then what will be the transaction this customer is going to make? Now, what is the business objective? Business objective is that the company is the largest online loan marketplace, and basically they provide personal loan, business loan, financial and medical procedures loans, and borrowers can easily assess the lower interest rate loan through the fast online interface. Now, like any other leading company, leading loans to risky applicants is the largest source of financial loss, because if you have given the loan to the wrong person, you may go into a huge loss. The credit loss is the amount of company lost by the lender when the borrower is going to refuse to pay or run away with the money on. Okay, let's say run away with the money on. In other words, the borrower who default caused a large amount of loss to the lenders. In this case, the consumers label as charged off. So wherever you notice charged off, that means that customer have not paid the loan, he ran away. If one is likely to identify this risky loan applicants, then such loans can be reduced, thereby cutting the amount of loss which is possible, and identifying such applicants using ADA is what you want. So here also, as I said, we are not going to use any machine learning concept. It will be completely through ADA. So in other words, the company wants to understand the driving factors behind any loan defaults. That is, can we determine the variables which are strong indicator of default? The company can utilize this knowledge in future for the future loan giving thing. Now, to develop your understanding in this domain, you definitely are advised to look at or do your own research before you start solving this problem. So again, the same point I'm going to mention, which I have said even in the previous EDA project, is you have to try to solve this problem on your own first. Don't directly jump on looking at my solution, because then you're really not learning anything. So if you really want to basically whatever you have learned, make the best use out of it, you need to really spend time and fix this code on your own. Just try to write. Think of how you can come up with some univariate analysis, bivariate analysis, segmented variable analysis. Before that, how to clean the data. Can we come up with some derived column? All these techniques, what we have learned, you have to apply here. This is going to be very interesting in a real case study. So you have to work on it, come up with some solution. If not, then after that, look at the solution and see that where the things were missing at your end. Or maybe you could have come up even with a better solution than my own solution here. If yes, then paste it on the discussion forum. Let other students also know so that they can take advantage for your code. So I will tell you my code, my way of writing code in the next lecture. But before that, again, stop here, write the code on your own, spend at least a day or two on this. It will take time. It is not going to be just a day task. Maybe it will take a day or two. It will not finish so fast because the data is huge. And then see if you can come up with some interesting trend. On top of that, a bonus brownie point, if you can prepare a presentation in the last and post it in the discussion forum, nothing can be better than that. Please try that. So I will be waiting for your solution, and in the next lecture I will propose the solution for it. Okay, so I'm really assuming here that you have already tried all these things on your own, and I'm assuming that you have looked at the data and would have realized by now that it's really a huge data to kind of analyze on and to come up with some loan analysis. And if you have noticed that I have also given you a data dictionary, which is very important to look at for your analysis. Without that data dictionary, you would not be able to make out lot many columns. So you have to definitely go to that section and kind of read about the data dictionary in detail. So there will be four major parts which we are going to follow in this case study. Number one, we're gonna understand the data. Second thing would be data cleaning. So we will look at the missing columns, missing values, and so on. And then we will do some analysis where we perform the univariate, bivariate, segmented analysis, do some derived column also if required. And then in the last, we will do our recommendations in this case. So that's what would be our strategy while we are solving this. So first we need to load this data, which is through read.csv, loan.csv. We are reading it up. Once we read it up, this is the data. So you can see that there are some 111 columns which we have in this case, and there will be a lot of rows. So I have just printed out 5, but there are a lot of rows. Now let's look at these column names. So these are the column names, and if you look at the data set closely, major columns which you can even make out by reading the column names would be loan amount, which is going to be very important, term, interest rate, grade, subgrade, annual income, purpose for the loan, right? So these may be few important factors basically in this data. And what is going to be a target variable? Target variable is going to be a loan status, whether the person have charged off or he have paid or whatever. So this is going to be a target variable in this case. So let's start with the data cleaning step, because this is the most important component we start with. So what we are going to do here is that we will look at all the missing values. So again, following the same strategy what we are doing it from last. So we will look at is null sum, and you can notice that the basically this is the data. This do not look so better. So what we will do, we will look at the percentage, like how we were doing it in the last time also. So if you look at the percentage, you will notice that few of the columns have 100% missing value. So which means that we definitely would like to remove. In fact, you will find some columns with 90% also. So maybe we can devise a strategy that anything where we have more than 90% missing values, with this column is not going to be any useful for us. Let's remove them out. So what we're going to do is we have placed a code which is going to look at the percentage. If it is going greater than 90, then remove them out. So these are the columns which we are going to remove in that case. You can see that we are getting rid of lot many columns like this. So then we can do a drop, and when we are dropping it up, we can see the shape. This is the 55 column we are left with. Let's see the missing value once again, just to see that if we have any more missing value. And yes, we do have. In fact, you can see that we have one at 32% and one at 64%. Remaining looks okay. So maybe let's, before we decide to do anything with them, let's take a quick look on the data, that what this data is all about. And this is where maybe we would like to see the data dictionary as well. So now we will look at this two columns, describe and month since last dealing. Now if you look at this two columns, basically the first column is description. This is basically kind of a description being added, right? So while applying for loan, there is some sort of description being added, some details being added. Now, definitely you may say that I can use this for text, using some text sentimental analysis, like using text mining and NLP. We can use and try to use it for a lot of many other purposes. This is definitely possible to do, but we will not do this analysis in this case study at least. So I'm going to remove this out. Second column, month since last dealing. If you have gone through the data dictionary, you might have seen that this column basically is created after the loan is approved or disapproved. So definitely this column is of no use for me here, because this column when during the loan time is not going to come, right? I want something that during the loan time I should make a decision. So let's drop these two columns. Let's look at again my null values, and this is the data what we got. Now still we do have a lot of missing value, but if we want we can ignore them for now, because we are not going to build any machine learning model here. It's just ED analysis. So if required in future to remove something, we will keep on doing it, but for now let's ignore it. Whenever requirement will come, we will take a look. So let's look at the missing data in rows also now, because we would like to see that if there is any row where we have more than, let's say, 5 missing value. So in that case, we would like to remove that particular row. So this is the row count which we are getting. And what we can do is we can just search for if there is any row where there are more than 5 missing value, and we got 0. So looks like we are all good with respect to this. So let's look at the information of the data using the info command. This is done just to see that is there any column which is supposed to be numeric, but we have kept it like object. So object is like string, right? So we are keeping it like that. So is there any column like that? So I have already done this analysis. So this is basically, you will find something like int rate. You can go and check out here. So int rate will be there as object. So you can see it here. Int rate is there as object. So this integer rate basically will be can be an important factor. So we would like to convert it to integer, because that will make more sense, right? So we are converting it using a lambda function and converting it to an integer numeric value. Now look at this data set once again, and this time we would like to do something for employee length. If you have already seen the data in employee length, you will notice that it have categorical data as well. So we would like to take out only the numeric value out of it, but there's a problem in this employee length also have some missing value. So if I have to apply some regular expression which is taking out the digit from the data, right? So employee length have some string value. So if I want to take only the digit out of it, so in order to apply this regular expression, I have to make sure that I need to remove all the values where the missing data is there. So I would like to first remove the employee length column missing values, and then I'm gonna pull up the digit value from it. So I'm really assuming here that you have done all this thing. If you have already tried this case study on your own, then you would have observed it. If not, pause the video and look at that. I'm definitely not doing each and every step here. I'm just kind of explaining you quickly here what are the steps you should have performed. This is just to give you an idea, so that but to just compare your solutions with mine, and if you have missed out anything you can match out with this. But main the intention was that you should have tried this on your own before. Okay, so now this is the one part. Now after that, once we have done it, taken out only the digit, then after that we can make sure that it's in the numeric format. Now after that, let's look at the columns once again. Now when we are doing it, now everything looks good, and after that we are all good to start our analysis. So this is where we will start our univariate, bivariate and further analysis. So we will do that from our next lecture. So now after we have got the clean data, what we're gonna do is we're gonna work on the data analysis. So here we're gonna look at a lot of univariate analysis, bivariate analysis, segmented analysis, and so on. So the first step is that we gonna understand that what all we are going to do in this case, right? What is our clear objective? Now, keeping that in mind, there are three kind of basically variables with us. One is the first one is those which are related to the applicants, like for example, age, occupation, employment detail. Second one could be a loan characteristic kind of data. For example, amount of loan taken by him, interest rate, purpose of loan, etc. Similarly, there can be a customer behavior variable, which could be like they are the one which are generated after the loan is approved. So these are the third kind of variable which we probably don't need, right? So now you need to again go back, look at the data dictionary, and would probably try to get rid of those variable names, because those are the variable names which are not going to help you at all. Now let's, when we searched it up, so we got these particular all the variables like D-Link 2 years, earliest CR line, Inc last 6 month, open account, public rec, similarly Revol Bal, Revol Util, total account, out per income. So all these things will be a part of your behavior, which is after the loan is approved. So definitely these we don't need it, right? Because my final analysis, what we want is that at the time of giving the loan, which are the variables which I would like to look at. So these were the things we would like to probably go with this. So basically here, so these are the variables, and again you can go back with dictionary and match up these things and see what each variable means. Now so let's drop all these behavior variables because these are we don't need, and now we have reduced our columns a lot. Now there are few more which could be probably not that useful. For example, if you look at the zip code, how that can be useful? No, right? Similarly, you could have a URL or title, right? Or you could have even, let's say, a variable is title, which is, if you look at the purpose column, the title column can be actually derived from it. So maybe you don't need it. Okay, you don't need it again. So you would like to again remove this title, URL, zip code, and address state, because these will again not be useful. Again, this is a business call. Okay, if you want, you can still keep the map and try to do analysis. You may not come up with some very interesting trend. Now, after this, what we would like to do is we have some columns which we may want to completely convert it to 0, 1. And one thing we would do is like loan status first convert to category, and then see that how many are fully paid, how many are charged off, how many are current, right? So these are basically three values what we have. Now, definitely the current one we cannot do much because we don't know whether they're gonna be charging off, whether they're gonna be fully paying. Right now we can't do anything about them. So let's skip them out. So we're gonna remove all the one which not current, and the remaining part what we are left with, like we are left with the charged off and fully paid. So what we will do with them, we will convert them to 0, 1. So if they are fully paid, I will mark them 0. If not, basically if they have charged off, I will mark it as 1. So 1 means they are kind of my risky customer. Now, once I've done it, let's convert these to numeric values. Once I have converted to numeric value, let's see that how my distribution looks like. So there are 32,145 people who have fully paid the loan, which is good. But there are 5,399 people who are in the charged off category. Now, let's perform some univariate analysis on top of it to determine that what can be basically a possibility in this case. So during the univariate analysis, what we could figure out is the default rate, the people who are defaulting are like 14% in this data, and the remaining 86 is like the one which they are fully paid. Now let's do some analysis. So let's say if I want to look at the grade column. Now if you recall from the grade column is coming from the lender part, right? Lender company, like the CIBIL score kind of thing. So if you are basically grade A customer, means you have in the past paid like a lot of loans nicely. If you are in grade higher like G, F, all those, so they are basically the one who are bad customers. So let's see that how this is gonna come up in a bar plot. So bar plot will draw on the y-axis count and x-axis will be the grade. So what we have done is like grade and the loan status. So these two we are going to plot with the data frame. So you can see that it is also telling me an interesting thing, like this is what is expected. So you can notice that basically people who are in grade A, they are defaulting the minimum, and as and when this grade is going up, the default is also increasing, right? So you can see that the default is continuously increasing as my grade is going up, and that is expected, right? Because as I said, grade is one column which is determined from your previous records. So this is something which is expected also. So now we're gonna do this kind of analysis on multiple columns. And in order to do that, let's create a function for it so that I need not write this code again and again. So what we are doing is we have created a plot underscore cat function where I'm going to pass a categorical variable. For example, I can plot here grade. And what we are doing is we will just plot bar plot again here. We will pass the cat variable, whatever we're going to pass. And y-axis will always be loan status and the data will be always df. So this is gonna just plot up this thing. So I'm gonna just call it. So for example, plot underscore cat grade if we pass, this is gonna plot exactly the same graph which we have just seen. Now, as I told you already that this is expected. Now let's do it for the term. So maybe we have two kind of terms with us. One is 36 month term and one is like 60-month term. So we would like to see if the people who are applying for 36 months, they are defaulting more, or people who are applying for longer term like 60 months, they are defaulting more. So that's basically what we want to infer now. So what we are doing is we are passing term and we are seeing an interesting thing that people who are applying for longer term loan, they have the high risk of defaulting. Okay, this is risky customer. Now let's look at A1 is A1, A2, like there are subcategories also, right? In A also there's a subcategory A1, A2, A3. And definitely A1 is better than A2, then A3 is better than A3. So we would like to see whether the same trend is following up here. And yes, you can notice if you go with this, A1 is very, very small. And you can see that after that, it's when you are going from A1 to A2 is also going higher. So this is something which is coming as our expected lines. Now let's look at the home ownership, right? Now home ownership is like whether he's renting own house or whether he have a mortgage or others. Now here it's not a very well way of coming with some output because they're very close. So maybe we would say that this is not impacting much. Home ownership is variable is not letting me know much of the information. Now let's look at the verification status. So you might have noticed that when you apply for loan, they do some verification for you. Now we are noticing very interesting trend. What we are noticing is that people who are verified by our verification agency, those are the people who are defaulting more, and people who are not being verified as per our records, they are in fact not defaulting much. Okay, so sometimes it do happens in bank that this is being referred by somebody, or maybe we know about it that he's a very genuine customer, and in that case maybe they sometimes keep you as an exception and do not put any sort of inquiry for you. So maybe those are the people who are not verified. They were just given loan thinking that these are the people we know or this being referred by some known people. So maybe I don't want to go for verification for them. But what we're noticing is that for people for whom we have done our good verification, they are the one who are basically doing more default. So maybe we would like to make some rules more stricter from the verification agency, right? So this is something which is interesting trend. Now let's look at few more things. Let's say purpose of loan. Is the purpose of loan also impacting? Yes. You can see in this graph, there are small businesses which are applying for loan. They have a very high chance of defaulting. And if you look at the other ones, for example, if you look at the renewable energy and education part in this particular graph, they are not defaulting much, right? Their defaulting rate is very, very low in this case. Now, this is interesting, right? If you look at it, this is giving us interesting thing. Maybe if a person who is going to apply for loan in future for the small business and so on, we may accordingly take the decision that looks like this is a risky customer. Now let's look at the second thing. We also have a date column which is issue date, and what we would like to see is we would like to see the distribution for it. So maybe it may be a good idea to separate out the month and the year so that we can have a separate analysis for both of them. It would be better. So what we can do, the date is looking like this, and what we will do first, we will convert it to date time or using date time into an appropriate format. And after that, we can just take out the month from it and year from it and keep it separately. Now these are like derived columns, right? Now what we're gonna do is we will do a basically count with respect to group by of year, and we would try to see that for each year how the distribution is gonna look like. So you can notice that as my year is increasing, in 2011 we had the maximum loan given. In 2007 it is lesser, right? So definitely the customers are increasing here. And a similar thing we will do to with month also. Okay, so you can notice that most of the loans are being granted in December. So maybe December is the time frame where people are applying for more loans, and they are being granted also at that time frame. Now let's see that whether we can make any interesting trend out of it. So when we are plotting this, what we notice is that the graph was decreasing. In 2007, the default was very high. They started decreasing, but suddenly in 2011, it increased again. Now, this may be a worrisome part for that company, because they would like to see that whether we are doing something wrong here, right? So maybe they can do further analysis on top of it. Now, after that, what we can also see is that month-wise analysis, but month-wise is not giving us anything more concrete, because more or less everyone is looking same. Now let's look at the loan amount. Now, loan amount, if you remember, is a continuous variable. Till now, whatever we were dealing with was continuous variables, means basically was a categorical variable. Now, categorical variable was very easy, that how we have done it. But what about continuous variable? Because if we plot a graph on, let's say, on loan amount, this is not telling me something very interesting, right? This is not really giving me much insight from it. Just like how we were getting it from categorical columns, we were telling that, okay, if this is the case, the loan is risk is more higher or not. So I'm not able to give any inference out of it. So how about if we again do some sort of derived column, and what we would do is we would basically make some categorical columns out of it. For example, in the loan amount, how about if we say that anything less than 5,000 loan amount, maybe we would say that these are like low value customers with low loan amount. And similarly, anything between 5,000 to 15,000, let's mark it as medium. Similarly, anything between 15,000 to 25,000, let's mark it as high. Else, if it is more higher, let's mark it as very high. Now, what we will do is that loan amount, let's basically we got it from here. And what we will do is once we pass inside this function, we can just do some value counts, and then we can also do a plotting, just like how we were doing in categorical variables. Now here we notice that most of the customer are medium sized customers. So medium sized customers are people who are basically applying for like between 5,000 to 15,000 is the loan amount for them. So now if we plot a graph and see that what is the risk coming up for it, because again, if we look at it, the y-axis is again going to be the same. So now again, the loan status is my y-axis. So when we do this, we can very well see that the people who are applying for more loan, basically for whom the loan amount is higher, they have in fact more high chance of basically defaulting the loan. Okay, so people who are applying for lesser loan, in fact medium and low are almost same, so they are not very much risky customers. But definitely the people who are applying for higher loans, they are very much a risky customers for us. Now let's do the same thing for funded amount investment also. When we do the for the funded amount, we got the same sort of distribution. Now you can see here also, when they are high in number, the loan risk also have increased a lot. Similarly, what we can do is we can derive a function for interest rate as well. So for that, what we have done is any interest rate less than 10, we will mark it as low. So between 10 to 15, let's mark it as medium. And above this value, let's mark it as high interest rate. So when we draw that, what we notice, there's people who are being given the loan on a higher interest rate, they basically are defaulting more. And people who are given the loan with a lower interest rate, they are not defaulting more. So this is interesting, right? How we are using a continuous variable and now coming up with the interesting insight out of it. And we are using the business logic to derive all that. Similarly, we can do it for income ratio. So for income ratio also, what we have done is anything less than 10 is low, between 10 to 20 medium, otherwise high. And what we can notice here is that people again for higher we are defaulting more, but they're almost close, so we cannot do much analysis here. Let's do the same thing for funded amount. And in funded amount, you can put it like value less than 5,000, low, between 5,000 to 15,000, medium, else high. Let's do the analysis. and again we are going to get almost the same thing. So let's do the further analysis in the next lecture. Okay, so now we have to perform a segmented univariate analysis. One thing which I missed out in the last video was that to look at this employee length, but it was not giving much of the information. So what I have done for employee length was that converting it to freshers, juniors, senior and expert based on the year of experience, and then we plotted this and we could not make much information. Let's do the segmented analysis. This we have already done, it's just the repetition which was happened by mistake. So here if you remember, the small businesses was creating basically more of the risk factor. Now after that, what we would like to do is we would like to look at the purpose of the loan. Purpose of the loan basically is given in the data set. So there can be various purpose. Maybe I would like to take a loan to pay my credit card bill. Maybe I would like to pay the loan for paying some other debt, right? Maybe this kind of risk there, maybe for home loan, different kind of purpose. So when I plot this, we notice that we, for the debt consideration, which is basically means to paying the other debt, I have taken some this debt, they have the high chance of risking it. So they are the one who are not paying it often, and they are the risky customers for us in this case. So now in this case, we figured out there are four which are basically higher. One is your basically debt consideration. Second is your credit card. This is also higher. This is not coming very clear, but it is actually major purchase which is basically impacting it up. And basically there is something home improvement which is also not very clean, but it is going to show up here, home improvement. So I will take out these four columns which are impacting the maximum, and what I would do is I would look at those values, and basically from the data I will only pull up those values, and we'll see that how they are distributed. So we can see that for depth consideration we have the highest value. Now after that we will draw a plot for purpose. So we can see here only with four values this is going to be higher depth consideration, and the remaining are also higher but not as high as depth consideration. But now using this column we are going to perform a segmented variate analysis. Let me show you how. So what we will do in this case, we will basically plot a graph with respect to term like 36 month and 60 month. But now we have divided it into like based on credit card, based on debt consideration and so on. So this is interesting, right? Because now if you notice, we are getting some more insight. Like in 36 month and 68th month, both the cases debt consideration is the main one where I'm getting into the more credit loss, right? But if you look at the green color, which is home improvement, for 36 month it is high comparatively, but for 60th month it is lower. But in fact for 60th month this is the second number, credit card, right? So maybe this is giving us even a better inference what we had last time. Now in order to do this, let's better draw a function, because we don't want to again and again repeat it. So in this function plot segmented, I'm going to take the categorical variable, and the remaining y loan status and hue purpose is going to remain the same. So we just exactly plotted the same graph for term just to see that it's working or not. Now let's do it for grade. So this is the grade 1, and here also you can see that the debt consideration is the highest for almost every grade. Now look at the home ownership. Here also almost the same result, but in others case, basically here we can notice that for home improvement we are getting more of the risk part. Now let's draw it for year. We are getting something similar. We are drawing it employee length. Now I leave it to you to infer on it, right? Because we have done so much of inferences earlier. By looking at this graph, you can very easily infer. Similarly, I'm gonna do it for loan amount. I'm gonna do it for interest rate. I'm gonna do it for installment. I have to do it on DTI, debt to income ratio. I have to do it for annual income, and basically this is what the way we can do it. But till how much you will keep on doing it, right? It's very difficult to do that. How about if we can get some numeric value of doing it? So what we can do is, let's say if I want to look at the annual income and see that what is the loan status mean value for low, median, very high, high. So this is the value. Now maybe what we can do is we can subtract low and high, and we'll get that how much it is increasing or decreasing in that case. So for that we have written a function. So what this function is going to do is exactly this part, okay? And then basically it is looking at the basically the minimum and maximum and going to kind of subtract it. So what is happening here, let's say if I applied it for basically on default rate, let's say. So now you will notice that the result is going to be that low is this, medium is this, very high is this, and high is this. But the difference between low and high is zero point 0.6, which means that there is a 6% increase in the default risk at you go from high to low annual income. Right? So basically when the annual income is kind of going from high to low, there's a 6% chance. Now we can do it for all the variables like that, but can we keep on writing the code like that? It will not be a good idea. How about if we basically use this function in a loop like for loop, and now this is giving you a very interesting result, right? So now basically with respect to this, you can apply it with the for loop with a dictionary format, you can keep it. And then you can see that it's telling that for loan amount we have 7% increase, for funded amount 6% increase, and that's where we can see that for term we have a maximum impact. So using this we will get a good insight that which are all the columns where we're gonna have a maximum impact on the loan part. So this is how we gonna compute all these things. Okay, so we will compute and finish up all these things like that. So this consists of this project. I have basically not finished this project completely, but definitely now you can just write your inferences after that. So this I want to give you as homework. So I have completed the whole project from the code point of view, but now you have to just write your inferences and finish it up. So how about if you use a presentation for it? Interesting, right? So maybe you can just use that to complete this particular section. So this is relatively a smaller and simpler problem, but this will give you a good idea how to build a linear regression, and there will be few challenges across while doing it. So these are the things we gonna work out on this. So there's a Chinese company, let's call it as TechLove Chinese, and they want to, let's say, enter into the US market. So they were the automobile company who want to enter into this market by setting up their manufacturing unit there, and then they want to produce the car locally to give the competition to their US and European counterpart. Now they have contracted an automobile consulting company to understand the factors on which the pricing of the car depends. Specifically, they want to understand the factor affecting the pricing of the car in American market. Since those may be different for Chinese market, especially the company wants to know what are the variables which are going to be significant in predicting the price of the car. So they want to specifically figure out that what are those factors which are going to impact the pricing column here, and how well those variables describe the price of the car. So based on various market survey, the consulting firm have gathered a large data set of different type of cars across the American market. And the business goal is that you are required to model the price of the cars with the available independent variables, and it will be used by the management to understand how exactly the prices vary with the independent variable. They can accordingly manipulate the design of the cars, the business strategy, etc. to meet the certain price level. Further, the model will be a good way for the management to understand the pricing dynamic in the new market. And we also have to do some data preparation here. There is a variable called as car name, which is going to be comprised of two parts. The first word will be called as your car company, and the second will be your car model. So for example, if it is written as Chevrolet Impala, then Chevrolet is going to be your car company name and Impala will be your car model. So you need to consider only the company name as an independent variable for model building. Again, I have given you even the dictionary along with it, and this data set is also available in UCLA repository. So you can also get all that data set. This data set will be easily available outside, and in fact, you might notice some solutions on Kaggle for this as well. So, but this is a quite simple problem as per, if I compare with the other problems, I found it a little simpler, but this is going to give you a good insight on linear regression. So that's the reason I have chosen to keep it inside this particular course. So now we're gonna divide this problem into four parts, but before I go into the solution, again the same request, please do try to solve it first on your own. And this is relatively a simpler problem. Any further problem which is gonna come is going to be much more complex than this problem. So I would strongly recommend all of you to please try to do it on your own first rather than looking at the solution. And especially you should look at the data dictionary well, because if you're not clear on the data dictionary, you will not be able to understand what I'm going to explain you in this. So I'm not going to go over the data dictionary. This is something which you have to do. Okay, my focus would be to make you understand the problem. So here there are the four steps we're going to follow. One is to understand the data, then we will do the cleaning part, then we will do the preparation part, then we will build the model and evaluate it. So let's look at the first part where we're going to explore and understand the data. So first we need to import these packages and we need to load this car price assignment, which I've given to you first to solve it. And then we can look at the information of this. We can see that this is all the data what we have. We can see the basically this data quickly. This is the data what we can see here. Now let's try to understand the data dictionary. So once you have looked at this, you can see one part which is symboling there. One column will be there, which denotes that -2 means less risky and +3 means more risky. So the value will be ranging from -2 to +3. So what we're going to do, we will count that how many values are available here. So we can do a value count for it and can see that there are basically 0, which is like neutral kind of part, where they are 67 in number, but -2, -1 is also having some count. Now, similarly, you will see another variable called as aspiration. This is an internal combustion engine property showing whether the oxygen intake is through standard or through turbocharging, right? So that is basically the aspiration. If you read through data dictionary, this detail is there. So let's convert it to categorical because we have only two and we can count that standard are just like 168 in total and turbo is like 37 in total. Now let's do it for drive wheel and front wheel or four wheel. So you can see here that this is how the distribution for drive wheel is gonna look like. Now look at for wheelbase. Now for wheelbase, we have just done a distribution plot because again, this is kind of a numeric value. So when we did this, you can see that most of the values are falling around 90, right? So somewhere around 90 to 100, this is falling more. Similarly, when I did it for curve weight, again, this distribution is going well. We have done it for stroke also to see that where the maximum values are coming up. And similar thing, we have done it for compression ratio. In fact, you can see in compression ratio, things are moving towards the right hand side as well. Now we have done it for pricing also, and you can see that most of the pricings are around like 10,000 and so on, right? So that's what is the pricing maximum coming up. Now let's do some data exploration. Now, in order to, before we apply linear regression, it's always better to look at the correlation and all. So maybe one thing which we need to do is we need to look out first all the numeric and float values because definitely we cannot do the correlations or looking at the pair plot. We cannot look at all that on the categorical data. So we have to look at all these things from the numerical data. So we will pull out only the float and integer value, and you will notice that there are few columns like symboling, right? It's though it is integer, but we will treat it like categorical because you have only 6 values, so you will not make much inference if you treat it like numeric. So now what we're gonna do, we have dropped this symboling and we can also drop car ID. And remember, we are dropping it from the numeric variable, not from anything else. So when we have done that, now further to this, we can draw a pair plot. So we are drawing the pair plot for all the car numerics, basically, which are integer float, and we can see this result. If you want, you can go ahead and try to see some nice relationship. It's very difficult for me to look at it without a microscope because there are so much of huge numeric column. So better thing is maybe we can look at the correlation matrix, and with the correlation also it will be difficult. So let's draw a heat map, and this heat map will tell you quite interesting thing which I have noted down below. So first is we can see that price is highly or positively correlated with wheelbase, car length, car width and curve width, engine size, horsepower. Notice how all these variables represent the size, weight, engine power of the car, right? So definitely, even if you think from your own personal experience, these are the things which impact your car pricing. And the same, if you look at the values here, you will notice that they will be more closer to 1. That's the reason these are highly correlated. Similarly, if you will look at the city MPG and highway MPG, they basically, it will be like minus 0.7. You can just match up with the above graph. So they are negatively correlated with the price. This suggests that maybe the car which is having a high mileage, right? They might be cheaper in price. So you can think of like a middle class family. They kind of prefer to go with Maruti and all that, right? So Maruti 800, if I'm talking about Indian market. So the reason they do that because they look at the average and all more than horsepower or anything else. So they don't bother about much other things than mileage. Similarly, you would notice some correlation among independent variables like basically you will see that wheelbase, car length, curb weight, engine size, they are all the measure of like size by weight. That's the reason they are all positively correlated, right? So now this becomes very important factor. You cannot really ignore it because you have to make sure that you need to remove all the multi-collinearity before you create a final model for yourself. So this is a very important factor. Now we're gonna perform some data cleaning and data processing part. So let's look at the information. This is all we have, and you can notice that we don't have much of the missing values, or in fact no missing value here. So the data is given to you clean, and the data is not also that huge. So that's the reason I was telling you it's relatively a simple problem. This symboling was into integers, so let's convert it to object. Let's treat it as categorical as I explained you earlier as well. So we have done that, and now let's look at the car name. Remember, in the car name it was mentioned in the problem statement that we should pull up the first entry from there. So we will take up only BMW, let's say from BMW X1. Similarly, BMW X3 will be treated as only BMW. So now let's take out the data. We are splitting out the zeroth index, and this is the data. But now this is also kind of alpha hyphen and all that. So let's basically bring it and use a regular expression to bring it properly. So that's what we are doing now. Now once we are done with this, we can just basically apply this up, and now you can see that all those dash and everything is gone. Now once we have done, one thing you notice that there are a lot of spelling mistake. Like one also you can notice that let's say Nissan is mentioned here, and somewhere basically here you will also, and in fact you can also see Toyota have a wrong spelling. You have a VW here, we have a Volkswagen here, and similar thing was there for Nissan as well. Let me just show you up. So you would notice that Nissan is starting with capital N thing, right? So one is small n and second is capital N. So there are a lot of mistakes basically here which need to be fixed. So I've mentioned out all the things here, like VW and Volkswagen should be Volkswagen. Similarly, Porsche spelling is wrong, Toyota spelling is wrong, and so on. So we have just written a simple Python code to fix it. Once this is done, we can again look at the value count and so on. Now further to this, we can drop the car name because we have already derived the column which we want. And then after that, we can just look at the data, everything looks good. Look at the information, things look good. Let's go to the data preparation phase. So now these are the columns we have. So we have separated out X and Y. And what we need to do for all the categorical column, we need to create dummy variables. So that's what we are doing in the next phase. Once we are done with the next step, so we have created a dummy and all that, we can drop the original categorical column because that's what we don't need it, and can merge the dummies column which we have just created. Once we are done with this, we have to scale the data. So we are basically taking the step here to scale all these things up. And once we have scaled the data, now we are going to split it into 70-30% data set. So if you notice, now I'm moving to this project very quickly because all these things, if you have done my machine learning course itself, I have done it in the case studies there. It's just that definitely this is a kind of a little bigger project than that, and we have to look at multiple things in this, but at the same time these steps we have done it there. So that's the reason I'm moving little faster, assuming that you know all this. If you have not done all this, you need to first go and kind of work on the machine learning course before you kind of jump to the project section directly. So now we are going to build the model. So we're gonna use the linear regression and gonna fit this train and test. Look at the coefficient and intercept value which is coming up from this, and we can do the prediction on the test set. And when we did this and calculate the R square, you will notice that we got 83%, which is okay, not bad. But remember, this is on a huge set of columns, so we would like to kind of decrease them. So in this case study, I'm not going to assume PCA knowledge at the moment. So I'm going to go with respect to simple RFE method because I want to show you that how to use RFE even in this. But feel free to use PCA or TSNE as per your wish. Now with, let's say, 15 features, if we go, let's say we directly reduce it to 15, so we can just go and look at the ranking, support and all that, do the prediction, look at the R square. So we got 89%, which is good, right? We are getting a better accuracy, means R square, sorry. Then we can go with 6. With 6 also we did a prediction and all, and now we got 88. Okay, so we got this value, but which one we should choose? Like, should we go for 6 or should we go for 15, right? But actually we should not look at R square only. We have to also look at adjusted R square. That's one of the important metric. And to get the adjusted R square, we need to use the stats model. So let's now create this model again with stats model. So now I'm going to create with 15 columns first, and when you're gonna do it with this summary, you would come across basically with this 15 some 93.9% of R square. Remember, it's a stats model, so things can go a little different, and adjusted R square is 93.3. Now let's basically do the prediction by adding constant and then doing a prediction with it, and then look at the test score, which is 0.89, right? So although the training was 0.93, but on the test is 0.89, and for me it's more important to look at the test rather than on the train. Now after that we can basically go and apply for the 6 columns, again applying all the same steps, and with 6 I got basically R square of 89 and basically 88.5, right, on the test set. So this is what we are getting for this part. Now what should we go for? Should we go for 15 or 16? For 15 we are getting a little better accurate R square in comparison to 6. But what we can do, but can we stop at 6 and 15? How about trying at 4? How about trying at 8? So in order to do that, how about we treat it as a hyperparameter and create a kind of a function which will run from 4 to, let's say, 20, and we will see that how the adjusted R square and everything is coming up, and we can plot a graph for it. So this is a simple function being created for, which is going to run from 4 to 20, and you can notice that in this particular whole code we have basically written this predict and R square, and then we are just plotting this test R square, train R square and adjusted R square in this case. And you can notice that test R square is decreasing after the basically value somewhere around 12 or 13. So we should not even look at any value greater than 12 because it is decreasing. And if you look at this value between 6 to 12, it's kind of not moving much, especially if I look at test R square. So we will like to go with more simpler model. So I would choose the value 6 in this case. Now again, you would have noticed that I'm not talking with respect to each and every line of code, because again I'm going with an assumption that you know all this. It's only I'm giving you a pattern which you need to follow, and please walk through each line of code on your own. If you have any problem, raise in discussion forum, but please, you have to do everything on your own at your end. You should not do the way I'm doing it, and this is just for an explanation part, but you should definitely write all this code by your own if you want to become a good data scientist. Okay, so now we're gonna go with the 6 features data. So we gonna basically look at this part. We're gonna take the final model with 6 features and gonna build this whole code. And remember, I'm using this OLS method to do this. Then we are doing this prediction and all that, doing the summary, looking at the R square, adjusted R square, calculating the R square score for test data. Now what we're going to do is we're going to evaluate our final model. We're going to see that whether this model is good or not. So there are few things we need to note here. The error term what you're getting should be kind of approximately near to 0. So the distribution should be more around 0. Second thing is there should be not much sort of correlation between the predictors. So we will see the 6 variables what we have got, there should not be too much of the correlation between them. And the third thing is we will look at the spread or the variance basically apart. We want to check basically this homoscedasticity feature, but if you don't know about that, you have to basically read about this part. This is a linear regression assumption what we do have. Now look at this. So when we have plotted this error term, you can see that the value is more or less kind of around 0. In fact, what we can do is we can see the other plot, which is y test minus y pred, and you can see that this is around 0, and if we calculate the mean value, this will tell us that we are coming around minus 382, which is almost close to 0, right? Because if you look at the whole distribution, this minus 382 is not a very huge term. Now further to that, we can see the distribution of this plot. Now let's look at the multicollinearity. For that, we can draw a heat map. We can see that yes, at some places we do have some sort of high correlation, but at the same time it's your call to take, because when I try to remove it up, it was increasing the adjusted R square. So if you want, you can definitely try out removing some of the thing and can compromise with a little bit of adjusted R square. But for now, I can go with this 6 features and can tell to my company that, okay, you can probably use these columns as the main predictor for the price. So this is accordingly, you can give the pricing part for it. So this is the very simple project on, I should not even call it a project. It's a simple case study which I have added it for a linear regression, so that you at least get from starting to end without using PCA on a bigger column data set, how to solve something and come up with a model, how to choose a better model from all the other models what we have created. And we have also seen the RFE kind of usage in this case, but I want to give you an assignment here. You have to try with PCA this thing and see that how it works. This is a very interesting case study where we are going to compare two texts. Now a text can contain a string of words, and that's what we want to compare, but definitely it's going to be much more interesting than that. So I hope everybody is aware of Quora, but if you don't know it, it is very similar to the platform like Stack Overflow. So in your Stack Overflow platform, you can anytime go and there you can write any of your technical question, and people are going to respond to that technical question. And then any other user or you yourself can go and upvote or downvote that particular answer. Similarly, Quora is one of the platforms where a user can go and type any generic question and they can get their responses. So let me show you how it looks like. The platform looks something like this. If you see here, like you can have any type of questions coming here, like what are some unwritten social rules everybody should know. If you click on more, you can even kind of read some very interesting responses what people do write with respect to images, right? So that is very interesting answers what you can read. If you like it, you can always go ahead and just upvote this, or if you don't like it, you can anytime go and downvote. So you can see the support option, there's a share option, you can downvote it, even you can report it and so on. So all these things are available. If you want to ask any question, you can always click on add questions and you can always ask a particular questions here. And this is a very famous platform. In fact, I myself use this a lot. So I kind of prefer to kind of keep reading a lot of question answers. It's an unlimited kind of resource for you to get a lot of knowledge about anything and kind of hear up the other point of view on any particular topic. Now, but since this platform is quite famous, definitely there will be few of the things which require a good solution. For example, maybe I can write a question which is already kind of being asked by somebody else, right? But there is a catch here. Maybe my wording and that question wording is little different. Okay, that's where is the catch. Now, there is a possibility, if it is exactly similar words, I can simply say that, okay, these two questions are duplicate, but that's not the case here. In fact, the case here is that I don't really know that what is going to be the sequence of what. Maybe somebody can write the same thing in a very different way, and I can ask the same thing in a very different way. Now, what the problem statement here is, that Quora want to identify two very similar questions, so that once they notice these questions which are very similar, they can kind of mark it as duplicate, and they can a person who have asked question 2, let's say, who have asked later, so all the answers from it he will be able to immediately view it here, right? So if that happens, so at least the user who have asked the question, he need not go and search here and there. So he will be simply able to come and read the answer. So I want to kind of create a connections maybe between both the questions, which I'm finding it as duplicate. In fact, this is one of the solution. This is one of the solution the Quora is already using in it. Because if you are a Quora user, you might have noticed a lot of many times that they do kind of mention that okay, this is duplicate, or you post a question, after some time you get that notification, and then they start showing you that answer. So they are using it, but at the same time, what they have done, they have made this topic available on Kaggle for everyone. They have made it kind of open for everyone, so that any user who wants to come and can provide a good solution, they can go ahead and do it. Now let me show you how you can view all of that. So you have to come here. I have already given you a link here. You can just click on this link. It will take you to the Kaggle page. Now here you can see that it is awarded with 25,000 US dollar kind of money if you are able to win this particular competition. And you can always go and kind of basically you can go ahead and try to explore this particular problem. It is very interesting, guys. It's very interesting. In fact, you will find a very real data set what Quora have provided to us, and you can just go ahead and look at the data set and try to understand and kind of try to solve it. In fact, I would strongly recommend you, after solving so many case studies, you can definitely attempt this question on your own, and if it do not come up, definitely you can have your solution for it. Now here also there is a evaluation metric. Like you can see here, you also have a log loss which you need to basically load up. You also have your data. So here again, log loss we have already learned in my last case studies as well. Data, if you want to download, you can anytime go here and can download, let's say this train.csv. This too includes a lot of data for you. So you can go ahead and download and can start using it. If you want to download it, one way to do that is you can just type this particular command and it will help you to download. But you can, when you will directly type it, it will give you an error that Kaggle is not found, right? So you need to go to this particular link to get the Kaggle API. The whole description is there. You can always go ahead and install Kaggle APIs. And then when you will do it, the data set will come to you. On the other hand, since this data was not very huge, so we are also going to upload this data for you on the portal. So you can anytime download it directly from there as well. It's up to you how you want to do it. So let's start working on this interesting problem from next video lecture. Okay, so after we understood the problem, let's go ahead and start working on this data set. So first we need to import all these packages because these will be definitely required for you. After that, we are going to load this train.csv file, which includes all the data set provided by Quora. Now, if we look at the shape of the data set, we do have some 404 290 number of rows present, and there are 6 columns which are present. So we will understand what are those 6 columns. Then further to this, we can just describe just to understand that how many of the values are present here. And we can also do a quick information check by looking at what is the type, how many values are present, and so on. One interesting thing you can note here, that there are definitely some missing values, right? You can see here that we do have like 2 missing values in question 2, because looks like total number of values is 290, here we have 288, and looks like there is also something catchy here, 289, right? So we may want to deal with missing values in this case. So this is one of the good information what we can capture from here. Now we can look at the number of columns present in this. So we can always see columns, and we can see ID, QID1, and so on. Let's understand what is this columns. ID is your definitely row ID, which we can always mention it up. Second thing is you can find second thing here as QID. QID means any unique ID for your questions. For example, in this case, I have QID1, QID2, means there will be 2 questions which I am going to compare. Both will be unique questions, and I am going to compare these 2 questions which belongs to this ID. Third one is what is that question 1, right? What is the text present in that question 1? Question 2, what is the text present in my question 2? And then there is a is duplicate. If the value of is duplicate is 0, that means the question is not a duplicate. If the value is 1, that means that question is a duplicate. So that's the reason we have defined like this. Now let's see that how the data is going to look like. You can see here that this is the row ID. We do have QID 1, means the question IDs for each. So question ID 2, what is that particular question 1, what is that particular question 2, and then we do have is underscore duplicate. So this is what we can also see it from here. Let's see a few of the examples to have a better understanding of this. So you can see here that we do have this sort of data where we have ID, QID 1, QID 2, question 1. But let's see this. So let's say for row ID 0, we do have a question ID 1, question ID 2, and the question is, what is the step-by-step guide to invest in share market in India? Okay, that's the first question. Second question is, what is the step-by-step guide to invest in share market? So the first question is very specific to India, while other question is very much generic. So definitely they are not duplicate questions. So we have to mark it as 0. Now let's look at the second one. What is the story of Kohinoor diamond? What would happen if the Indian government stole the Kohinoor diamond back? Right now, if you look at it again, both the questions are very different. So again, we will mark it as 0. Let's look at the third question, which is not basically, which is going to be similar. How can be a good geologist? What should I do to be a great geologist? But if you look at this question, the wordings is definitely very different, but they both are similar in nature. That's the reason we're gonna put it one value. Similarly, we can also look at another question. How do I read and find my YouTube comment? Second question. How can I see all my YouTube comments? Again, this is similar. So we're gonna mark it as 1. So this is how my data looks like. So given any two questions, I want to predict whether it is going to be similar question or non-similar question. That's a problem statement, what we are going to solve. Now let's understand that how this problem is going to translate in machine learning world. So since my output is going to be either 0 or 1, because here we are saying that whether it's a duplicate question or a not duplicate question. So it is definitely a binary classification problem. We have also seen before that from the Kaggle competition that we are looking for a minimum log loss problem. So that's the reason the evaluation metric is going to be a log loss here. And we are also going to look at binary confusion matrix because that's what we normally understand more easily. So that's what we have added extra. Now there are few things to keep in mind while solving this particular problem. If there is any error, imagine that there is a question which is not duplicate and Quora thought it's a duplicate one. Then that error is going to be very costly for Quora, because in that case people will have mistrust on Quora. They might be expecting some answer, but they are getting wrong answers now, right? So they will kind of lose their interest from Quora and people can move away. So the errors are going to be very, very costly for them. So since the error is very costly, maybe it will be a good idea if we talk in terms of probability. Means maybe I want to create something like probabilistic part, like probability that question 1 and question 2 are going to be similar only and only if the probability of their similarity is maybe greater than or equal to 0.99, means 99% or above. If that probability is, then only I'm going to say that these questions are similar. Otherwise, it's better to keep them non-similar only. Even if they are similar, let's not touch them up. Otherwise, it may end up with a lot of other issues. Now, so we can decide that threshold for us. What about time taken? Do you think we need a lot of time to do this, or we have to very quickly return the result? No, means it's okay. We can take some our own sweet time. Definitely, it should not end up taking almost the whole day also. Yeah, but your model is okay to take maybe a few minutes to give you the output, and then you can send a notification that yeah, these are duplicate and we are merging this up. So that's something you can always do. So the latency you can have with your own pace. What about interpretability? Do we need interpretability? May not be that important. From at least for the user point of view, it's not important. When Quora is going to mark any question as duplicate, Quora need not inform that user why I'm marking it as duplicate, right? This may be required for their internal part, but definitely they don't need it to show to the particular user. So these are the things you need to keep in mind while solving this binary classification problem. So let's do it from again the next video lecture. So now we are going to look at the distribution of the data. What I mean is that we're gonna give some answers in terms of like how many values are 0 in duplicate column, how many values are 1 in duplicate column, how many unique answers are there, and so on. So we're gonna find out all those answers now. So to start with, we're gonna take up this part where we're gonna write this code just to identify that in my data set how many are 1 and how many are 0. So you can see here that 0 values are much more than your 1. So, and that's basically means that most of the questions are going to be non-similar in nature rather than similar in nature. Now moving ahead, we are also going to figure out the percentage now. So because from this graph you are not able to make out that what's the percentage that the values are 1 and what is the percentage that the values are 0, means what is the percentage of duplication in the data and what is the percentage of non-duplication in the data. So those things we can easily compute, and the value for your similar questions is going to be 36.92%. which means that we're going to have 63.08% of 63.08% of the question which are going to be non-similar in nature. Further to this, we're going to figure out the unique values. What I mean by unique questions here. So let's say I have question 1 and question 2. I have question 1, question 3. I have question 3, question 4. So though there are so many parts, but unique questions are question 1, question 2, question 3 and question 4. So I want to figure out how many unique values are present in this. So I can easily do that again with the help of this particular code where we can figure out only the unique questions, and my unique question comes out to be some 5,37,933. These are my unique questions what we have in the overall data set. Now further to this, let's answer a few more questions. Like we want to, let's say, figure out that how many unique questions are there which are repeating more than one time. So that code also we can just very quickly write it up, and we got almost 1,11,780 questions which are getting repeated. In terms of percentage also we can look at, that means 20.77% questions are there which are getting repeated. We want to figure out now the question which is repeated almost the maximum number of time. So that also we can get that, and we got 157 as a number which is getting repeated maximum number at a time. Now we will also do few more question answers, but let's do that in the next video lecture. So now let's explore a few more in terms of graph, the data distribution. So here what I'm going to do is, now I'm interested in finding out how many questions are unique questions and how many questions are repeated questions. So you can see that in this case definitely my unique questions are much more in number in comparison to my repeated question. Now after this we want to see that is there any questions of a category where, let's say, I have question 1, question 2 being asked, and maybe question 1 and question 2 again given, means a duplicate question but again in pair. So that is there or not? So we have figured out that no, there is no such type of question which is a duplicate question. If there was such scenarios, we would have to tackle that as well. Then we would have to remove some of the that duplicate data from it. But in this case, we can see that clearly there is no duplication. Then we can also check number of occurrence for each question, and in this case we can also plot a graph for this. So again, this code is quite simple, so I'm not gonna go into each point of code into each project. In fact, in the initial few projects I have already gone through in depth of your code as well. Plus this is all expected that you guys are aware of, so I'm not going to go into depth of each code point. So now here you can see that we do have, there is a question which have occurred 157 times, but if you look at this overall graph, you can notice that most of the questions here are coming like 1, because if you look at this is 1. So most of the questions are just coming once. Then there are few questions that the graph is coming down drastically, right? So you can see that only one of the question is there which is 157 time in number. So this is quite low in number, and remaining maximum of the questions are quite repeating less times, but still this graph is here till this step. So this is how we can evaluate with this graph that the questions are getting repeated how many number of times. Now the next step what we're going to do is we want to find out the missing value. If you do remember, we were looking at the info command, and from that info command we have seen that there were few questions which were coming out to be NaN. So you can see here that this is the NaN values are being showing up. Now what we are going to do in this case is wherever my value is NaN, I'm going to replace it with the space. So this is going to be like a missing value, but I'm just representing it in a better way. So that's what we will do. Then once we are done with all this, we have to look at some feature engineering step. Now that is I'm going to explain in the next video, but this is the most crucial part of this particular project. See, analyzing and all that is now quite simple. We have already seen it so many times, but when we have to come to feature engineering, it becomes very important to understand that what are the columns we need to add extra. We can think of them as a derived column. So that we will learn it in the next video. Feature engineering is one of the most critical part of this project, as I said to you in the last lecture as well. Now in this case we are going to derive some of the frequency, and again I would like to thank and credit from a lot of places from where I have myself learned about how to derive all these columns. Now this is an art. Even while solving this project itself, I have learned from various places that how to do all this. There were few new techniques when I came across, and I was taken by surprise. Okay, this is also possible. So definitely whatever I am deriving, maybe there can be much more than that. Okay, so you can always look forward for a few more things. What I'm going to do is I'm going to show you up that how you can think of deriving some new column and how you can judge the importance of those columns as well. Like it's not mandatory that whatever columns you are going to derive, all the columns are going to be the best column, right? It may be possible that they are not. Maybe they are not going to impact your final output of 0 and 1. So in those cases, we would like to ignore those particular columns. So how we can decide on that? So that is what we're going to discuss in this particular lecture. So this is going to be kind of very interesting. In fact, I would call this step as the basic feature engineering. And once we are going to be done with this, I'm going to show you something like advanced feature engineering. Okay. Now that is going to be interesting. That what is basic feature engineering and advanced feature engineering. So we will add some more extra columns, which are going to be even more interesting, and you will notice that they will be much more fruitful in terms of giving a response. Let's start with the basic feature engineering right now. So to start with, first column which we are going to derive from here is your frequency question ID. So this is just to look at how many question ID ones are available in my data. Then the same thing is we are going to look at frequency of question ID 2. What is the length of question 1? Okay, so what is the length of total question 1 and the length of question 2? That can be basically another derived metric. Q1 n word means number of words in question 1. This is different from this length. Okay, length means total length by word, character by character. But when I say Q1 n word, it means I'm talking about words. Okay, so not character but number of words present in question 1. Similarly, we can also derive number of words present in your question 2. Once we are done, now this is going to be interesting. We have something called as word common. Now, what does this mean? That we are going to derive a column which is going to just find out the common unique words present in question 1 and question 2. You can think of it just like intersection of common words between Q1 and Q2. Then word total is just going to sum up your words in question 1 and question 2. You can think of it like a union of question 1 and question 2. Word share, this is interesting. In fact, when I will show you up that when you will analyze this, this is going to be one of the important factor for basically deriving 1 or 0. This is going to be interesting. So here you can notice that what we are doing, we are basically word share is going to be word common divided by word total. You can think of it like what we are doing in this case is Q1 question intersection of Q2 question. Basically it's going to be common words, and then Q1 union Q2, though it is not exactly same to be frank, but this is basically something around that what we are calculating in this word share. So we are basically getting the basically the average of what is going to be the common words divided by total number of words what is being present in question 1 and question 2. So that's going to be interesting. Now then after that we are just adding up the frequency of question 1 and question 2. So this is another column, and we are also adding a column with frequency of question 1 with minus subtraction with question 2. Now these are the columns we have derived. Again, this is not going to be the end of story. You can always go and look back at lot many other ways to also see and derive different new columns. Now this is just a simple code to achieve that. Okay, so like for example, you want to find you are writing a function to find the total number of words present in it, right? So this is very simple. What you are using the set method to get the unique values, and then you are just basically adding them up. So this is just a very simple code. You can walk through it. Very simple Python code, and this code is just going to help you to add all these new columns which we have discussed. Now once you have added that, you can notice that all these columns came as a part of my data set itself. So you can see here that now it is adding up frequency QID, frequency QID2, what is the length of Q1, Q2 length, number of words present in Q1 and Q2. We have how many common words present, how many total number of words are present, and you can notice that we do have something called as word share. We are looking at the frequency of question 1 plus question 2 and frequency of question 1 minus question 2. So these are the columns what we were also deriving above, and that's what you can see in the data set. So we have added all these extra columns. Now what we want to do, we want to understand that what is the significance of all these columns. So as I was telling you before, word share was one of the very interesting column which we have got. So I'm going to discuss about that column, that why I'm saying that this came out to be good. So what we have done is we have drawn two plots for this to understand this particular part. And you can see that this is on the, if you look at this right hand side part, my word share, this is going to on the x-axis, and basically this plot we are looking at, if it is, let's say, going to be red color, that means they have a similarity. If it is blue color, they don't have a similarity, like that. One interesting thing, if you note here in this particular graph, we are getting a graph where we have some sort of overlap coming, right? It is coming like this. So if you recall from your EDA analysis what you can basically perform, definitely the best graph could have been that if you would have somehow got with the word share, that as and when my, let's say this is somehow I got the graph. So let's say this belongs to 0 and this belongs to 1. Then I could have very easily said that, okay, if my word share is lesser than this, I could have written logic. If my word share is less than this, then all the values are 0. That means the similarity is not there. If it is greater than this, then basically there is a similarity is there. But that's the ideal case scenario, which is not going to happen in this case, definitely. So in this case, we do have some sort of overlap coming up. So it is not the best, but it is not the worst also. So you can notice that if my word share is increasing, definitely in that case I'm noticing more of the points getting into similar zone, right? And on the left hand side you can see that if the word share is less, then most of the points are falling into my zero zone, right? So this is an interesting fact what we can get from it. And in fact from here also you can see that this is a volume plot, but if you draw a box plot with it, right? So box plot is going to look something like this. This is going to be a median, and you can see here also if I draw this box plot, this is a median. So you can see here also, though my box plot is exactly not coming up to be similar, but still my box plot is something like this. So there is a small difference basically here. So this for word share 1, I do have basically median value to be higher than this. So we are still able to infer something out of it. It's not going to give us the exact inference, but we can still come up with some inferences in this case, and this means that this column was actually coming up to be one of the good column to go ahead with. Now let's look at few more things with respect to this. So this we understood that word share can be an important factor. Let's do the same kind of working with respect to my word common column which we have also created. So now in this case we can notice that when we draw this graph, this do not comes out to be good. So you can notice that this is the worst graph, right? If I have something like one plot is coming like this and the second plot is also coming like this. That means I cannot at all infer anything about from this particular column about for basically something like whether it belonged to 0 or 1. And even if you look at their histogram here as well, my histogram are also kind of very similar. If you look at this, there's no much difference in terms of height of both the histogram medians and all that. So this column is not useful. Now I want to give you as a homework activity to try this for all rest of the columns, though I have done it only for these two, but I would strongly recommend all of you to follow this and see if you can also do this exercise for remaining all of the column. In fact, we have done this and we have not found any other column to be much more useful. So this was a very nice way of figuring out whether a particular column which we have derived is going to be have any meaning or not. But definitely we did got word share, which was quite useful. So let's keep that, and we will see that this is going to be how we're going to use it in the further purpose. So now after we are done with this, we have to also do some processing on the text data, because that text data is huge and we definitely cannot just use it as it is. We have to do some changes in terms of removing some stop words and all that. So we will see to this in the next video, that how to perform all of the text processing. So now let's perform some text pre-processing on this data. So we do have a lot of text, right? Because we have questions, question 1, question 2, which is completely in the form of text. Now text contain words. So definitely we cannot just use it as it is as an input to my machine learning algorithm. Instead, I have to transform it into a format which my machine learning algorithm can understand. Now, in order to do that, we have to follow some steps. Like for example, since Quora is a web page, definitely it's going to have some sort of tags like BR tag, H tag. So we would like to remove them. We can't keep all these tags into my problem, because if you think about it also, it's not going to be any helpful in determining that whether the question is similar or not, right? Because if somebody is saying BR, that means he want to go to new line. If he's saying H, so maybe he want to define a heading, but that have basically no kind of significance in form of when we look at the similarity. So we may want to get rid of it. Second thing is removing the punctuation. So in my problem, I do have semicolons, I have comma, I have dot, right? I have this colon. So I would like to remove all of them also, because again, this is also not going to be any helpful in kind of predicting my final output of whether it's a duplicate or not. Third, this thing you have learned a lot during your NLP part. So I'm not going into this. In fact, this is the main thing what we perform in our NLP, doing the stemming, removing the stop words like a and the, right? And we also want to make sure that running, run. So these are the same kind of words and we want to represent them a similar way. So those are the steps also we need to perform. We will also do some contradiction. In fact, this was one of the fun part which basically we learned while solving this problem. If you look at this contradiction, what basically it means is, like if you look at the data, like some people have let's say habit of writing let's say 1000, right? So what I will do, I will represent it as 1k. So you can see that I'm just looking at replace. If there is 000, I'm going to represent this as 1k. Similarly, if this is the thing, I'm going to represent it with m, which means million, right? Similarly, if I have basically this sort of stuff, I'm going to replace it with this. So you can see that we have a lot of meaningful kind of conversion which we are doing in this process. So we have like won't, which means that will not. We have cannot, we can replace it with this. So whichever is making sense, like if we do have like she is, right, I am. So we do have a habit of writing like this. So we are kind of physically transforming all these values. Now we also are transforming sometime, let's say somebody have written rupee like this. Like this is, if you don't know what is this means Indian currency. Now I am representing it like this. Similarly for Europe also we can define it. For percent also we can define it. So like this, what we are doing, we are kind of transforming to a meaningful information. That's what we are basically going to perform into this part, contraction. So this was even this is the beauty about machine learning, that you keep on learning while solving these kind of problems, and you really learn a lot while doing so. So rest of the code is quite simple. We are just performing those steps of, we are using the Potter stemmer, we are going to use all that beautiful SOAP and all those functions to basically perform all these things what we have just discussed, right? So this is quite simple way using which we can process our text data and can basically come up with some very interesting outputs. Now in the next lecture we are going to perform some more advanced feature engineering part. So we will see that how we can create few more columns and those will have a good impact on my final output. So after we have done the pre-processing with the text data, now the next step is again coming back to some feature engineering. Now if you remember, in last few lectures I was talking about that right now I am doing the basic feature engineering, but later I'm gonna again come back and do few more feature engineering, and which I'm gonna call it as advanced feature engineering. Now in order to do that, I need to define few words here. So let me make it more clear. Like the first is token. Token means, let's say if I have word, right, present in my string 1, 2, W3, W4. If you split them, just like if you are coming from Java background, you might have heard about something called as string tokenizer, right? If you don't know about it, just ignore that up. So just like you are splitting it up into different tokens, split each word separately, that is basically called as a token. Okay, simple statement. Stop words we have already discussed a lot into our NLTK part. So it is, and, right, if, and so on. So all these words are called stop words. What is a word? Now word is also a token minus stop words. So like it is basically, word is nothing but a token only, but it is not going to include any sort of stop word like is, and, a, the. So these are the three things which is just to keep you informed, so that it makes our life easy once we go and derive some more sort of feature for it. Now let's understand the first two basically features which we are deriving here. Now the first is telling that it is the ratio of common word count to the minimum length of word count of Q1 and Q2. What does this mean? This means that whatever is the common word count. So let's say I have basically it's going to be for question 1 and question 2. I collect all the words and then I do take all of the basically I took the intersection of them. So I took all the common words being present in both the tokens, and basically then basically when I say this, I'm talking about word here, so I'm not basically considering the stop word. So then I just got all the words from it and then divided by, in Q1 what is the minimum length of the word, and in Q2 what is the minimum length of the word, right? So in this, basically whatever is going to be the minimum out of them, I'm going to just select that and divide it by this. So this is going to define my CWC underscore minimum, okay, which is common word count. You can call it as it is, common word count, and I'm getting the minimum. Similar way, I'm going to calculate or derive a new feature which is for the maximum part. So here again I'm going to take all the common word count. Again I'm going to look at all the common words between Q1 and Q2, and then I'm going to take the length of maximum of either Q1 words or Q2 words. Whichever length is going to be maximum, I'm going to divide it by that. So this talks about the first two derivation which we have just done. Now further to this, once we have done this, now if you look at the second part, which is CSC and CSC max. So in this case, we are just going to look at the stop word. So it's called as common stop word count. Okay. So in this case, what we will do, we will look at the common stop words in between question 1 and question 2, divided by again the length of Q1 stop words or Q2 stop word, whichever is going to be minimum, we're gonna choose that. And similar thing, we're gonna do it for the maximum. So we will just divide it with the maximum part to derive this particular column. Now let's also look at the third component out of it, which is your CTC. Now this basically means that common token. So if you remember, the first one was a word count, which do not include the stop word. Now here we're going to look at the token part. So it is going to be common token word count. So here we will look at all the common tokens between them, which will also includes even your stop words, and then basically divide by minimum or maximum. So by this we will derive these 6 column. So this 6 column is what we got, and now further columns we will see to that. Now a question which can come to your mind, that how you even come up with this thought process that this is how you should do it. Again, this will come by practice. Now, even I was not an expert while I was solving this problem. I would like to give all the due credit from where I also grabbed this idea. So I have gone through multiple research papers. I have gone through even the solutions what people have provided on GitHub, and I have looked at some top solutions which which were chosen to be the top solutions there, and from there I have seen that how those people were coming and deriving up all these particular columns and working on it. So this is how even I got all this insight. So you need not worry about that, how you can get that. So it will all come by practice slowly. Once you will kind of while solving this case study itself, you will come across a lot of different scenarios which will make you learn a lot. So we will see a few more advanced features in further lectures. So let's look at few more derived columns here. So we have just seen that how to come up with this 6 values, which is common word count, common stop word count, common token count, right? So we have seen this part for min and max both. Now we're gonna derive few more columns like last word equal, which is just gonna check that if the last word in Q1 and Q2 questions are going to be similar or different. So it is going to return 1 if it is going to be similar, otherwise it's going to return basically 0. Now similarly we're going to check for first word also, where if the word in Q1 and Q2 question, which is the first word, is similar, we're going to return 1, otherwise going to be 0. Absolute length is going to be like, I have a length of my basically all the tokens present in the question 1, and I have the length of for question 2 also is available. So token again basically is going to be with the basically it's going to include even the stop word. So it's gonna be length of them, and I'm gonna calculate the difference of it. Now there's a possibility that maybe in Q1 I got, let's say, 50 words, and in Q2 I got 60 words. So I will do 50 minus 60, so I will get minus 10. So that's the reason we are going to return absolute value. That I'm only interested in getting the absolute difference and not basically whether it's going to be negative or positive. Then we do have a mean length, and as you can see, it's quite simple. We're gonna take the length of tokens of question 1 and token of question 2, and we are going to take sum of them up and divide by 2, so we will get the average of them. So this is going to be mean length. So by this time we have already seen somewhere around 10 different derived columns which we have just done. Now after this we go to a very interesting technique called as fuzzy ratio. Now this is very interesting, that, and in fact this is not something which is done by us at all. This is completely, even we grabbed the idea from various places, that how people have used this fuzzy ratio portion. So now if you go to this GitHub account, you can basically see the whole code being available for this fuzzy. So this is basically fuzzy. In fact, the name itself is very interesting, right? You can see that it's kind of a weird name what they've given. It's funny, in fact. So basically you can install fuzzy by just saying pip install fuzzy, and this is just going to install at your end, because we're gonna use this package as well. Once you have done that, then this basically tells you a lot of examples also how to do that. But do not worry, I'm going to explain you that what exactly is this. Now if I go back, you can also see this. I've given you another link also, which is chair nerd. This is exactly coming from the same person who created all this GitHub account. So you can go to this, and there's a very nice written blog how to use this fuzzy. Now the idea behind this fuzzy is that given basically two questions, basically like Q1 and Q2, or two queries I should say, not questions here. So I would like to get the similarity between them. So the output of this similarity is always going to be between 0 to 100. Okay, now 0 means that the basically two strings are not at all similar, while 100 means the string is highly similar to each other. So that's what basically this similarity is going to tell me up. Now it works on a very interesting concept. Let me show you with some example here. It works on a very interesting concept of edit distance. So if you look at it, we do have something called as edit distance here. So this is a very interesting concept. So in edit distance, you can add a character, you can delete a character, you can shift a character. So like this, you can do some sort of operations on it. And the idea behind this string similarity is that basically here what we do, like for example, if you look at these two strings, New York Mets and New York Meets, though this is the name of two different teams, but still we just want to see how this edit distance works. So what edit distance means that by just adding, deleting or shifting the word, can I derive from first string to another string? Like in this example, if you look carefully, in this example, if I can just add a character A, I will reach to this, right? So this means they are very similar. So this is how the edit distance works in this fuzzy wuzzy case. So in fuzzy wuzzy case, we just look at whether by adding or deleting or shifting some character, can I reach to my another string too. So now in this case, you can see that when I was calculating the fuzz ratio between these two strings, since they were very nearby, I got the value 96, which denotes that these two are almost very similar. I could have even given the same exact thing if I would have given New York Mets and comma New York Mets only. I would have got the output as 100, because as I told you, 0 being the worst and 100 being the best. So this is how you do the fuzzy wuzzy part. Now we will explore this more in depth on fuzzy wuzzy, because even we do have some issue with this fuzzy ratio part, but we will do that in next lecture. So we understood about this fuzz ratio. So in fuzz ratio, we have discussed that we will look at the edit distance, and based on the edit distance, we gonna let the result that how many additions of character or deletion of character or shifting of character is going to bring up the final result, and based on that we were getting this result. But even this have some problem. The problem is, if you look at this part, like if I have a string, there are, let's say, two teams called as Yankees and New York Yankees. Now actually they are both the same team. Okay, so like for example, if I just say Royal Challengers Bangalore, if for people who watch IPL match in India, and or somebody say Challenger Bangalore, right? So something like that. So some people call it the Bangalore only, right? So people can call it just by short name or by the full name. So this is exactly same. So it should actually return you the total value 100, because these two are exactly similar. But what's going to happen here that we cannot do it, and in fact we're going to get 60 value here. Similarly, if we look at the first ratio for this, New York Nets and New York Yankees. Now these two teams are little different groups. Okay, so if you look at these two teams are different teams, New York Mets and New York Yankees, but still my fuzz ratio is coming out to be higher than even my Yankees versus this, right? So this is even higher in comparison to this, but it should have been the opposite way, in fact. So now in this case, what we should do, so we have this problem of basically doing this. So we go for another way of handling this situation. So let me show you how to do this. So in this case, we go with something called as partial ratio. So in partial ratio, what happens is, if you look at this example, here we do have something called as Yankees and New York Yankees. So what it do, it looks at whether there is a string which is a substring of the other, complete substring of the other. So in this case, yes, Yankees is a complete substring of the other one. So in this case, it's going to return you 100. Now, if you look at the other example where we have New York Mets and New York Yankees. Now, in this case, this is not a complete substring of this. So that's the reason this output is going to be lower. Okay, so that's how this partial ratio is going to help you with this. But again, partial ratio also have a problem. So let's see that how to fix that. So first of all, let's see the problem. Let's see this example. If you look at this example in out of order, so basically just before I basically go and understand that, let's go back to this. So we have already discussed about these two metrics. Okay, fuzz ratio, where we saw that with respect to edit distance, we can calculate our distance. Second is partial ratio, which looks at if there is any partial match of the string with the other. If it is a complete substring of the other, we call it as partial ratio gonna come to 100. And the third one now we're gonna discuss is called sort ratio. So let's see that what exactly is going to be this. Now, in order to understand this part, so for this we will go back to again over this. Now let's see. So here, what happened? Let's say if I have two strings like this. One is New York Mets versus Atlanta Braves. Okay, or we can say Atlanta Braves versus New York. They both are similar. Think about it like this. Like if somebody say India versus Pakistan, or somebody else say Pakistan versus India, right? Now, if these two string, if you look at, they are exactly same, but if you go and basically try to find out their fuzz ratio or partial ratio, you will notice a less value to it. It's not going to return you basically the exact value what you can expect here. So you can see that we are getting 45 and 45, which is quite low, but this should actually return as 100. Now, in order to handle this, we take something called as token ratio. So what token ratio do is, it is gonna first sort all the tokens and return it, and then gonna do a comparison. So when it is going to do that, you're gonna get all fully 100 result. You can see that here we are getting 100 result, because what it's gonna do, it's gonna return. You can see here in this example, like this string is first converted to your sorted string, and then when we apply the sorted ratio, we got the value as 100. So this is how we can go back and always look at the sorted ratio. But again, this also have a problem. That's the reason we have the fourth one. We will discuss that in the next lecture. Okay, so we have gone till token sort, and we have solved multiple problems till token sort. Now what we're gonna do is we're gonna look at the important factors. Like there is still some issues with this. Like for example, if you look at this token set, you can see here that in this particular example we do have like marine and angels, and here also we do have angels, marine, but there are a lot of other words which are also there. Now in this particular case, if we try to look at the sorted word, it may not work. So what we do is we take a little different approach to get a good output. So what we do is we basically, if we apply the token sort here first, so let me apply a token sort. Now we got to this stage where everything is sorted right now. Now there is a typo here, so you can see angel versus this part, but here there is a versus extra coming up, but there is no versus in this S2 string, sorry. So there is nothing extra here. So this is a wrong maybe typo in this block. Now further to this, we take a different strategy. Here what we do is we take T0, where we take all the sorted intersection. What is my sorted intersection in this case? I have marine and angel. These two are common words, right? Only these two. So this is going to be my sorted intersection. In T1, I have sorted intersection plus the words which is left out in string 1. So it's going to have marine versus angels, 3 words. T2 will have sorted intersection plus all the words which is left out in this. So let's see what basically we have done till here. So if I come down and see this result now, so you can see that this is my T0, T1, T2. And when I found basically when you look at it, how we got this up. So first this T0 is nothing but the common word. The T1 have common words plus remaining words in your string 1. So T2 also have common words plus the remaining words in your T2. And then after that, what we do is, as a next step, we gonna calculate the fuzz ratio of this. So we get, let's say 90, 96, 50. And then when we apply the set ratio, we got the maximum one, which is 90 in this case. This is how you get basically your set basically ratio for your token. So this is interesting, and you can see here that we can get the best result, but there are some problem with set ratio also. You can see that we have like two string like Sirhan, Sirhan and Sirhan. So in this case, it will return you 100 because it looked at a set of the value. So even though it's common, it doesn't matter to it. So these are the problems with it. I strongly recommend you to please go back and read this particular block. This is very nicely one of the best written block which I have seen. In fact, if you try to read any of the textbook, or if you have gone through any of the machine learning courses, you will never ever kind of come across in the courses about these things. But we have learned this particularly as a part of this case study. But this knowledge, you can keep it with yourself for the lifetime, because this is going to be really helpful for you wherever you are kind of trying to solve a problem, wherever your problem is kind of document similarity. If you are finding the similarity between two documents, it is going to be very, very helpful in those cases. So I would strongly recommend you to kind of walk through the whole block. I have given you the insight, but if you go through it on your own, you will get even a better clarity of how to do it. So we just understood what is fuzz ratio, what is fuzz partial ratio, what is token sort ratio, and what is token set ratio. And one of the very interesting thing about this is that you can also go and look at the source code what is written for this. So GitHub profile is already provided to you here, so you can at any moment you can go and look at the source code of this particular stuff, which makes it more interesting. In fact, I would strongly suggest you to please look at it so that you can get an idea that how people are coming up with such a unique and interesting ideas to solve these kind of problems. So I would strongly recommend you to please go through it and check this particular stuff. Now we do have one more stuff, which is longest substring ratio. What is this? So first of all, let's understand what is this longest substring. So when I say longest substring, what I mean by that is basically, let's say if I have two string like this, C1, C2, C3, C4, C6, C2, and so on. Let's say this is my string. And let's say I have another string which is C2, C3, C4, C6, C5, C9. So in this case, if you look at it, we do have a longest common string. If I have to catch, this is going to be longest matching string, right? Which is what? Which means the common string, that's the one thing. But what is the maximum length common string? So even these two are common string, but the length of this common string is 2. So I am looking for a common string which is at the maximum length. Okay, so this is called as the common string. In fact, if you are coming from the computer science background, in your algorithmic courses you must have read about these algorithms a lot, right? Where you have whole chapter basically dedicated for this. Now, so this is about what's to find the longest substring, and what we wanted to do as this column is we want to get the length of this longest common substring divided by the basically length of Q1 token and length of Q2 token. So whichever is minimum between two, I'm going to take basically the length of it and going to return it. So now with this, we have got so many derived advanced columns. So if you look at it from starting, we have 6 first records which we got for common word count, common token count, common stop word count. So there were 6 with respect to this. Then we looked at these 4 more, which is basically for your last word equal to first word matching. What is the length between difference of length between those tokens, and also we have figured out the average length for it. Then we looked at a very interesting concept of fuzzy wuzzy, where we got the 4 new values for fuzz ratio, fuzz partial ratio, fuzz sort ratio, and token sort ratio. And then we also looked at the longest substring ratio. This is basically one more extra part which we have just seen. So we got almost how much? 6 here, 4 here, which is 10, 4 for fuzzy token, which is 14, and 1 this. So 15 columns which we have derived. We'll see that how to use them up now. Okay, so by now we have calculated a lot of advanced features along with the basic features. Now what we're going to do, we are going to take up some more work with respect to creating all this, right? So we need to write a function for this, and writing of these functions is quite simple, right? So if you take a look at this, we have basically passing these 2 questions. We are calculating all the features, like you can see that we are also giving the name for this, like CWC min and so on, right? So these are the features we are creating. Even if you look at your fuzz ratio and all that, you can see that we are basically calling token sort ratio, token set ratio, and so on. So again, these are all the things which we have even discussed. It's just that we are going to put everything into programmatic feature. So we have created almost 15 features by now using this particular portion. Now, once we are done, we can see all this output. So you can see it here that what all the features we have just created after creating that fuzzy ratio. So further to this, let's do some analysis just to understand that how it's gonna look like. Now what we're gonna do, we're gonna look at a word cloud. What is a word cloud? Word cloud is going to look something like this. What does this mean? So this is a word cloud for all duplicate questions. So what this word cloud is doing is it is showing you all the words which are very commonly occurring into your duplicate question. So these are the words which are continuously occurring into your duplicate questions like Donald, Trump, difference, 1k, rupee, best way. Similarly, I want to see for the non-duplicate words, and these are the words like India, not, will, one, difference. So these are the words which are basically not very frequently occurring into a non-duplicate questions. Now, once we are done with this, this is just to give us some insight that, okay, what kind of words, if we see that most likely it's going to be, my algorithm is going to learn from it that, okay, if these words are there, most likely it's going to be kind of repeating question or a non-repeating question. Now, further to this, we have created a lot of features, advanced features. So what we're going to do is now we're gonna put all those features basically here and do some analysis. So what we're gonna do is creating a pair plot on CTC min, CWC min, CSC min, and token sort ratio. So I have created for these, but feel free to create for more. Okay. The reason we have not created for more because actually we have tried that and they were not looking that great. So the features which were making sense were this while doing the pair plot. So you can see here that it's showing a very nice distribution, right? So if you look at this particular graph, there are some of the places where we are getting a very nicely separated one, like you can see here. So here we can very easily say that in CSC min, and if we compare the first column which is CTC min, so we can very easily write an if else loop and separate them out, right? And you can see not only in this one graph, but in fact in most of the graphs you can see that there is a very nice distribution happening basically, right? Even in this, right, there may be some mix up here and there, like in this. So there is a very nice kind of distribution which is happening, which means that these columns are highly important for our analysis. Now, once we are done with this, let's do some more analysis just to see the distribution. And you can see here that when we created this graph for token sort ratio, you can see here that we do have again a very good distribution of graph in terms of, you can see that this is not exactly overlapping. This is basically there is some overlap but not fully overlap. So we are getting a graph something like this. So it's okay. Basically we can still see that when my token sort ratio is going on the higher end, then basically my duplicate questions are going to increase, right? So this is what we are getting an idea. And if my token sort ratio is on the lower end, then it's going to be kind of my we can see that we have non-duplicate questions. Similarly, we can look at these histograms. We can plot an histogram with this. And you can see that yes, even in histograms we do have a good difference. Like if you look at the median values for both, they have a very distinct highly apart from each other. So we are basically looking at a duplicate portion. So this again reflects that we are going in the right direction and these columns are highly important. Let's do the same thing for the fuzz ratio, and for the fuzz ratio exactly the same thing. What we can notice, there's an overlap, and we can see for the higher value of fuzz ratio we do have again in this case some duplicate values. Now let's do some visualization. When I say visualization, what we're going to do is this is 15 dimensional data, right? So definitely we do have even some basic additional feature which we have added earlier, but let's say if I only consider this 15 advanced feature which we have created, so what we're gonna do is definitely it's impossible for me to visualize that 15 dimensional data. So what I'm gonna do is I'm gonna take up and reduce it to maybe 2 dimension or 3 dimension and see that whether we are going to still make some sense out of it. So here we are going to take up only 5,000 rows because TSNE will not be able to take up so much of data, again as we learned in the TSNE kind of topics. So here we are keeping the method as Barnes said, we are taking iteration as 1000, we are going with respect to components as 2, and basically if you look at this, we have basically computed and converted to 2, and we are basically also kind of plotting this up. So when we are plotting this up, you can see that this is the output. So this is a nice distribution, right? We have converted 15 dimension to 2 dimension, but we can still see that we have a very nicely separated data, like at least in this region is very nicely separated. Here also we have a very good separation. Here also we do. Yeah, there is a small mix up. That's definitely there. But still it's a very good kind of visualization we can do in 2D itself. Now this is telling us very clearly that we do have this model have a very nice sense basically for this. So this is basically telling us that yes, this model is whatever 15 features we have created, they are highly important. So that's also one thing what we get from it. Now again we can do the same thing with let's say 3 dimension, and let's see with 3 dimensions we can also plot a scatter 3D plot, which you might have learned in a machine learning course, that we can also visualize it in a 3D way. This looks more cooler. Let me show you. In fact, you can like move this, even if you want you can kind of zoom, kind of look at the data. You can even kind of keep moving and keep scrolling. So this you can visualize it basically in a 3D format. Okay, so this is a nice box which you are noticing here, which you can visualize it, and very nicely if you hover over it, it will also tell you the points. So again, for us the crux point here is that we can easily visualize by just looking at this data, and that means that all our features which we have created are highly critical, and we're gonna use it for our further analysis when we're gonna apply our model on top of it. So now we are going to apply some featuring on text data with weighted TF-IDF word vector. So remember we discussed about basically this is a part of NLP, which basically comes across TF-IDF and weighted word vector, right? So this is more advanced technique in NLP you must have learned. Now, basically in this TF-IDF weighted word to word vector, what we gonna do is, so there are various ways to do this, but there are a lot of packages being available to you for doing this. So one which basically I have found is very interesting, which is SpaCy package, and in this we have something called as GLOM. Okay, so this is gonna return basically weighted word to vector TF-IDF. That's basically what it's going to return for me. Now, the way it is done, the code is very simple. We will just use the data about train.csv, and you can see that even I have properly put all the comments that from where it is being taken up. It is taken up from Stack Overflow, some idea how to convert it to str and all that. So this code is taken up. So this is question 1, question 2 is duplicate, and we gonna do some feature engineering and gonna convert to it. So you can see that I'm using this TF-IDF vectorizer, transforming it up, creating a dictionary, and using this spaCy load. Once you have imported this part, you can just load it up. In fact, this is very strong. And installing it's very simple. You can just say pip install glove and it's basically take care. So I have done a typo there. It's not glom, it's glove. And basically here it is trained on Wikipedia, so it also kind of takes care of word semantics, which is much more powerful case here. Now once you're done this, then you gonna apply it on question 1 and question 2. So let me give you an intuition that what we are trying to do. So do you remember we do have some simple features. So one part we have is simple features, what we do have earlier. Now the second part was we have 15 features which we have created. So those 15 features I need to add it extra here. Then further to this we had basically the TF word to vec, weighted word to vec for question 1. So this is going to be your TF, basically TF word to vec, which is weighted basically, and this is for question number 2. Okay, this is for question number 2. So this is what will be a final data frame which gonna come up, and then in the last we're gonna have a column which is going to be is duplicate, right? So now you can see that this will become like a proper classification problem for us, which we can work further. So this is what being done in further code. So understanding this code is quite simple. Now you can see that we are just applying in question 1 and walk through it. Similarly, we're going to apply in question 2. We will get 2 columns. So earlier we have all the separated columns. Then after that you will notice that we so you can see that this is for question 2. Earlier one was question 1, and then you can just basically merge all these things together and create a data frame which I explained. My strong suggestion, though I'm just explaining you the main insight of it, but please walk through each and every line of the code. Try to write it up. It's quite simple. The reason I'm not doing it because my focus is to explain you the project, not basically line by line. So my assumption is that through machine learning courses or through NLP courses, you know all these things up. So again, the intention will be completely on project. That's the reason I'm not going line by line. But you have to walk through each and every line and see if you want to change something. Maybe my code, you can just write something better than my code. So please do follow all that. So now we're gonna start building our machine learning model. So again, we have loaded all the package required, and now we're gonna load the data again back. Only difference this time is, so remember this was my final feature. So only difference this time is I'm gonna use the SQLite DB to put it. Now, SQLite is the most lightweighted DB what we have. In fact, in your Android phone, in your iPhone, in basically this is very lightweighted, so it's being basically installed along with it. So now this data we are going to convert it. So also the advantage of using SQLite is that you can also write your SQL query in this case. So your SQL query will also work. I will show you an example with it. So what we have done is we basically loaded this data into my SQLite DB. That's what basically we are doing in this case. Now, if you want to go and read some more of the tutorial, you can always go and read it from here. Now, this is to create the connection. Okay, so this is to help you to create the connection with SQLite, and this is going to check whether the SQLite, basically the table exists or not, right? So that's what it's gonna do. Now we're gonna just create the connection, check the table exists or not, and then work on this. So then after that, you can notice that what we are also doing is we are taking the data and we are limiting it only 10,001 records. So we are not going for lot many data. We are just taking 1 million rows so that we can perform these operations on our basically laptop. So even if you have 4 GB of RAM, you should be able to do it. Otherwise, you may end up with issue, but feel free to use even the whole data if you have no issue with RAMs and all that. Now once you're done, then further to that you can also basically drop the indexes whatever you don't need, the first row especially, and this is the data what you have. Now what basically we have, if you recall, we have the advanced features, we have the simple features, we have word to vec for question 1, word to vec for question 2, that to TDIF for weighted one, and then we have the final column. So now let's convert the string column to numeric column. So if you recall, these were all my data, but we are just converting whichever is categorical, we are converting to numerical. And you can see it here that these initial one, what you're seeing, fuzz ratio and all that, and CWC min, these were your advanced features. Then you can also see that these frequency and all these were your simple features, and these basically are coming out as, this is for question 1, TDIF. So you can see that it's running from 0 to 383, I believe. Let's go and check. So if we keep coming down, you would notice that this will be having somewhere around 383, right? So 0 to 383. So means it have created 384 columns for it. And similarly for question 2 also, it will have the similar number of columns here. Now once this is done, we basically are going to take up the split train test split with 70-30%. That's the simple code written for the same. Once that is done, we can just look at the distribution of the columns data. So for class 1 for the train data, what is the distribution looks like. Then further to this is a simple code. We have seen it even in the last project of medical treatment, that how to create the confusion matrix. So it is gonna create a confusion matrix and precision and recall matrix for you. That's what is being done here. Now let's build a random model, and if you recall from the medical treatment project, we have done exactly same there, because here also the metric required is log loss. And if you recall from the medical treatment project, what we have done there was the log loss can move from 0 to infinity. Now because of this, I don't know if the model which I have, how to compare whether it's a good log loss or bad log loss. So what we will do, we will create a log loss for the random model. Now let's say it comes out to be 0.9. So now my any model which is better than random model should have log loss lesser than 0.9. So the more it is closer to 0, it is better. The more it is near to 0.9, it is a bad model. So that's the same concept we are going to use here. So we are going to create a random model here on the same, and you can notice that it is giving the confusion matrix, which is telling me that basically this is the original class, this is the predicted class. So 9482 are correctly classified in 1 and 45433 are correctly classified in 2, but the remaining all this diagonal part are wrong, like 9493 is a wrong one, similarly 5592 is a wrong one, and that's expected. It's a basically random model, so we cannot even expect that it's going to give me a good log loss. And similarly, sorry, confusion matrix log loss also, you can notice that on test data we are getting around 0.88. Now definitely whatever model we are going to create, that should have a better log loss than this to be adopted. Similarly, you can look at the precision recall, and they are also not sounding that great, and that's obvious because again we do have basically precision recall are generated on the random model, and it's not even expected to have a better value. So this is all about how you can perform on this, and at the same time, as I was telling you, so definitely for solving this project, it's better if you have already solved the medical treatment project, because I have already explained a lot of things there which I'm skipping in this case. So I have explained a lot of concepts from, so I'm just assuming that you have already completed. If not, you can please follow that as well, because that have a lot of beginner explanation in case if you have not covered it from your normal machine learning course, then basically you would have learned it from that project. So I have basically covered what is log loss and so on, and why we are creating random model in detail in that particular project. So please do follow that. So this is how we have generated the random model. Now further to this, we will create some logistic regressions, linear SVM and XGBoost, and we will see that which will give us a better log loss in comparison to this. So we will do that from next lecture. So what we have done last time was we created a random model and we got the log loss around 0.88. So with a random model we have 0.88. Now what we are going to do in this section is that we are going to create different other models, and in fact what I would be working on is mainly logistic regression, linear SVM and XGBoost. Why not other like random forest? Because remember, this is a huge dimensional data. We do have like almost 790 columns, which is huge. So the other algorithms may not work well, but I leave it as a homework activity again for you to basically apply them up and see if you may get a better result. Let me also know. But most likely this is not going to work well. So and it will also take a lot of time. So that's the reason we are sticking towards techniques which towards the algorithm which basically are going to work well with higher dimensional data. So let's start with logistic regression, and here we are also kind of doing a lot of hyperparameter tuning. Now you can see that we have put a lot of comments for understanding all this part, and here we are going to choose an alpha. So this is going to be an hyperparameter. So we're gonna take multiple values of alpha and gonna run our algorithm. So you can notice that I'm using a log loss of log, which means that I'm using a logistic regression. Secondly, I'm using the L2 regularizer, and basically I'm running it for all the alpha values of I. Right. So now when I'm going to run it, remember it's a log loss, and we have learned that if whenever you have to work on log loss, it is always you have to use calibrated classifier so that you can convert anything to a probabilistic format, because remember log loss always require probability. So we are going to use it, we're going to fit the model, predict the probabilities, and this is what we have done for it. Now if you notice, my log loss is coming minimal for this value, which is with 1, and we have also plotted it up. And if you notice, this code is very similar to what we have seen in medical treatment also. There is nothing too special about it. So now you can see that with this graph also, that at the value 1, this is kind of at the minimum part. So now what we will do, we will look at the log loss at the train and the test, and you can notice that both this log loss is coming quite close, which means they are not overfitting. So they are not overfitting. This is what we are. But can I really say this for underfitting? No. Now, if you look at it, we got almost like 0.52. Now, ideally, I should have got near to 0. And this was my random log loss. And I have come somewhere around 0.52. This is not great number, right? I could have come somewhere around 0.3, which would have been far better than this. So since I'm getting around 0.52, there is a chance that maybe my logistic regression might be underfitting, and that's the reason this is giving me this part. Remember, logistic regression have a problem of bias. So you can go with high bias if you are using logistic regression, and that's the reason we have to look at this thing. So what we will do, we got logistic regression which is taking us to 0.52. Let's see if we can get a better number with SVM. But before that, I want you to also notice one more interesting fact here. If you look at the precision and recall, definitely my precision is looking okay, not a big issue. But if I look at my recall, there is a big problem. So this is fine, but this is not fine. Because if you look at it, I am misclassifying almost like 50% of my point, which is definitely a big no-no for me, right? Big no-no for me, because this is a big huge concern. More than 50% of the data we are misclassifying here for class 2. For class 1 we are very good, means definitely this is a very good number, I would say. But the second part is definitely basically a big concern for me. So let's see if my linear SVM is going to help me solving this problem. Now again we're going to apply linear SVM for the hyperparameter tuning. Now same thing, we gonna apply the calibrated classifier. You can see that I'm using this time the penalty as L1, not L2. I'm using the hinge loss, but feel free to change it to L2 and see that what's gonna happen. Now after that you will again do exactly the same code, and this time your log loss is coming minimal here, 0.48, right? And if you even try to infer it from the graph, it looks the same, right? Now let's look at the log loss values. So now we got to this number. This is better than last time, but definitely this is also telling me that we are not overfitting here as well, right? So this looks good. So this is not overfitting. Now let's note down this number here also. So with linear SVM, we are coming to 0.42, right? 0.48, sorry, 0.48. Not a great improvement, but okay. So again, we can notice that there is a chance of overfitting even here, because this is not a great number what we are also getting. Now let's look at the precision and recall. Maybe is that improving for us? Then maybe we can say that, okay, fine, we can still be okay with this model, but we have to first go and see that. Now here, when you see this number, again, we have so many of the misclassification. This is awesome, even working better than your linear SVM, but this is a big concern. Okay, so again, my linear SVM also have a chance of bias, so this can also be an issue for us. Now what is the next solution? Next solution is looking at XGBoost. Let's try that. Now here I have not done much of the hyperparameter tuning. I would like to leave it to you to do that, hyperparameter tuning. So I am having all these values, max depth and everything, and we are passing all these values, creating the matrix, and we are calculating the log loss after training all the model with XGBoost. I need not explain this code because you are quite familiar with XGBoost by now. So you can also write it in a different way, which I have shown you in the class as well of machine learning course, but feel free to use it in whatever way you want. I've just keep on playing with different syntax here and there. Now, if I look at my basically these values, so what is the output? So definitely this is doing a lot of iterations, and remember 790 is an okay data set for XGBoost. Maybe if you have 10,000 columns, then XGBoost may not work well. So keep that in mind. And XGBoost also have a big problem that it can overfit a lot of times. Okay, so you have to be little cautious with XGBoost at that point. Look at my log loss. 0.3435, and the training loss was 0.34. Look at this number. This is a wow for me. So this is the part, and this is my test log loss, right? So looks like this is also not overfitting, which is quite good, right? Because XGBoost have a high chance of overfitting, but looks like this is not overfitting. Secondly, this number is now coming to 0.34, and remember, I told you this point. If we would have come somewhere close to this, we could have said that it's a good model, because now it is quite far from 0.88. On the other hand, any number close to 0.5, I cannot really say that it's too good from the random model. So now this XGBoost is definitely working better in comparison to last one. But definitely remember, we have to look at the precision recall also to basically make sure that we are not doing wrong. This is okay. Now this is not 0.5. This is 0.3, which is okay. So looks like we have improved and this is still excellent. So we have now improved and got this particular solution. And now we can say that in this case, we can particularly choose XGBoost to basically build this model. Now, I would say that please go ahead and build with other classification algorithms, what you are aware of, and see that whether they really give you a better result than this. I've already done a lot of experimentation on this code, and trust me, they're not going to work better. But still, I would like to see if you can come up with something interesting. Means except neural network. I'm not going with neural networks because that is not being taught yet. This will be a deep learning topic, but whatever you have learned from basically from the knowledge perspective of basically for you for machine learning, then I would like you to apply. So this is the solution for Cura project. This is another problem again coming from Kaggle, and this is related to Stack Overflow. I'm pretty sure there will be a lot of people here who might have already used Stack Overflow. In fact, it is kind of called as a powerhouse for engineers. So whenever we get stuck, we simply go to that Stack Overflow and get some particular answers from it. So this is about same problem which basically we are solving. If you are wondering at the moment why the name I have kept it as Facebook recruitment, is it a mistake? No, it's not a mistake. Kaggle have one more interesting property. It's not only that companies come and put their problem, but in fact, a lot of times what company do is they hire from Kaggle, which is the best point, right? So they get basically best data scientists basically through Kaggle as well. So what they do is they create a competition, and who will be the top 10 or top 20 winners, they will call them specifically for interviews with them. So that's what companies do, and Facebook is one of the company who hired from Kaggle in such a way. So now they have put a problem related to Stack Overflow. So they have put this problem, and whoever is the winner is going to get called for the interview. So let's understand that what is this problem statement. So first let me show you up how the problem statement is going to look like. So you can see that this is Facebook recruitment 3. This means that even before this they have also put some more recruitment part, and this is the third time they have come. So you can notice the trust what Facebook is making on Kaggle, which means the company will only do this when they have in the past got the right candidates with more ease and the candidate is performing much better. So then only they will trust the platform to again and again come back and keep on conducting these competitions. So this is the third one, and you can see that this is telling that it's a keyword extraction. Basically, it's and they have clearly mentioned that looking for data scientist position as Facebook. So basically, two successful prior Kaggle connections. What they have done. If you go and search for it, you will get even the previous competitions. Feel free to go ahead and solve them as well. Now, after doing this course, you have all the power to solve all this, right? You need not worry about basically all that. Maybe you can just apply for Facebook in the fourth competition and get a good job. Okay. Anyway, this is the basically one of the part which I pulled up. Now, here you can see that this is basically an individual competition, but you need to work and do that. And they have also mentioned that the position is available in these locations. So, or basically if you are eligible to obtain the visa. So, uh, a lot of times I have seen people, let's say from one country and they want to move to another country. For example, there may be candidates from India and they want to, let's say, relocate themselves to US or UK. So this is a very good opportunity. I have known few people who have actually got into the job like this from one country to another country by using Kaggle. So this, if you basically can crack it, so they have no restriction as such that you should be belonging to these places. It's just that once you clear those rounds, they will help you in all your visa process and get this done. So Facebook had done that in the past, so it's not a big deal if you can easily get basically those things here. Now, what basically I'm gonna do is I'm gonna show you what is Stack Overflow before I go and explain this problem, because it's very important for us to first understand the problem statement. So what we're gonna do in this case, I'm just gonna quickly go to Stack Overflow. This is how it looks like. Now, Stack Overflow, as I said, is a great place where you can go post your questions, or you can answer somebody questions, and maybe people will like it or not like it. So this is what the question all about. So you can see that this is basically a question part. Okay. So you can see that even you can raise a new question from here if you want to. Now, this is basically the body of text question. Basically, this is the body of question. What is the question being asked by that particular person? These are the basically likes being done. So these are the people who have said that we basically are liking this particular question part. These are the tags. This is very important because in this problem statement we want to predict these tags only. So this is basically the tags which we want to predict, and you can see that this is being asked by this particular person and being edited also on this particular day. Now what happens after this is, you can, if you come down, you can see that there will be answers, like two people have answered to this particular question, and you can see that even this answer got like 3 particular likes, and this is the answer. So this is what you have written, and also you can notice that they add a lot of code snippet. It's very important to understand this because the data what we are going to get from Facebook will also have this code snippet. So this will be important for us to understand. So basically this is the part for it. Now let's come down and see a few more things up. So you can see that this is the full answer for it. And this is the person who have written this answer, right? And we can also, it also tells that this person have already answered maybe this many number of questions. And this is very critical for basically Stack Overflow, because if you think about it, let's say this guy whose name is let's say Ruad Van, I hope I'm pronouncing it correctly, Ruad Van. So what basically Facebook can do, let's say they notice that this guy have answered, let's say, most of the answers in C sharp, and this is also a C sharp question. So what Stack Overflow can do is they can just, as soon as this person have posted this question, so maybe once they identify that the tag of this question is C sharp, maybe they can immediately send this question to this particular person, so that there is a more likeliness chances that they will get a quick response, right? So this, from the business perspective, these tags are really important to be identified, that what can be the possible tags here which we can use so that we can accordingly just drive those questions to the right set of people to get the quick answers. So this is how your Stack Overflow looks like. If you're not very familiar to it, you can go to Stack Overflow and create an account and play with it. It's quite simple UI, and you would basically understand that how the questions are being written or how the answers are written. I would definitely encourage you if you have not used it, but I'm pretty sure almost 99% of you must have used Stack Overflow somewhere or the other in the past. So this is the problem statement what we are trying to solve. Now, this problem is little tricky. If it is not tricky, then how come Facebook will be interested in it, right? So we will learn even some new concept in this particular project, because let me give you a hint why I said that this is tricky. So look at this, what we are trying to solve in this case. We are trying to predict this. Till now, what we were solving till now, if you go back and basically look at this, what all we were trying to basically solve till now is, we were looking at, let's say, x was my input, it may be belonging to some real number or whatever, and y was like 0 1 kind of output, right? This is what we were doing. Now there was another kind of questions where we were sometimes like having multi-class kind of problem. So this was like multi-class, right? So this was multi-class. This is simple binary class, two outputs. But in this case, there are things are going to be little different. Here, we are not basically creating this, but in fact, we are outputting some set. What I mean by set? So if y is going to belong to C1, C2, C3, where your C1 could be a set, where C1 could be like C sharp, memory management, and so on. It could be a set now. It is called multi-label problem. multi-label problem. Okay, so C2 can also be a different set, and this set may have different number of elements also. It is not mandatory that the length of C1 will be equal to length of C2. It may be completely two different answers through it. So definitely this is a set which basically we want to output. So it's a little different problem what we have seen till now. So I will come back to this again, explaining in how we can solve multi-label problems using scikit-learn. Scikit-learn have a way of solving it, but it's little tricky to understand that how to do all that. But don't worry, we're gonna cover everything in detail. So this is the part, right? So I already explained you that what is the problem statement, what exactly we have to do in this case. So we given some sort of input data like the heading of the problem or the body of the problem, we would like to predict that what basically is going to be the possible tags for this question. We will understand more detail about this, but before that, let's go back again to our problem statement. So first of all, what I have done, I have basically loaded all this, and you can see that this is a tag prediction problem, and you can basically see from this I have pulled it up directly from Kaggle, so this is not written by me. So this is directly pulled up from there. So as of April 2014, because this recruitment exercise was almost like 4 or 5 years back, it's not like today, so they have given at that time recent data. So basically it is April 2014, there are 4 lakh registered user, and there are so many questions being available to them, and majorly they have noticed that most of the questions are belonging to these categories like Java, JavaScripts, and so on. So this is basically the part. If you want to go and read more about it, you can always do that. So you can go to this problem statement here, and from here you can read about all the details basically from the descriptions and so on. So even you can just read from the discussion forums and all that, and even you have to see this is also kind of having a lot of details what you have to do. And I will also be talking about this is also something important, mean F1 score. This is what will be our evaluation metric. So till now in any of the course we have not seen that, so we have to understand it first, that what exactly is going to be this metric. So we're gonna work on this. Similarly, the data part, if you look at it, data is going to be little huge in this. So what they have given is, you can come to the data part, and the data have like ID, which is going to be ID of the column, title, which is the title of the question, body contains the detailed question part, and the tags, right? This is basically the part we have. But if you look at this data, so this train.zip, right? So this is what you need to download. So this is basically quite big files, just to let you know beforehand. In fact, I have written the size also what I have got at that time. So you can, I will explain you all this. You can see this part. So the size of train.csv was somewhere around 6.75. So they have kept it in a zip format, but when I unzipped it, I got around 6.75 GB, and the test size was almost like 2 GB, right? So, and this many number of rows were there into this problem statement. So let me explain you now basically few more things to it. And what I have done is I have given you some more useful resources where you can go and read about it. And there are some research paper also associated with this problem. I have read almost this paper fully and enjoyed it thoroughly. So feel free, after you understand the problem statement, maybe you can read about it. See, I'm continuously telling this in all the problem statement. Maybe the solution which I'm providing might not be the best solution. Even I have read all this from multiple places. For example, I've given you this links from where I myself have read and kind of try to come up with these solutions. Not only this, even I would like to thank so many GitHub users for with whom I have read so much of solutions from them also. Like if you go and search these GitHub solutions on GitHub, you may get a complete different solution from it. So I keep on reading even their solutions, that what were their thought process. And definitely when I am reading their solutions, I will also get motivated by that, and some portion of their thought process will be added into my code. So wherever it's possible, I have definitely added even this, I've cited them up, but at few places it's just the learning process, so I cannot cite everything up. So, but I've tried my level well to cite up and kind of give them all the due credit which they are supposed to get. So please read it from here. It will really help you also out to understand a lot many other things. This is a nice, I think, 1 hour video which is available on YouTube. So please do follow that. It will really help you to understand that. And you can even read more on the problem statement from here. This is the Kaggle link. Now, what is the real world business objective here? So what we want to get is, this is we want to predict as many tags as possible, and we want to definitely ensure that we should get high precision and high recall. Now, if you have forgotten what is high precision and high recall, please go to my machine learning course and read that well, because I have explained this in very detail there. What is high precision, high recall, and this is really important to understand this problem. Now, here in this case, we want to predict as much tax as possible. Now, second thing is that incorrect tax could impact the customer experience, because it can happen. Let's say there is a tax C1, C2, C3, C4. Let's say this is my tax. Now, let's say I missed out C5 tag. Now, this can be a problem, right? Because maybe I missed out on very important tag C5, which could be a part of it, or maybe I have incorrectly basically put C4 tag here. It was not supposed to be a part of this question. So then also it will destroy the customer experience, because if you think about it, you may be sending this question to wrong person who might not even know about it. So that experience will be going best. So that person might think that why Stack Overflow is going mad, right? So definitely this will be a huge impact on the business if they predict all these tags wrongly. Third thing is no strict latency constraint. So basically in this case, um, it's not like as soon as the customer posts the question, they have to immediately get the answer. If it is taking maybe 1 minute or maybe 2 minutes, right, or maybe 3 minutes, fine, let the model take this much of time to get the output. So maybe the timing may not be a huge constraint, but definitely it should not also happen that it start taking a day or two. Okay, so keep that in mind. So it should not also start taking up too much of use time. So it should be at a level which is acceptable by the community. So that is one thing to keep in mind while solving this particular part. Now let's look at the data. So data I already showed you, it's kind of huge, but this is the detail about the data. And if you look at this part, title is nothing but it's just like a simple heading question, like implementing boundary value analysis in C++ program. This is the body. Now, if you recall, I told you this part that body could have even code. So you can see that there will be a lot of tags coming here and there. And this is a code. But if you come down, there is a text also along with it. You can see that answer should come in the following table format and so on. So basically, there's a text also being involved in this. And if you come down, so this is basically your question part. Now you can see here that there are tags also there, like C++, C. These are the tags basically what being given to you. So this is your data set. Okay, so this is your data set, but what we want from here is, from using this particular data set, we will want to build a model so that in future, if I only know the title of the question, the body of the question, and the basically these details, I should be able to predict that whether what all possible set of tags are there. And remember, the errors can be costly, so it's very important to determine the right set of points. Now, as I told you, this is a multi-label classification problem, and I already explained you what does I mean by multi-case classification problem. Like, it is going to be, if I talk about C1, C2, C3, then C1 could be one set, C2 can be another set. So here we are dealing with set. Okay, and if you want to read more about it on this part, then you can always, this is a link I have given. So this is the scikit-learn library page. Here you can go and read about it. Even I'm gonna come back to this page because there is something which I'm gonna teach you using this page as well. But this is one page which I would recommend you to kind of follow and read about it, because we're gonna use this as a part of this problem. So like as I said, a question on Stack Overflow might be any of the C, pointers, file IO, memory management at the same time, right? So it can be a combination of multiple tags, and we would like to predict it particularly. So this is a multi-class classification, multi-label classification, sorry. So this is not multi-class. So multi-class was completely different from this. So keep this in mind. Do not get confused with this specifically. So multi-class is when you have like multiple values possible in output, and multi-label class is when you have basically multiple values possible, but each value can be a set. Okay, so that's basically is your Y part. So this is all about how you can basically work on this problem. So we just understood what is the problem statement. We understood the data part. We understood that what are the metrics required from it. But now we need to understand that how we will say that this is the best solution or bad solution. What can be the performance metric here and so on. So that will be important to understand, because definitely the performance metric what we were learning till now, like let's say if I say that I want to create high precision or high recall. Now I know how to create high precision for maybe multi-class, but I don't know how to do it for multi-label because it's a set. So definitely those things might not work for me well now. So I need a better solution here. And that is what we are going to work in from the next video lecture, that what is the performance metric here, and then followed by we will talk about few things like Hamming loss and so on. So we will talk about that from next lecture. So now let's talk about that what is going to be my performance metric in this case. Now, as if you go back and read it from this page of Facebook, they have given it like they want to look at this mean F1 score. Now we know what is F1 score, right? If you recall that we do have two things like precision and recall. This is the precision, which is like true positive divided by true positive plus false positive. And this is a recall, which is true positive divided by true positive plus false negative. And we used to compute F1 score by using this method. So we know about F1 score, but what we have to figure out is mean F1 score. Now there are two ways to get that. When you're working on multi-label classification problem, one is your micro average F1 score and second is your macro average. Micro average is more famous, and in fact when Facebook have mentioned that they want mean F1 score, they are referring to a micro average F1 score. A thumb of rule I would suggest you is to always go for micro average score. This is far better than macro. I will explain you what are these and what is the difference between them and why I'm telling you that you should always go for micro F1 score. So I will be explaining you all that. Now, in order to understand this, what we are going to do in this case is, let me quickly go back to my same formula of precision and recall. Now, as I told you, if you go back to precision and recall, this is a precision, right, which is true positive divided by true positive plus false positive. So let me go back here and note it down. So if I say precision, so your precision is true positive divided by true positive plus false positive. This is a simple precision metric. If I have to talk about recall, so my recall is going to be true positive divided by true positive plus false negative. Now, if I have to talk from the perspective of micro F1 score, now I have to go with some difference in formula. Let me explain you what is this formula. So now my precision is going to be turn out to be little different. Now the difference is going to come like if I have to calculate, let's say F1 micro. So this is gonna become the same value, because if you recall my basically my this simple F1, if I have to compute, my F1 was nothing but this is going to be 2 of precision into recall divided by precision plus recall. Okay, this is going to be the case here. Now here basically 2 positive into recall, this is my formula when I had a binary classification problem. Now when I have to compute basically for mean F1 score, there is going to be a small difference. Difference is, instead of calling it as precision, I am gonna give a little different name to it. So if I have to calculate for F1 micro, I would use the same thing 2, but this time I'm gonna say precision of which is coming from micro. I will explain you what is the formula for precision of micro, but before that I just want to tell you that how this F1 micro gonna be little different. Then after that recall micro, so this is also being calculated in a different way. Precision micro plus recall micro. Okay, this is going to be the formula for F1 micro. But now the question is how to get this precision micro and recall micro in this case. To understand this part, again, we're gonna use almost the same thing. So like I'm gonna say precision micro, which is what I have to compute here. Now I will use the same thing. I will use the TP, which is basically gonna be happening here. I'm gonna put TP here also plus FP. Now I'm just gonna tell you what's gonna be the difference gonna come here. I'm just gonna sum this up for all k belonging to C. Now what is basically my C here? C is nothing but my set of all the tag. Set of all the tags. Okay. Now means it could have been like T1, uh, T2 till Tn, right? Because these are like set of all the tags possible in this case. So this is going to be my true positive. So what I'm basically going to do is just going to put this summation for all. Now here also for this summation, I'm going to sum it up for all k belonging to C. Okay, this is what the sum will be for all the component. So this is what going to be the difference here. Similar thing I'm going to do for recall also. So let's say for recall micro, I'm just gonna say here basically the same thing from k belonging to C, true positive. Let me in fact make it little more precise because I'm putting k belong to C, right? So I should definitely put a k because k would be any of this value. I will talk about that. So this tpk and then again k belonging to C, and this is going to be your value tpk plus fnk, right? This is going to be a value in this case. So this is how you will be defining this value. So what I'm basically doing, if you look at this, my basically k is what? My k is belonging to C, right? My k is belonging to C here. And C is nothing but set of all label. So now k could be any of these tags, right? T1, T2, T3 till Tn. K could be any of these tags. So let's say if I pull up any of the tag T2 here, okay. So what I'm doing is for this T2 tag, I will compute basically a true positive. Similarly for T1 tag, I will compute a true positive, and I will also compute the false positive and false negative. So for every tag, I will compute the false positive, true positive and false negative and keep on plugging in this formula, and I will keep on doing this for all the tags which are basically present here. That is what I'm doing. So for each k, I am basically doing nothing but calculating my true positive k, false positive k, and I'm calculating false negative k. And then I'm summing it up according to this particular formula, right? So this is what I am going to do in this particular example. Now, while doing this, there is a very interesting property which also comes up. So let's say I have a T1 tag, which is let's say occurring 90% of the time. Similarly, I have a T2 tag, which is let's say occurring only 1% of the time. Similarly, I have a T3 tag, which is let's say occurring 80% of the time. So you can notice that this is going to be very few, right? So in this case, my true positive for T2 tab is going to be low, right? It's going to be low. So that means what? If I will go in this formula, so the contribution from T2 tag in this is going to be low. So in the micro setting, we are also considering if the class is kind of imbalance. If there are some tags which are occurring very high and some tags which are occurring very low. So this is also kind of considering that into the formula. On the other hand, this is not going to happen when you will go with macro basically system, and that's the reason micro is most preferred, and even in this competition we are being asked to use micro and not macro. So in this case we will be kind of looking at all these values and we will be kind of working on all these tabs part. So you can notice that definitely it micro is taking care of a lot of stuff for us. Now let me explain you what we do for macro. Okay, so I hope now you are very clear how the micro system works. It's going to look at all the tags and calculate the true positive for each tab, false negative for each tab, and so on, right? So we will basically put across the values. On the other hand, what we do basically for macro, I'm talking about macro now. So for macro setting, what we do, let's say I have a tag 1, tag 2 till tag tn. So what we will do, we will compute an F1 score for it. We will compute an F1 score for it. We will compute an F1 score for it. And then what we will do, when I have to compute F1, basically which is going to be your macro, I'm really sorry, macro. So when I have to compute this, I will do an average. Basically this is the length of all the tags. So I have t1 t2 till tn, so there are n values out of it. So then in that case this c will become n, right? Now then after that I will sum up all these values basically for f1 score, because I'm just calculating f1 score for 1, f1 score for 2, this is f1 score for n, like this, right? So this is the same thing. In fact, I should have put k here, right? That would have made more sense. So here in macro setting, if you look closely, we are not considering the points which basically are low side occurring, because this is just taking the f1 score. So due to this, we are not basically considering if any tag is occurring more or less, because we are basically giving the F1 score. So F1 score can still be high if you have low precision and low recall, right? Because there will be other tags which can basically cover that. But here, in this case, that's the reason macro is not preferred, and we are going to go in this competition with micro. Coming back to this, so now with all this explanations what we have done here, so in this case we are going to use the same micro this part, and I've explained you now in detail what to do for it. If you want to go and read more about it, please do follow these links which I have given you. Even scikit-learn do support the basically this micro score. You can even follow this link there. There is also one more interesting loss. This is called as Hamming loss. This is not that popular, but still this is worthy enough for me to talk about it. So I will be talking about this in the next lecture. So now let's discuss about the Hamming loss. Hamming loss is quite simple, where we have, let's say if we have to create the Hamming loss between y hat naught and y hat, where this is your predicted and this is your actual. So the formula for them is going to be this, which is 1 going to be divided by number of dataset samples. Basically this d length means that total number of samples, how many total number of rows you have. Then here we are computing the XOR value for it, for my prediction as well as basically with my real output. And this is length of L, basically, which means that how many total number of labels we do have. Now if you recall, basically how my how my XOR gate kind of works. So XOR works if you have both the values as different. So let's say if I have 0 1, the output for this is going to be 1. If I have 1 0, the output for this is going to be 1. But if I have 0 0 or if I have 1 1, in that case I am always going to get across 0 0. So if they are different, then only I will get 1, otherwise no. So this is going to be the part. Let's take an example to understand this part. So now if in order to take this example, let me create some space for you so that I can probably put down this example easily. So now let's say I do have some sort of Q1, which is, let's say, this. Now here if I have, let's say, question 1 which have the tag, let's say, T1, T2, T3 and T4. Let's say this is the situation. Now this is my actual output. Okay, what I predicted from here is, let's say my prediction is, so here basically let's say my value was 1. So how we are keeping it, let's say in Y I have the tag present T1, so I will put 1 for it. I have T2 also present, I will put 1 for it. I have T3 also present, I will put 1 for it. And I have this value there, which is I'm gonna put 0 for it. Okay, this is not there, let's say. Now what I predicted is, let's say, is completely opposite, 0 0 0 1. Okay, I predicted completely opposite. Now if you compute the XOR value of theirs, so it's gonna be 1, right? So for the first part it's going to be 1. So for when I did this comparison, now after that it's going to be again 1 here. This is also 1, this is also 1. So if you count it, 1 plus 1 plus 1, which is going to be 4. Now how many total values I have? 4. So 4 divided by 4 is going to be 1, right? So you can think of it like XOR is like how many mismatches are happening for you. So if the mismatches are more, definitely this value is going to be higher. If the mismatches is less, then definitely it's going to be lower value. So that's the reason it is called as loss. Okay, so we want this value to be as low as possible. So this is about the Hamming loss part, which I brought up in the last part. Now what we are going to do next is we are going to work on our data set, and further we gonna use it for our further application. So in order to solve this problem, I'm going to use something called as SQLite. Now this is just to add a different flavor so that you can understand how you can work with SQLite. Just to let you know, like for example, you might be aware of databases like Oracle, you have Microsoft Server, right? So many databases are there. Similarly, this SQLite is very lightweighted database. In fact, if you basically think about in your Android phone, you save your contacts. So you must be thinking where those contacts will be getting saved. So there is a DB which is involved there, right? So that DB will be always SQLite. Similarly, in your MacBook, in your iOS, everywhere SQLite is used because it's a very lightweighted database to solve this purpose. So, and the very good news here is that SQLite is comes default with Python. So we need not even install something separately for doing it. And the advantage of using SQLite is that you can now write your SQL queries. And if you are not an expert in SQL and all, don't need to worry about that. You can just follow this link, W3 School. And in this project, I'm not going to use very complex query. It will be very simple queries. So if you just spend half an hour here, you will be all good with SQL knowledge. Okay, this is just something you can follow up here and then come back to this project. But if you know it, then you will really understand things quite well. Now, in this case, what I'm going to do is, so first of all, we got the data from Kaggle in CSV format, right? So we have the train.csv format there. So what we are going to do, we are going to read this data and basically going to dump all this data to something in SQLite. So I'm going to put this complete data into SQLite DB so that I can write my SQL database. So this is what exactly this line of code is doing for me. So you can see that df.toSQL. I'm basically writing all this data and keep on appending each row one by one. So that is what I'm doing in the first line of code. So once I'm done with this, then after that I'm just basically counting the total number of rows being present there. So now I'm just basically connecting to my DB which I have created, and you can see that I'm just hitting a simple SQL query, select count asterisk from data, and saving it in num rows. And now I'm just printing this num rows, right? That's it. So now when I'm printing it up, so this came out that it have almost like so many records being available, almost 6 lakh record, and the time which it took to count this is, you can see that it's so low, right? Almost 1 minute 15 seconds. Imagine this was a huge data. So SQLite kind of a very fast way kind of go and kind of can read all this data. Now going ahead, the first thing we have to look at is, do we have any sort of duplicate data with us? Now in order to do that, it's quite simple to achieve this. And always remember, whenever you are working on any database, for example, you can see here also I'm working, whenever you are opening any database connection, always make a good habit of closing it as well, otherwise you may end up with a lot of issues. So always remember to close it. It's a good programming practice, you have to do that. By default the connection might not get closed, so you have to do it explicitly on your own. Now going ahead, now I'm going to check for the duplicate. So first I'm again going to create a connection with train.db, and now what I'm going to do, I'm going to hit this query, read underscore SQL.query, and if you see this particular query, what I'm doing here, so I am basically doing a count, select title, body, tag, count as string, as I'm just giving a name to it from this data set, by but basically from this but group by, I'm doing it for all these three. Because wherever all these three are commonly occurring, then do a count of it. So if there will be any duplicate records kind of thing coming up here, that will be caught. And this basically took me almost like 4 minutes 33 seconds to get the result. Definitely the data was huge, but it gave me this result. Now if we see this data, so this is how the data will look like. So now you can see here that let's say this part of the question is only occurring one time, but this part of the question, if you look at, is occurring two times. Okay, so means this is maybe a duplicate question. Similarly, there are lot many other duplicate question, and if I count that how many duplicate questions we got, it's almost a huge number, which is like 30% of the values are duplicate. So it's always a good practice to remove the duplicate. Otherwise, how they will be useful for me in analysis, right? It's just the same data getting repeated twice. So we need to remove them. But before that, we can do some more analysis. So what we are doing is we are just checking here that so there are this many number of questions which is occurring single time. These many number of questions are occurring two times. These many number of questions are occurring three times. And in fact, there are basically 5 questions which are occurring 6 times also. So which is basically a huge time of duplication, but it's not too much high number, like 5 questions are only occurring. So what we would like to do is, so let's say if there is any question which is or basically there is any part which basically question is there which is, let's say, occurring two times, so maybe we would like to retain one of the question and remove the remaining part, right? So that is what I would be doing in the next steps. So what I'm going to do now, before even now cleaning this up, I'm also going to count that how many total number of tags are also here. So for example, here you can see that I have a tag C++ and C. So this is basically going to be counted as 2. Similarly, here we have C sharp, we have Silverlight, data binding, and basically we have columns. So this is basically 4 number of tags. So this is also one thing which we are doing a count. So we are doing nothing but you can see this code. We are looking at only tags, and we have applied the lambda function, which is just looking at the splitting part and looking at the length of this basically code. So this is how we are basically kind of counting all this value, and you can see here it is showing me up the values of tag count. Now once we have done that, you can also see here very interesting trend. So there are basically the number of questions where 3 tags were there are 3 in number. Sorry, this is a number. This is the number of questions where we have basically these tags occurring so many number of times. Similarly, you can also notice this part, like you can see that there are questions even where we have 5 tags, and this is a high number, not very high if you comparatively see from here, but this is also high in number. So this is a nice insight what we are getting from the data. Now let's create the data basically with no duplicate. So once we will do this up, then we're gonna store the no duplicate part into my DB again. And once we save it up, now we're gonna use that not no duplicate kind of data. So I'm gonna use this no duplicate data, and from here I'm just pulling out this tag data, means I'm just pulling out this tags from here so that I can use it later. And at the same time, I'm just removing any unnecessary column from here. And for doing this, it took very less time. As you can see that though the data was huge, but now after removing almost 30% of the data, we are not left with too much as well. So we are pretty much good with this particular data. So now after this, we have to perform some analysis on my tags and all, which we are going to do in further lecture. So now we are going to perform some analysis on my tags. So first, let's look at how many total number of unique tags we do have. So while writing this code, we figured out that total we have almost this many number of data points, which is total number of rows, and this many unique tags we have, like 42,048. So this many total number of unique tags is what we do have. Now let's go and check few things. Let's say if I want to look at maybe few tags here, so I'm just looking at 10 tags. So you can see that one tag is A, one is app, one is ASP.NET, which is ASP XOR, bash profile, and so on. So these are basically my tag names, which is present as a part of it. Now let's do some analysis, and what we want to do is we would like with this code to count that each tag is occurring how many times. So let's say I would like to count that dot a tag is occurring how many times. So we got 18. Similarly, dot app is occurring 37 times. Bash profile tag is occurring 138 times, and so on, right? And basically you can get a whole list by looking at this code, this simple code to get that. Now what we're gonna do, all this what we got, I am gonna sort all these things. So for example, you might notice that C sharp, let's say, will be the highest tag, and maybe this is occurring, let's say, 2 million times, right? So let's say, similarly, let's say C language is the next one, and let's say it is occurring 1.9 million times. Similarly, Java, let's say, is the next one, then it is 1.78 million times, and so on. So let's say this is will be in the sorted order, in the descending order. So this is what I would like to do it, because I do want to plot it. So what I have done is, all the tags what I have, I just plot it into this graph. So you can see that most of the tags are kind of occurring highest number of times, and then it is just dropping very steeply, right? So it's very even difficult to decide that how steeply it is really coming down. So because the way it is coming down is really fast. Now, so what we can do in this case, how about if we reduce the number of tags? So let's not look at all, but how about if we look at only the 10,000 tags, and see that with 10,000 tags how it looks like? Can we really see the steepness of the curve in that case? So when we did it with 10,000 tags, we can still notice that it's huge, right? You can see it here. Like the first tag is occurring like 3 million times, and the second is 44,000 something, and it is kind of coming down, right? But at the same time, the main thing which you want to notice is that I cannot derive any steepness in this curve, because it is coming down so fast. The initial value was so high, and then suddenly it is coming down so fast. Now, what about reducing it to even more? Let's say instead of 10,000, let's do it with only 1,000 tags. So when I'm doing it with 1,000 tags, now I have a little bit of smoothness coming up, but still it is not that great. At least this is giving me an idea that maybe at tag 200, after 200 it's going more down, but at 200 the number is still low. So that's what this is giving me a good insight. So let's go down even a little more, maybe with 500 tags. So with 500 tags, it is looking a little better. So now definitely there's a steep, but we can still make something out of it. Now, in order to make more meaningful out of it, what I did is, this time I created only for 100 tags. And what I'm looking at, top 100 tags. So this is basically top 100 tags which are in the descending order. So what I'm doing is, I have basically put this quartile values. Like you can see that any yellow color is like fifth percentile. This is just to give you an insight. So this is going to be like fifth percentile. So let's say this is like my fifth percentile, this is my 10th percentile, this is my 15th percentile, this is my 20th percentile. You can see that the next one, 25, we have marked it as a different color. So this is just to kind of help you in reading this particular graph. You can see that after that it is dropping and they're pretty close. But initial term, if you look at, this is basically kind of at a higher level, right? So this is just to read the quantile in the graph itself. This is being basically performed. Now let's look at a few more analysis. So in this case, we have added a code just to get some more insight. So we can see that 153 tags are used more than like 10,000 times. That's what the analysis we got. And 14 tags are used more than like, again, more than like 1 lakh times. So this is the analysis. So there are total 153 tags which are more than 10,000 times. 14 tags are used more than 1 lakh tags. Means the initial 14, if you look at, they will be like more than 1 lakh. And the most frequent one is C sharp, which is occurring the maximum number of time. And since some tag are occurring, so in this case, if we look at it, the tags is completely imbalanced, right? Some tags are occurring very high and some tags are occurring very low. So in this case, in this case, definitely my macro F1 score will make more sense, because if we go with macro, right, though that was not considering that weighted part. So that's the reason it will make more sense for us if we go with micro. Now let's do some more analysis. So now the next part, what we will do is, we basically are looking at like total number of, maximum number of times a tag is occurring. So like in one question, there are maximum 5 tags coming up. Similarly, minimum and average is what we have calculated. So the minimum is definitely one. Maybe somebody have created a question and he just put one tag. And maybe the average number of tags per question is like on average per question how many tags we are getting. So almost like 2.89 is that number. Now let's plot it in a histogram, and we can notice that the most frequent one as expected was like 2 and 3 tags per question. So like usually the people who are tagging, they are adding like 2 or 3 tags mostly, not more than that. But yes, there are few questions where people are even tagging like 5 particular tags in a question. So that's what is also occurring in this case. So what are our observations? So we are just going to put all these things in detail here. So we will see that maximum number of tags per question is 5, minimum is 1, average is 2899. Most of the questions are having 2 or 3 tags, right? So the same thing which I explained you. Now, let's look at the basically let's do a word cloud. And doing a word cloud is very simple, right? There's just one line of code what I have to write to generate this. And this how we kind of interpret this word cloud is, so the bigger the size of any word, that is occurring the most number of times. For example, you can see here C sharp. This is the very big size, right? That means this is occurring too much many number of times. Java, Android, Python, Windows, JavaScript, iPhone, PHP, jQuery, CSS, arrays. So you can see that these are the tags which are like bigger in size. That means they are basically being coming up at the maximum part. So this gives a very nice visual representation rather than looking at the raw data. You can just look at the word cloud, and this is going to give you very nice representation of all this. Now, the time taken for doing this was around a good time, or not much, means 5 seconds. So it is quite quick given that the data was huge. Now, with this, can make out that we have C Sharp, Java, PHP, ASP.NET, JavaScript. They are occurring the most number of times. Now, let's plot those 20 highest tags and put it in a histogram. So you can see here that C sharp being the maximum as expected. Then after that we have Java, then we have PHP, we have JavaScript, we have so on, right? So these are tags. But one thing to kind of look at is most of the tags which are occurring here are belonging to programming language. So this reflect that Stack Overflow, people who do programming, they kind of love Stack Overflow more in comparison to anything else. So you can see that this is the analysis, because you can even read it from this tag. They are all mostly programming languages. Now C sharp is the most frequently programming language, and means most frequently used programming language, and Android, iOS, Linux and Windows are among the highest operating systems. So that's also the tags coming up in this case. So maybe you can infer it like this as well. Sometime you might have noticed that they say that in 2018 this is the best trending programming language which worked, right? So maybe one criteria could be that they can look at the Stack Overflow data for, let's say, for that particular year, and can see that which was the that programming language which was most getting used, or which was most being asked kind of by the user, and using that maybe they can infer that basically this is one of the programming language which was preferred in year 2018. Right? So this is a very nice way of coming out with that information. Now let's come down and let's do some cleaning and pre-processing of the data. Now in pre-processing, I'm going to follow few steps. Again, here I'm assuming that you already know NLP, okay, natural language processing part, because all these things are being used from that particular section. So here I have a sample of like 1 million data points. So I do have in fact more. I had I think 4 million, but I have just chosen 1 million because again, if I use all the data set, it's going to be very huge. And the problem is I'm using i7 system with 32 GB RAM. And you have already noticed the previous step where I took almost 47 minutes to do the pre-processing. Yes, if you can go up and see that code, it took almost 47 minutes to do the pre-processing only. And basically I'm going to show you that. Now, so that was happened when I use 1 million of the record and some limited tags. But if I do take all of that, maybe it may end up with a lot of number of hours. Definitely you can use it if you have a high-end laptop and you have the patience to wait for it. But most of the times I'm getting the feedback from students that when they have to wait for longer, they just lose the interest because they can't do anything. The notebook get hanged. So that's the reason I have taken the sample, but feel free to take more data set as per your basically the computation power. Now, second thing what we need is to separate out the code snippet. Remember the body section? So we have some code from it. So maybe we want to pull it out separately. That might help us relatively further. Third thing is we would like to remove the special characters from questions. If there is any special character in title and question, but not in the code. Code we will not touch, because in code maybe somebody might have written hash include. Now you can think that this is a special character, but this is not, right? Because it's a part of the code. But other than code, definitely if there's any special character I would like to remove. Remove all the stop word, but don't remove C, because C is one of the programming language. So don't remove that particular language from here. Remove all the HTML tags. So this is one thing we're gonna do, and convert all the characters into lowercase. Definitely that's required so that we can distinguish the things. And we are going to use snowball stemmer to stem the words, right? So like somebody have written, let's say running, or somebody have written run. They both are same, but they are being basically will treat it as a separately. So what stemmer will do is they will it will bring into the common format, right? So it will treat both of the words as the same thing. That's what is the role of the stemmer in this case. So in order to do that, I have written some function. So first is to strip the HTML tags. So let's say I would, and you can see that I'm just using this regular expression things to do that. It's very simple. Second function is very simple, just creating the connection with the DB function I've written. I've written a function which is going to create a table for me. I'm creating a function which is just going to confirm if the table exists. If it do not exist, then create it, otherwise throw an error, something like that. Then creating a database table, that's what is the next function to do that. So this is quite simple, right? It's just the functions being created so that it makes my life easy. Now all these functions we are just calling it up. Okay, so that's the part we are doing it here. And basically we are looking at the data, and to do this it took me almost 6 minutes 32 seconds. It's not that huge, it's okay. Now after that, we are going to do the processing part. Remember, I have written all the steps. So it's very simple code. If you know an LP, you might have used it, all these things. For example, if you recall, I want to take out the code from it. So I'm using some regular expressions to get that done, right? So even a lot of things like I'm converting the questions to lowercase and all that part. So all that thing, you can just go through this code. I'm not walking through it because it's again a simple NLP term what we are using here. Now, if you come down, this is the processing we have done on the huge data. And as I was telling you before, it took us 47 minutes. That's the reason I have reduced on number of data sets. If I would have taken the whole data set, it would have been a disaster for me at least, right? Because on my machine, maybe it would have taken much more time on this. But feel free to use the whole data set if you have the computation power. So that's not a problem. Now after that, we are just committing all the things and just kind of closing the connections. And once we have done, this is the pre-processing part. We are just printing out the results after it. So you can see that this is the result coming up. So you can see that some of the words got stemmed. So because let's say this is define, this is basically nothing but define. So maybe you will not be able to understand it, because the reason is some places it might be written as defining, somewhere it is written as define. So I'm just bringing everything to a same scale. Okay, so that's the reason you are seeing all these things into this format. Let's come down. So this is the data, and now if you see and basically combine all this data together and view it. So this is the ID, this is the question which we have. Like for example, you can see here also, this is the stemmer thing, like resize, and you can see that all the stop words and everything got removed, everything in lowercase, everything is very nicely coming up. And these are the tags what we do have. And if we look at some more things related to it, like come down. So this is telling that I now am left with this many number of samples, and I have total 2 dimensions being available with me. So this is basically how we can perform some sort of pre-processing and so on. And after this, now we are all ready to work on the modeling section. So now we need to really understand that how we gonna determine this multi-label problem, right? So now this is the problem which we have to solve, multi-label. How we solve it using my models? That's a question for us. Now the thing is that can we somehow convert it to either a binary classification problem, or if we can somehow convert this to multi-class problem? If I can somehow do this conversion, then it will make my life simple. But the question is how we can do this sort of thing. Now, in order to do that, there are a lot of articles you will find across internet, but this is one of the article from Analytics Vidya, which I love it personally. And I love it because they have basically kind of created a lot of nice diagrams, which is a lot easy for us to understand. That's the whole reason why I'm basically going to use Analytics Vidya in this case. And if you go through them, actually they write a lot of nice blogs. I kind of love reading them, to be frank. So I would also suggest you can read more in detail on this. So let me explain you what are the techniques what we do have to solve this. Number one is binary relevance technique. Let me explain you what is being done. In fact, this is the most popular technique which is used, and also it's also called as one versus rest. One versus rest. And the idea behind this is, let's say if we have data, so let's say I have 5 rows. These are rows. Okay, I have 5 rows, and these are tags. Okay, so now what we are doing is we are putting the data for it. Let me give you an explanation for this. What exactly this is doing? Let's say I have a question Q1. Okay, which have, let's say, a tag T1 comma T2. Let's say I have a question Q2 which have the tags, let's say, T2 comma T3. I have a question Q3 which have the tag, let's say, T1 comma T4. Let's say this is my tags. Now in this case, if I look at it, how many total tags I have? T1, T2, T3, T4. Let's say these are the 3 questions. Let's assume that these are my rows where I have the data. So now in this case, what I'm going to do, for the first one, I will create basically 3 columns. Okay. So let's say this is column T1, this is column T2, this is column T3, and this is column T4. Now I'm going to keep the data here. So let's say in this case, I have T1. Yes, I have T1. I have T2. Yes, I have T2. This will be 0. This is not there, right? So let me do it for the same thing for this. So T1, T2, T3, T4. So this is going to be 0, 1, 1, 0. Let's do the same thing here. So in this case, 1, 0, 0, 1. Like this, I can arrange my data and keep up all these things into the column wise. So that is what being done here. Okay, this is the data representation here. So you can think of this y1, y2, y3, y4 as, let's say, tags, okay, which we had in our question. So now in this case, maybe the first row point, I have maybe y2, y3 available. In the second row, I might have only y1 available. In third row, maybe I have only y2 available. In fourth row, I might have only y1 and y4 available. And in fifth row, I might have only y4 available. So this is my way of representing it. Now, what I'm going to do with this, I'm going to split this data into this format. So what I'm going to do, I'm going to divide it into 4 parts because I have 4 different columns. So for each of this value, I'm going to repeat it 4 times. So like I'm create one with X with Y1. Then I will create X with Y2 with this row. Then I will create X with Y3 with this row. Then I will have X with Y4. Now, if you look at it, now what basically it means, I can basically create 4 different models and then basically can work on them, right? Because now if you look at it, it becomes like a binary classification problem for me, right? So that's what we can do with this, but there's a challenge here. Remember, in our problem statement, we have 40k tags, right? Now 40, to do it for 42k tags, building 42k models is going to be almost very complicated, right? Because this is equivalent to, if you have a smaller data, smaller set of these set values, then it works pretty good. And in few cases actually do not even work well. Let me tell you, in our problem statement, when we tried actually using it, it failed for some reason, and then we have to put some sort of different logic to get this done. I will explain you at that time why it failed, because actually we will have a very sparse data. Anyway, we will explain that at that later point. But this is basically going to be like very rigorous in terms of creating number of models. And to do this, it's quite simple. So to do this, we do have, just like we have a scikit-learn package, similarly we also have a scikit sk multi-learn package. Okay, that is also another package what we have. And in this we do have something called as binary relevance class, and we can just pass it on here, and you can see the remaining code is very simple. So it will just take care of everything for you and get the results done for you. So this is a very simple way of working on this part. Now the second thing is, you can see the second method. This is called as classifier chain. This is in fact interesting way. So basically here again the data set is same, but what we are doing is, so let's say the first one what we got is from x1 we got, let's say, 0. So we have pulled up only this much. But for the second one what we are doing, we are taking these two as my input point, and then we are predicting for the last one. Then after that we are kind of creating a chain here. Okay, so we are like one model, we got the output, then we take the output as the input for the second one, and then we move on. Definitely this is not helping us with the last problem what we had earlier with the binary one. So definitely here also we are creating a lot of models in this case, but at the same time this is sometime useful. Let me tell you where this is going to be useful. So when, let's say, in whenever we have a situation like, if one kind of tag is having a dependency on another tag, for example, let's say this y1 is C, okay, or C++. So let's say if there's a question on C, there's a high chance that maybe the question might be related to pointers. So because generally the questions on C, if you look at in Stack Overflow also, you will notice that most of the questions will be related to pointers in that case. So that is what basically is being explained in this case, that maybe you can have a chain in that case to get that kind of dependency along with it. So this is also quite simple to be done. So if you look at this, again, we do have a same package, scikit multi-learn package. And here also we can just use classifier chain and get this done. It's quite simple to do it in the programmatic format. Now, after this, we have something called as label power. This is quite an interesting idea, in fact. So here what we kind of do is, so let's say you can see this part, like this is one part, right? Now I will give, like, whenever the value is, let's say, coming as 0, 1, 1, 0, I'm gonna give it a number, let's say 1. Okay, think of it like a pattern, which I'm giving it a number 1. So I'm basically writing it up. X1, I have given the number 1 to it. Now let's look at this. This pattern is different from the first pattern, right? So I will give it a number 2. So let's give it a number 2. Okay. So now let's look at the third one. This is a different pattern from above both two. So let's give it a number 3. So I've written down here also as number 3. Let's look at the fourth part. Now this is exactly same with pattern 1, 0, 1, 1, 0. So I will keep the name same number 1 for it. So I will give the same number 1 for it. Okay. Now let's look at this. This is different. So let's give it a number 4. Let's look at this. This is again similar to my 3. So I will give again the number 3. So now if you look at it, this becomes my multi-class classification problem. Now this looks good, but there can be still a problem with this. Problem is, if this columns are going to increase, then in that case the number of unique values are going to also increase, right? Now in that case we can end up with problems, right? Because it may be possible that we have lot of multi-class problem. Maybe I have 1 to 100 of different multi-class problem coming up, and maybe few of them are only occurring once, only one. So basically there will be very less amount of data for them to be trained on. So that can be a big problem in this case. So definitely we would not, this is not being too much used, especially wherever the uniqueness will be there, means there are too many of the set values too huge. Then again we can end up with a lot of issues. Fourth one is, and again using this is very simple. Again you can see that we can just use label power set, and we are again using it from scikit multi-learn package, and this is going to give us the result. Now there is one interesting approach which is called as adaptive algorithm. What is adaptive algorithm? Adaptive algorithm is like basically where you can change your corresponding algorithm itself. For example, let's say I have a KNN algorithm, right? K nearest neighbor. I can convert it by using ML So there can be a different algorithm which takes care of label class values. And the way it works is, you can think of it something like this. So let me draw a diagram for you to make things more clear. So maybe let's say you have a query point xq here. Now let's say this is being surrounded by x1, x2, maybe x3 and x4 and so on. Let's say now we have tags being attached to it. So let's say x1 have tag like t1, t2, t3. Let's say x2 have tags like T1, T2, T4, and similarly we have tags like T1, T5, T6. Let's add another tag to it. Let's say X4 have tag like T1, T3, T5, right? Now if I have to compute it for XQ, so one way to think of for XQ would be like T1 is occurring in almost all my nearby neighbors. So definitely I can be assured that XQ will have a tag also T1. But if you look at, let's say let's say here I have not T5 but T7. Now T7 is not occurring anywhere nearby, so I would not put T7 in this case. Now I can look at T2. Maybe T2 is also occurring, or T3 is also occurring like 2-3 times. So I can maybe put T2, T3 like that. So in this case, what I'm basically doing is I'm looking at all the tags and then basically saying that which are the tags which are more in number near to me, and maybe we can decide some sort of rule that if, let's say, I have three or more than three tags near to me, I will choose it, otherwise I will reject it. Like T7 was occurring only once, I have rejected it. T1 was occurring 4 times, I accepted it, right? So like that I can put some strategy, and based on that I can do it. So this is basically a nice way of getting this particularly done. Okay, so this is the algorithm way, that how you can work with your algorithm and get this particular part. So after we have understood all the methods from analytics vidya, which I have just explained you up, now it's the time to convert into this format which is in front of you, right? So this is the format we would like to convert. Now you would notice this is very simply done by this two line of code. So we're gonna use this count vectorizer to get this done for us. But there will be a problem. We can't really use this much of amount of tags what we do have. So we need basically some better method to solve this. So one way is, let's say, basically I have a set C, right? So let's say I have a set C which contains some data. So for this, let's say I have a question one which contains the tag T1, T2, T3, and I have a question Q2 which contains the tag T4, T5, T6, right? Now, let's say these are my tags. Now what I would do, so if I look at my set C, this is going to be T1, T2, T3, T4, T5, and T6. These are my tag sets which we're gonna have. Now in this case, what we will do, we will, instead of taking this set, we will choose a different subset, which is going to be a subset of this C. C dash, a subset of C. So let's say by some strategy we have chosen that we're gonna take T1 and T2. And we will do that actually with the help of frequency count. Like the more the higher frequency, we would like to retain it. Otherwise, we would not like to retain it. So we will choose like that. So in that case, how this conversion is going to happen here? So in that case, Q1 will be left with maybe T1, T2, T3 will be removed from here. And Q2 question, if I talk about, this will become null because there's nothing left with it. So as I said, what we will do, maybe out of these stats, because we already have the sorted frequency of this, so maybe we can decide that we will go only with these two. But while doing this, we have noticed that we will lose few questions, because when I lose this question, I have to remove this question now, right? I don't have any tag left for it. So we would like to minimize it as well. And we will see in Python how we can basically achieve this kind of scenario. So what we can do is we can look at the tags what we want to choose here. So this is a simple code to do that, because I need to take a sample of my tags. And this is the question explain part which I've done. So let me explain you what basically this is gonna do for me. So in order to achieve this, let me show you up. So this is the graph which we wanted to basically get. That's the reason we have basically written all these functions. So if you look at this, there's a mistake here. Actually, this should be percentage of question converted partially, and this is going to be number of tag. So if we look at this, this tells me that if I choose 500 tags, okay, top 500 tags, I will be able to cover 90% of my questions. And if I choose, let's say somewhere around basically 5,500, then in that case, it will cover almost like 99% of the question, right? This is 99% and this is 90%. Definitely 99% looks better for now, because we will lose only 1% of the question if we just reduce the tag. And if you look at it, definitely it is better than having 40k, because 40k is a huge number if I compare with 5,500, right? But we will try this, but let me tell you, the computationally it will be very expensive, and it may happen that we may not be able to use this well. If it's going to happen, we can always fall back to 500, where we will lose 10% of the question, but we will be okay with it because we can go ahead with it. If you have a high computation system, very high computation system, feel free to use all the tags also. But then you will end up creating 42,000 model, remember, which we learned in the last previous lecture. So you have to choose wisely that what you want to go for. So 99% seems to be a safe choice, going with 5,500 models. And let's see that how this gonna behave. So what we're gonna do, so as we have seen that with 5,500, we will be retaining 99.04% of question. Now, number of questions which are not covered means what are those 10% of questions which will be like 9,599. Now, if I look at the basically number of tags in the sample, this is going to be basically 35,422, and basically this is a remember earlier it was pretty huge. Now it is reduced up to a good limit, and number of tags what we have taken is 5,500, which is almost like 15% of my original one. Right? That's what we have basically chosen. Now, one interesting thing to note here, while I have to do the split of train and test. Actually, if you were a software engineer in Stack Overflow, the best idea would have been if I have a timestamp with me, because if you're working basically in Stack Overflow company, you would also have the data with the timestamp. Right now, Facebook have not given us, but definitely with Stack Overflow, this data will be there. So when I'm going to do this train test splitting, it will be a good idea to do it time based. Maybe the some part here will be your train initial time and the latest part will be your test. This will make more sense. Why? Because think about it. Maybe I have yesterday some language like ASP 1.0. Today ASP.NET 2.0 is released. So questions will start happening for 2.0. So let's say earlier it was iPhone, some older version. Now a new version came up. So the questions will also come up for the new version. So a new tag will be created for it. So in Stack Overflow, the tags will keep on getting generated dynamically for us. So in that case, it would have made more sense to use temporal kind of splitting rather than doing a random split. But since Facebook have not provided us the timestamp, we will simply go with our random split, which is 80-20 split we are going to take up. So you can see that we are taking this much of records in my train set, and this is my number of columns we have. You can see that it's just 5,500. This is the number of tags what we have chosen in this case. Now let's go ahead and look at the how we're gonna visualize our data. Now in order to do this, what we're gonna do, so the first step is we are going to compute the TDIF vectorizer for this. So basically again we need to apply all this data, right? And we are taking the maximum feature as 20,000. But one thing to note here is we are going to also and this TDIF we are doing it on question and all that. Okay, this is done on questions part. So here in this case, we are choosing the n-gram as 1 and 2 and 3. Only 3 and n-grams what we are choosing in this case. Now we are going to convert it to vectorizer, and after that this in fact was a huge data in itself, and it took me almost like 9.5 means almost around 10 minutes that I've taken to do that. Now, when we did that, means when we applied this TDIF on basically on my question set, now definitely my number of columns are going to increase. So you can see that in the basically this part in the X portion, we got 88,244 columns because now we have applied the TDIF on that. Then similar, but this is my input rows. Input rows will remain same. There's not going to be any change. On the Y part, it will remain as 5,500 column because we have chosen that many number of labels in the last case. But number of rows will remain same as it is, right? So that's what is you can see in these 4 cases. Now, what we are going to do next. So this is interesting. What we had done was that analytics with their thing, which I have just shown you in the last lecture, I tried to use after that basically this multi-class. And what basically the problem happened was, so this skmultilearn we used, and then I end up with some memory errors. Okay, so I kept on trying to figure out that what went wrong because looks like it was pretty decent. So this was the memory error I was getting. So it was a decent one. So I was not able to get what exactly is going wrong in this case. So then I went over some Stack Exchange and basically learned from there that this issue is being faced by a lot of people. And this issue happens because this data what you have, input data what you have, is very sparse. And this SK multi-learn is only good to work with respect to dense data. It is not good with respect to your basically sparse data. And that's the reason you are ending up with this memoria, because it will work with respect to so many columns, right? It have to create so many models and all that. So we have very high chance that you will end up with basically the memory error. Even if you have a huge computation system, you can still end up with such sort of errors, because if you go to this post, you will read a lot of people who have mentioned that even they have a very high processing power, it still didn't work for them. So then what we can do with this, so we just commented out this code, but I've shown you the code so that if you want to use, you can use it. But at the same time, we what even this community have said that they're going to fix it in the latest version, and they have not done it at least by the time I'm recording this video. So we cannot just stop this case study. So we will use our own method, which we have basically came up with to basically solve this problem in that case. But yes, if this method was available and working without this bug, then it would have been a better method to use here. So maybe in future, at the time when you are viewing this video, maybe this error is fixed out. So you might want to just kind of uncomment this code and see if this works for you. If yes, then comment out my later code, and then you can use this and see that a better performance coming up. In fact, it will be good. You can just post it on the discussion forum, and I would love to again change it back. So that is something which I can do it. So the technique what we are going to use now would be to use this one versus rest classifier. So again, this is going to be very rigorous, right? Because we're gonna use one versus rest, so it's gonna still create like lot many models for me. And if you recall, we have 5,500 basically different columns in Y. Now, when we do this, you can notice that one thing is definitely even the F1 score is not coming out to be good. If you recall, we want this value more closer to 1, but that's not happening here. So definitely we need to do some sort of imputation to see that how we can improve it. But at the same time, one point to notice, when I run this on 8 core 32 GB RAM system with all the CPU being involved, let me show you up. I have used all the CPU involved. I have used njobs is equal to -1, which means I'm using all my CPU. So it's parallelly computing. It took me almost 6 to 7 hours. If you have a lower end system, you may end up with almost a whole day to get this basically part. So definitely we cannot use it because of the computation power issue here. So what can be one possible solution is, how about if we reduce it to 0, instead of 1 million, we take a 0.5 million, means half a million. And second thing what we can do is, remember we took 5,500 columns. So rather than that, how about if we go with only 500 columns? So that can be one hack for it. But we have to also improve the F1 score, right? So how we can do that? So one nice strategy is, how about if I give more weightage to title, maybe 3 times more weightage to title than on the body part, which means that I'm going to just kind of repeat the title 3 times. So that's what, if we can somehow do it, definitely it's going to help me with this. So in order to do this part, what we are going to do is, we gonna basically create all these regressions, and you can see that I have just created all the, and even you can create this models like this, like you can save your classifier, you can dump your models in this manner. So that's also very nice way. It will create a pickle file for you. Now going ahead, you can see that I'm just using 500 tags, half of the million data, and more weight. So I'm going to repeat now almost every step, which I have done it last time. Only difference is I'm just going to add more weight to all this. So you will notice that all these steps I have done it last time. Okay. So even pre-processing, you can see that I'm just adding one more statement, give more weightage to title. But other than that, everything is set. You can see that code and everything is getting repeated here, right? So everything else is same. It's just that I'm just adding basically the weightage part and all, and doing nothing basically extra in this part. And you can see that this time it have not taken 47 minutes, it have taken 23. And then I have to repeat everything up here. I have to do the processing, which we have learned it already. Then we have to save the data to database. This was the data, we have seen it, dimensions, number of sample what we have. Then basically we are just selecting the 500 tags, And we have seen it. Okay, this is nothing new. Even this part I have shown you already. This should be all again percent of it, and we're gonna choose 500 here. And when we have chosen 500, we are basically left with these data points. Now after that, we have to apply the TF-IDF part, which also we have done it last time, and then we will be left with this many number of columns and rows. You can see that definitely it's lesser than the last time. So after that, we can apply our part. So this is the first step which we have basically tried, and this kind of worked for us. So further to this, now I'm gonna apply my logistic regression again and see that how it's gonna work. Now a definite question which might be coming in your mind, that why I started with logistic regression, why not going with random forest or basically any other modeling. So the thing is, this random forest and decision tree and all may not work with such a high dimension, because remember, we have a very high dimension here. Linear SVM might work, but this will be very similar to logistic. So I leave it to you. If you want, you can apply linear SVM also. We have already learned how to do it in the previous case studies. So maybe you can apply linear SVM here, and even if you want, you can try random forest. It may not work that well, and you need a good computation there. But definitely, from the perspective of linear logistic regression, this will make more sense. So that's the reason I'm going with this technology. So in the next lecture, I will show you that how to complete this particular section. So now in this case, we gonna choose basically now on the smaller model. So if you recall from the previous lecture, we discussed that we're gonna choose only 500,000 of records, and we're gonna choose only 500 column in this case. So that's what we're gonna choose in this particular part. So we're gonna build a logistic regression again with the L1 regularizer. And when we build this with a smaller data which we have just basically created, you would notice that this time we got a little better F1 score. So if you recall from the last time, we were getting some 0.37, but now I'm getting around 0.44. This is kind of a better than previous basically time. So this is basically the way you can see this data, and I'm just dumping this model. One more thing which we could have done here is basically I could have changed even the regularizer if I want. This you can try it up, but this time I'm also using basically SGD classifier. So that's one thing. I just basically changed a few things here, and it just improved a little bit. So as I said, it just a kind of an experiment what I was doing, but you can also play around with multiple things, like change the regularizer from L2 L1 to L2, though it's going to be more complex in that time. But you can see that I got a little improvement in this case, right? Now this is the final model what you could have. Now as I said, why I'm choosing still only the logistic regression, why not the linear SVM? So definitely I could have gone to even the SVM and all that. In fact, SGD classifier with respect to SVM would have been even better, but I want to leave this as a homework activity. Secondly, I want you to even change from maybe 123 gram to 1234 gram and see that how it's gonna behave differently. And you can also use it with grid search and see that how you're gonna get the result. So all this I want to leave it as an assignment to you. So this project, though I have explained you completely, but you still can do some work and give me a better performance. So I want you to basically complete this exercise and put in discussion forum for other students to tell you up that they have got this when they have added this part. So I want to see all that happening in the discussion forum. So this kind of completes this project of Stack Overflow. So you have noticed that it was a very interesting project. We started with a lot of data. We did a lot of basically data cleaning, then building the model. We have used TF-IDF, lot many things we have used in this single project.